So I invite Petya to the stage, and also our colleagues Olivier, ESRIN, and Mathieu. Thank you.
Thanks very much, Francesca, and good morning, everyone. So here we are at day 3 of URBIS. We had a lot of exchanges these past 2 days. We heard very insightful and practical applications developed for cities on a variety of topics. So today we would like to start the day with a short reflection from our practitioners as to their takeaways from the sessions that they themselves moderated. Before this, maybe I have a short reflection also from my side and what would inform our follow-up actions, because at the end this conference is also a step in the overall path and conversation about how to link the two communities, how to bring those solutions to a number of cities, and to go away from the single city, single application, single product, then scale up. And to me, it's actually like a chain, which I did not have before coming to this conference. A chain that we start with the data, and Earth observation is what provides the data. You, as scientists, researchers, make sense of the data into applications that work on the ground. And I think even the word application and the fact it's applicable, turning data and making sense of it needs to be applicable for those city practitioners to use it for their realities. Because what the realities of cities are that they need to react, they need to plan, they need to respond, and this is all into a larger context of strategies, achieving targets that are driven by their national governments, but also by larger policy, as in Europe and within the EU, by the also priorities. And we have, since yesterday, a proposal for a new commission coming with new priorities, where space, a development of space technology for the competitiveness of Europe, for the security, but also for driving this green, sustainable agenda at all levels, is very strongly grounded. So there is a lot of potential for this, and I wish that we all see it in its entire complexity, starting from the data to the high-level policies and how these link. So when we speak about the application side, I would turn first to ESRIN, followed by Mathieu, Olivier, and Marcos Wansky join us to give us their short snapshot reflection of some takeaways from yesterday and what possibly we can do once we are all back home. Thank you so much, and ESRIN, please.
Yes, well, what I did is going back to my introductory statements to the heat stress and soil sealing session, reorder a little bit the ideas and incorporate some new elements. With the perspective of an organization as Tecnalia, which is a little bit in between the final end user, the public administration, and the upstream developments, to say it somehow. Well, we need transferable and scalable workflows and applications, as we were saying yesterday, combining different data sources with different resolutions, qualities, and complementary information. I will not go into detail, but with the aim of informing decision-making, taking into account that there are complex and sophisticated analysis, as we were saying as we were seeing during the whole day yesterday, combining in situ sensors with the approach of calibration, LiDAR, real-time data, modeling, artificial intelligence, data cubes, Dockers, DIAs, which is a complex landscape for the end user. Interesting elements yesterday with differentiations from form and function in urban environments. Also, other approaches like indoor versus outdoor comfort or stress or vulnerabilities, other type of variables like a sky view factor. So the complexity in the type of analysis that is being developed is high and sometimes not comprehensible for the end user. Taking into account that end user perspective implies addressing in decision making to time frames, so operational decisions, early warning system versus the long-term planning, and I think that was a really interesting contribution yesterday in one of the sessions, and taking also into account that being able to analyze scenarios, ex-ante analysis, and ex-post effectiveness of interventions is a little bit the framework of that decision-making of the end users. Going back again to the authoritative data sources, allowing benchmarking at European level, that is crucial, that is important for certain type of decision-making, but that has to be combined with enough granularity as the required resolution for local decision-making at local level and in urban areas. That implies that there are huge challenges related to interoperability and integration of data. And this is the new contribution from yesterday, which is related to the necessary orchestration of the offer to the end users. The co-production, which was mentioned also in different interventions yesterday, is important. So having the real end user engage in the development is important, but there is a need of generous, and I intentionally included that word, a coordination of research and harmonization of those validated approaches. Managing the offer to the end users, and that transition from basic research to applied research and to operational services, differentiating what is under development and what is already operational, because the end user in the end is quite confused which tool, which approach, which provider to choose for a given analysis. And there is a need of clarifying and mapping all that constellation of data and products, depending on the size of the city, depending on the purpose, and therefore which better fits for that purpose, and the best available technologies. And that mapping is crucial. And that could be quite related to offering and providing capacity building to those end users, not only mapping what is available, but also installing capacities for the use of all that offer. And I think that in that respect, it could be differentiated, generalized use of certain products. Yesterday we were talking, cadastre is something which is already installed in whatever public local authority, and therefore in Earth observations, perhaps a first stage is generalizing certain products which could be universal, to say it somehow, versus specialized services which could be, or those capacities could be in intermediary organizations at regional level or other type of stakeholders. And that could be.
Thank you very much, ESRIN. I don't have anything to say after that. So as regional agency, we are not like cities, but we are not also national level, and we are not EO community. So we are just in between all these actors. So the work with cities is really interesting, and because you have so many topics to address, sometimes it's hard to take a step back. Our goal stays to help all the territories, including smaller rural areas that maybe we have not mentioned too much the last few days, because it's hard to have access to those territories and to match their needs. But our goal as regional agency is also to address those territories and to help them. So that's one main issue that I have still after leaving today, but I'm sure that we will together find solutions for those territories. One point that I found very interesting yesterday is the fact that you are always asking yourself questions on your own practice, saying, okay, am I using the right tool? Am I using the right process? Am I using the right database? Is it a public or a commercial data set? Depending on the precision you need, depending on how easy it is to update your data. So I found it really interesting, because I think it's really promising for our two worlds of cities, practitioners, and your world to come together to find a new way to help the territories. Another thing that I found really interesting yesterday that is a little bit meeting my world is the fact that all those data, they need some training for the cities to take into account what you built, to take into their daily practice the tools that you are offering. And I think that on the training side and what goes around the tools, what goes around the data set that you produce, we have still some progress to do, but I already saw in some presentation that you are taking this into account and that it's working most of the time, hopefully. And so I'm just maybe inviting us to do just what ESRIN just said about going on operational level, going further on after the R&D, after the research, after the innovation, going further on how can I make this usable on a daily basis by the territories, by the small territories who have low resources, low financial power, and still need to make their transition happen. So I personally think that we are going in the right direction, that this event is a proof that we are going in the right direction, that we still have us, public actors around cities, and you, EU community, we still have work to do to understand each other and to match our strength and also our weaknesses. But we have room in our practitioners' practices for satellite data, and I'm sure that it will help us accelerate our transition, our environmental and energy transition. Thank you.
Hello, so I don't think I will be really original following my two colleagues. So I think that capacity building and how the research tools are bring to end users and policymakers is the key. In the frame of the project, we have to go until that end users can take control of what they are currently using. So it means not only be able for the end users to use the tools or to use the data, but also to know what they can do with the data and to know what they can't do with the data. So in my domain, which is air quality, we need to know all the uncertainties of the tools and all the data. So this is the first point. The second point is we have to be in a mixing domain approach. Dealing with climate change and air quality, we must be in a co-benefit approach. And I saw lots of things about the impact, for example, of green domains on an effect on thermal comfort for people, but what's the result for air pollution? There could be counter effects of that kind of stuff. So we must mix the domains. We must have a global approach for all the Earth observation treatment of data. And the last point deals with the data access. We saw that the cost for Earth observation data is not the same when we are dealing from the global scale to the local scale. The cost is much more important. And when we in the session yesterday, we saw some kind of downscaling approach could be really interesting in terms of data cost. So these are the 3 points I would like to share with you.
So a big thank you to ESRIN, Mathieu, and Olivier, and also to Marcus that you have co-chaired with us yesterday's session. This is a bit of a new thing for us in ESA to have non-technical people co-chairing with us. So thank you for being the first ones. I mean, we've been working a lot with users on single projects, but now we're trying to make it a bit more structured. So thank you for being part of this and for sharing your reflections. Thank you again. So now I welcome Nicolas Longepé, who is going to chair the next session on the hackathon Map Your City, AI for EO.
Okay, let's start this session. I hope that you can share the slide here, please. So my name is Nicolas Longepé. I'm the one organizing this Map Your City challenge, which is organized as part of this AI for EO challenge project. So I'd like to present first the team behind the scene, and while there are some people from the field, so myself and also Nikolaos, this project is also supported and led by NovaSpace, and actually the data platform is operated and managed by URBIS. Then all the data pre-processing, street view images that you will see later has been processed by Minders, which is a startup based in Switzerland. Maybe you may recall the talk you've seen yesterday about the B.ai project. And as well, Synergize providing some support in data preparations. So today, we have about 30 minutes. The idea is to introduce the challenge that we propose to the community, and then we'll announce the top 3 winners, and each of them will actually present a bit and highlight their solutions. So the challenge, what was this about? The idea of this challenge was to estimate the age of the building. So the age of the building referred to the time elapsed since the building was built. So obviously it can reveal many things: architectural trends, construction techniques, design philosophies, and so on and so forth. So why do we want to estimate this parameter? Because, well, of course, this is a proxy of safety, integrity of building structure. That can be as well useful to calculate the renovation and the preservation needs. And generally speaking, that support as well urban city planning. There are many problems associated to building age. While usually this information is being done manually, this is very hard to get some ground truth somehow. It's time consuming, tedious to get, and also cities might change, so on and so forth. So here, the idea of this challenge was to merge perspective. We offer to the community street view images that you can see on the left, and we offer together with them top view provided by orthophotos and also Sentinel-2, as you will see later. And from that information that you can see on the top left, the idea was to estimate the age of the building. Because as you can see on this example on the top bottom right, over Vienna, for instance, that information is very, you have like the age of the building, which is well referenced over Vienna, but you don't have the age information coming from Ubuco database. So this information somehow is lacking to some aspect. Just to give you some other example, here you see on the left probably a building which is, well, very likely in Northern Europe, probably Netherlands or Denmark, if I may recall correctly. And here you can see in the center the top view image, and the building is actually exactly the one which is at the center. So here we propose to estimate again the age from these two types of information. So the challenge was open from April to July this year. So we provided a data set with Street View that was collected by Minders and Mapillary. We did some specific process to make sure that the Street View is perfectly, let's say, orthogonal to the facade of the building. We collocated that information with top view orthophoto at 50 centimeters and also space-borne imagery from Pléiades. And we collocated that with Sentinel-2, the closest in time, with the 12 bands at 10-meter resolution, as you may know, and 20 meters. So we provide these three types of information for 35,000 locations in five countries in Europe, 19 cities. We totally anonymized the countries and the cities, so the participant didn't know about the location or whatsoever. The challenge proposed was to estimate the classes. I mean, it was a classification perspective. So it was a bit, let's say, the funny part for deep learning nerds. And as a matrix to estimate actually the different solution, we use the mean producer accuracy, which is a diagonal of the confusion matrix. This is a classification scheme again. We take the confusion matrix, and we took the average of the diagonal. At the end, we had more than 100 teams registered and 30 teams which were very active in the leaderboard and in the submissions. And as you can see on the bottom right, we offered some cash prize. So today, I will not give the checks to the people, but they will receive in the coming days the amounts that you can see here. So this was the content of this Map Your City challenge. And now, actually, we'll go to the announcement of the winning teams, starting with the third place. And actually, the third place goes to Caroline Arnold, which is with yeah, she's here already. Hey, good morning. I hope that you can speak.
Yes, I hope you can hear me.
If you can increase a bit the volume, I guess.
Yes, I can try.
Or maybe on our side for the technical rooms, if you can increase a bit. So please, Caroline, if you can introduce yourself and maybe present in few words while you have about 5 minutes to present your solution, that would be great. Thanks a lot.
Yes, thank you. First of all, thank you for the organizers for awarding me the third prize here. I'm Carolina Arnold. I'm an AI consultant with the German Climate Computing Center in Germany. And if you can go to the next slide, I will start with my presentation. Are you advancing the slides? I only see the remote screen sharing.
Just a second, we'll fix that.
Sure.
We are working on this, so no worries.
That looks great. Yeah, so the model that I built is a robust multimodal model because, as you mentioned, sometimes the street view image is missing during inference, so the model should not fail in this case. What I did is that each of the modalities was encoded separately with a pre-trained vision transformer. That's a computer vision network that you can essentially download. It's been pre-trained on a large collection of images, and we just fine-tune it for our specific case. So applying these vision transformers separately on each of the modalities, that yields a so-called embedding vector, which is just a list of numbers. From these, I calculate an attention weight that tells me how important each of the modalities is in order to yield the final prediction. Then I go ahead and calculate the weighted sum of all of these embedding vectors and proceed with classification to tell which of the 7 classes the building belongs to. The nice thing is that this works also if 1 or 2 modalities are missing during inference, because the weighted sum can always be calculated if at least 1 modality is there. Can you go to the next slide, please?
Yeah, it takes a bit of time, but we'll move the slide now.
Yeah, sure.
Here we go. Go
All
ahead.
right. So I just want to highlight some of the ideas that help to improve the score here. I use pi-fold cross-validation, so I split 20% of the samples off for validation, use the remaining 80% for training. And I did this in so-called stratified group split. So I grouped all the samples by the city ID, and I tried to create the splits such that the class label distribution is comparable across all 5 splits. In inference, I used the majority class of the 5 folds, if there was one. So in the first example, you see the class 1 was predicted 3 times, I would use that. If there was a tie, I would use the more probable class. So the class 0, that is the oldest building age, it's far more likely than the other classes. In the second example, I would use this one. That actually helped increase the score a lot. In the end, I also figured out for the purpose of the challenge, it makes more sense to train 2 distinct models. So I trained a special model for the samples that do not have a street view image during tests. I trained with all the data first and then fine-tuned on country-specific samples. So in the end, I have 5 models per country, essentially. We applied more or less standard data augmentation, flipping the images, applying color jitter, and from the Sentinel-2 images, I calculated a vegetation, water, and building index to help identify where building zones are, actually. We used weighted cross-entropy loss with the class weights and album optimizer with the standard parameters. And if you go to my last slide, I can show you some results. Excellent. So I set aside a development set with around 1,000 samples with a distribution of countries that matches the one in the test set. So that allows me to tell whether my solution is performing good or not. The mean average precision that I can report here was around 0.72 for samples that have the street view image available and around 0.6 for the other samples. These values are slightly higher than what I achieved in the end on the public leaderboard and also on the private leaderboard. And for evaluation, I always calculated this confusion matrix. So in the confusion matrix, if an entry is on the diagonal, that means that the class was correctly predicted. And you see this is most often the case. So overall, the results were satisfying. But sometimes neighboring classes are confused for each other because it's apparently hard to tell whether a building is 30 or 40 years old. And that's it already. If you like to check out my code, here's the link to GitHub. Also, if you'd like to get in touch, you can do it via GitHub. Thanks.
Okay, many thanks. And congratulations, Caroline, for getting this 3rd place. So now it's time to announce the 2nd place. And actually the 2nd place goes to Tran Wanba from Japan and Axel Space. So I don't know if you're online. Yeah, I'll switch. My turn. I don't know if Tran is online and then can present himself and give a short talk about his solution. In any case, congratulations. Okay, just a second. We'll set the screen for you, and then you can start speaking. it's muted. Yeah, you are muted indeed. But still, we are trying to fix a bit the setting because we don't see the slides anymore. Yeah, we knew it was a complex setting. Okay, now we see your slides. So we cannot see anymore. Meanwhile, can we check the audio? Can you speak and say some few words?
Hello.
Okay, great. At least we hear you. Well, I guess you can start now. We see the slides, so go ahead. Thanks.
Hello, everyone. Thank you for organizing this amazing competition. I am Bartran. I am currently working in Exospace as a computer vision software engineer. My company is manufacturing small satellite and also construct and providing satellite imagery. And as you can see here, here's the approach of mine. For this contest, I designed two types of classification model. The type 1 is training and inference is done on full modalities. And type 2, the training is done on full modalities, but the inference is only on two top view modalities. For this, I also integrate the countries index as one-hot representation as country categorical feature for both type 1 and type 2. For type 1 here, for the three inputs from the three modalities are fetched into the three encoders of the same feature extractor models and fused by late fusions. I experienced with two types of methods for the late fusion here. The first one is the simple feature concatenation. Here, the features after average pooling are concatenated together with the country categorical feature and then fetched into the final FC layer. And the other late fusion method is inspired by the one of the paper that I listed in the below of the slide. That is here the features before average pooling are fused by the method to learn the importance of the feature, and then finally fetch into a convolution layer, and then later concatenated with the country categorical feature. For the type 1, 4 models were trained, and the ensemble of the 4 models was used as the final model. I tried to make the models as light as possible, so I used the efficient and lightweight encoders as the efficient net and mobile pitch. Finally, 2 models were used with the feature concatenation and 2 were used with the geometric fusion approach. Can you please go to the next slide? For the type 2, the training is done on full modalities, but the inference is done on only 2 top view modalities. And 2 important techniques were used to address the problem of the missing modalities. The first one is the input dropout. So during training, the street view images were randomly replaced with only 0 images with the probability of 0.5. And the other techniques is inspired by a paper in CVPR 2023 that I listed in the below of the slide here, that is share specific feature modeling. So for this modeling, each modality input will be assigned a specific separate encoder. And we have 3 specific encoders, but the street view and VHR modality inputs were further assigned a shared encoder. The purpose of this share encoder is to align the feature of the VHR and Street View after being passed through this encoder, and during the inference, the aligned VHR feature will be used as a Street View feature. And for this approach, I also use two auxiliary losses. The first one is the L1 loss to align the shared features, and the cross entropy loss to differentiate between the specific features. For this type 2 only feature concatenation approach was used. And two models were trained for this type 2. The first model for the share, I use the EfficientNet V2 B1, and the for model 2, I use EfficientNet V2 B2. That is also lightweight encoder. Can you please go to the next? Here is some of the list of the optimization parameters and techniques that I used. I used the PyChalk and PyTorch Lightning framework for this contest. And also for the collection of the encoders, I used the team library. So here is some parameters about the optimization. I used a single GPU, a batch size of 5 with the accumulated grade batches of 8. And so effective batch size is about 40 and 48. As we know that the data set has some problem with the imbalance label. So I use the focal loss with label smoothing to address this problem. I also use the divide the trained data set into stratified 10 poles. Each of the model would leave out one different fold for validation, and the remaining will be used for training. I also use some data processing and augmentation from Argumentation's library that I can list in here. And also one of the techniques to improve the accuracy of the model is the test time augmentation that I listed here, some of it for type 1 and type 2. So finally, for type 1, I have a total of 32 patterns for ensampling. And for type 2, I have a finally total 8 patterns for ensampling. Yeah, thank you very much.
Thank you very much. Thanks a lot, Bertrand. It was fantastic. Thanks a lot for participating. So let's move to the first place. And now it's time to announce the final winner of this Map Your City Challenge. And we have the pleasure actually to host the winner now at the URBIS conference coming from South Korea. And I'd like to invite on stage Eric. Please come on side. Thanks.
Okay, thank you for inviting us to such a great workshop. My name is Jaewon Park, and I work for a company called Telepix, which is located in the South Korea. Please show next slide. Yes. Okay, it's worked. Thank you. Instead of my colleague Hagai, he's actually the leader of this approach, but some network issues he cannot join us. So I'm going to explain this. They tested certain models which summarize as follows. Used the approach integrated the final submission. They actually try to use the cross-validation works and then split the data for each country. And then pre-processing works, normalization worked, and then histogram equalization works. And then some for augmentations, random rotate flip they used, and then each of the sources of images, Street View, and then it has different augmentation techniques. So encoders was selected EVA 2, and then Ruben also used. Please, next slide. Okay. I see. key factors to increase the performance was powerful encoder, actually. Bigger was actually has a tend to be better, and it's important to choose right pre-trained model. Yes, these architecture is the actually summarization of the previous slides, and then each images are flow into the encoder, and then end of it there is an ensemble layer. So prediction is it. Okay, then this is actually our first best solution for the hackathon. We thought that the label of this data is predicting the year the building was constructed. Therefore, the distance between labels indicates the time distance when the building were constructed, and there was a correlation, it means. So class 6, which means that the building was constructed after 2006, is closer to class 5 than the class 0. The reflecting correlation according to the label was the key approach. So the first approach I took was to convert the hard encoded labels into the soft labels following the Gaussian distribution, and then trying to guide the learning to occur with the KL divergences. As a result, I could obtain a small improvement in a public board score. However, because the distance of the converted labels is manually adjusted by the variant parameter, there's a cost and uncertainty involved in this part. To overcome this, finally, I used the label smoothing techniques to achieve the best public board score improvement. The architecture is actually simpler. Each model did not start it with this form from the beginning. Rather, we just started in a very complex form, as previous participants have shown. There was an attempt to group all encoders into ensemble layers, infer them at once. But that attempt was also highly successful, but the structure became more complex. The complexity of a validation also increased twice or 5 times more. So I get back to the simple. To be more specific, the use of k-folds and the division of test images into cases made the experimental design very complicated when using such methods. So I removed all the ensemble layers and optimized the individual encoders to reach their optimal points. Looking back after the competition, I believe that this decision helped prevent the overall architecture from the overfitting to the public board. So if we had frozen the old encoders, that has a high chance to be overfitted. So next, I tested different ensemble methods. There were methods using hard porting or soft porting techniques. We could try to divide the ensemble into stages, but ultimately it was designed as you see. Each orange box represents a model, and it was designed to average all the losses for each test cases. So here is the final model specification. The model primarily used EVA classification model, which is a transformer-based model that recently achieved state-of-the-art performance on the ImageNet classification. It actively encodes features without falling into local traps. The final model, as you can see, looks so simple, but as many of you know, there are countless experiments and combinations hidden behind it. After training each model to its optimal point, we were able to identify the best result through the soft-porting ensemble of predictions by made each model. Yes. Oh. Okay, thank you for inviting us. Such a great place. And then I would like to express my gratitude to all the staff organizing such a great challenge. Thank you for your attention. Thank you.
Before to close, I'd like to congratulate again our colleagues from Telepix coming from South Korea, especially for this event and this URBIS workshop. So thanks again. I appreciate it. So as a conclusion, I mean, I will not spend too much time here, but actually the conclusion of this challenge is that, yes, we can estimate the age of the building only with satellite imagery. Of course, you need some contextual information to train on, but we have seen that with multimodal approach, having the street view a bit and doing the inference without the street view is still seems to be feasible. Here you see the mean producer accuracy that we get. I mean, obviously, if we use all the modalities, it gets close to 73% for 7 classes, which is decent. We get lower without any street view images. 60% over 7 classes, which is, well, better than random at least. And I think this is pretty decent in terms of performance. I think there are still many perspectives on these activities. I'd like to understand personally what is the benefit of adding Sentinel-2 over the autophoto. Probably the Sentinel-2 images have limited to no impact into the classification scheme. I'd like to understand as well, maybe with some explainable AI techniques like GradCam or whatsoever, what are the features that give some classification, that give the classes at the end from the top view images. I'd like to understand as well if those techniques can be generalized over different cities, over different countries. Here we provided only 5 countries, 19 cities, so it's a bit limited, obviously. So obviously there's a question of generalizations. And how to improve the performance, maybe adding some additional contextual information, but yeah, the door is open. Thanks a lot for attending this Map Your City session, and I wish you a very great day and enjoy. Thanks.
Thank you, Nicolas, again. And so just a quick word. You have 2 sessions now in parallel. One happening here on assessing and mitigating urban hazards, subsidence, water risks, and flooding. We will have Thomas Kemper and Petya Pishmishiva chairing. Instead, in the Magellan room, we have the session on commercial EO data and services for urban contexts. So if you're interested in that one, I kindly ask you to go very quickly over there, chaired by Peggy Fisher and Roman Esteve. Just a kind reminder for who is presenting in Magellan in the course of today. Please bring your presentation in Magellan and the technicians will upload it. Thank you. I leave the floor to Petya and Thomas.
So good morning. I think we get going slowly in order to have enough time for all the interesting presentations, and I really hope also for some discussion. after each of the presentations. So we will try to make sure that presenters stick to their 10 minutes to allow some questions. And I already invite you to really be attentive and ask questions after each of the presentations. I a bit ad hoc decided to put up this web page here. It's the Global Disaster Alerting and Coordination system that the JRC is running together with the United Nations. And it gives you a bit an overview of the global situation in terms of major disasters. So being in Europe, we all read the news of what is happening in Austria, in Romania, Czechia, Poland, etc. That's one part, but there's so much more going on. You see this a little bit here on this screen, where you have a lot of flooding also in the Sahel area currently. So big parts of Sudan are still flooded. It's not even mentioned here. On top of the conflict they are facing there. So it's really not only in Europe, but just to give you this overview of what we're talking about. And Earth observation plays an important role in providing ad hoc information on the situation on the ground that is very essential. And this is really the topic of today's session, where we will have 6 presentations addressing various aspects. We have some presentations that will look into subsidence. We will have some presentations related to flooding, some multi-hazard assessments. So I think it's quite interesting. And with that, I think I would hand over to Petja, my co-chair.
Thank you, Thomas, and hello again. Thank you for staying with this session. A very quick and very fresh update and related to what we will discuss and the situation that we face in Europe, with almost 1/3 of Europe being affected severely by floodings. And because we speak about the work or mostly you do on using Earth observation to inform cities, support them in their planning and inform policy making. As we speak, actually it started at 9 o'clock in the European Parliament session in Strasbourg that's taking place this week. Actually, the European Parliament is discussing the adoption of a resolution directly related to the floodings that are taking place in Europe. And in this resolution, these are very important developments, because I will read only a sentence of the part of this resolution regarding regional policy. Calling on the Commission to provide technical and financial support to regions disproportionately affected by natural disasters exacerbated by climate change. Further, strongly supports strengthening of EU investments in next multi-annual financial framework to regional and local resilience, notably under cohesion policy and so forth. It's a long document, but it's just to note that at the policy level, there is a strong acknowledgement of the impacts of climate change, of the fact that regional and local authorities need to be supported. And when they are supported and there are enabling conditions for them to act, then the services that you provide can be plugged in, and for them to use and more effectively make sense of the complex urban environment they have to address. So I think it's a very relevant session, and we are acutely reminded of this through the realities that happen. So maybe we start with our first presentation.
Yes, that is a presentation that is not even in the program, so we are very much ad hoc here, taking that into account. I have the pleasure to have Lorenzo Solari here, who will present to us the European Ground Motion Service of Copernicus. The floor is yours, 10 minutes.
Thank you, and thanks for having me at the last very moment. But let's say I will try to give you an overview of what the EGMS can do in terms of urban areas. And as you can see here, I have the title of my poster, that is How Can 13 Billion Measurement of the Ground Motion Help Manage Natural Hazard in Urban Areas. And I will try to answer to this question by the way, I'm Lorenzo Solari. I work for the Copernicus Land Monitoring Service at the EA, and we are the entity responsible for many Copernicus services and many Copernicus products that you have over Europe. So the, I thought it was touch screen, anyway. The reply to this is that we have many ways to address ground motion, and especially in urban areas is where this kind of data, it's for INSAR data in general, shine, because we have a very high density of points. We can reach nowadays a precision of the measurement that can be in the line of the 1 millimeter per year, if not lower. Here you see many examples that come from different cities in Europe. And we have, for example, an airport in Stockholm is the old airport of Stockholm. Nowadays you have Arlanda that is to the north, but this one was the one active in the 90s and before. You have the new port structure of A Coruña in Spain. You have the Oslo train station in Norway, and an example from Amsterdam. And of course, we can do this over many cities because we have a continental wide map of ground motion. And here in the QR code, you have the access to our EGMS Explorer. The color scale is on purpose left, let's say, with a lot of green because I exaggerated the scale bar, but you will see that when you assess it, you will find many different things moving around. And why are we doing this data? Why are we providing this data to users? First of all, and thanks that Thomas mentioned, let's say, the number of events that we have right now in the world, we also have to remember to look into the future. This is an overview from the UCRA report that the EA published early in 2024, and you have, let's say, all these arrows going to future, let's say, worsening of situation. And of course, when we speak of ground motion, and especially, for example, of landslide, the amount of heavy events in Europe, as we are seeing right now, are a factor, and we can measure their presence. But also, it's very relevant to say that the EGMS is a clear product that is driven by user requirements and by a well-defined user community. It's a process that started around 2014, 2015, with later a group of geologists of all over geological service in Europe, backed up by the scientific community and the industry that wrote a white paper that went then to the Commission, and then the Commission decided to adopt this product, and then went, let's say, on my table, and then it went back to users. So it's a really powerful example of a bottom-up process. Just a few words about the EGMS. As it is, it's, as said, an element of the CLMS portfolio, and it is produced only from Sentinel-1 radar data. So it's a pure radar-derived product. It's based on satellite interferometry. I'm sure that many of you know the technique, but in summary, it's essentially we create a big stack of images, and then we calculate the motion of the pixels between one image and the other. It's easier to say than doing it. It's quite a gigantic effort, but what we can have is this high-density continental scale of map of ground motion. And it's important to remember that each measurement point has a value of ground motion velocity, millimeter per year. This is what you visualize right now in the map of subsidence for the center of Rome. And when you click on a point, you will retrieve a time series for the last 5 years. Right now, we are producing the data set that is 2019-2023, and we will publish it by mid-October. And as you can see, for example, in Rome, we have many green points. The Vatican City and the Pope are fine, but we have some, let's say, motion. I think the biggest one to the south is the Grotta Perfetta Valley, which was filled by material to create buildings, and we have subsidence that is, let's say, studied by many researchers. In terms of the portfolio, I will not use much time here. We have, just to remember that we have 3 products. The first 2, basic and calibrated, are the classic, let's say, line of sight insert product. The difference is that the calibrated is somehow, let's say, ortho-rectified with respect to a GNSS velocity model that is available for a 50-kilometer grid all over Europe. And the ortho product is essentially a reprojection of this velocity into the vertical and the horizontal components. That is a bit easier to understand, because one of the problems of EGMS, especially when you see these complex patterns, is interpretation. And here I added here some natural phenomena that, of course, can directly impact or also indirectly impact a urban area. We have, for example, the case of Larissa. Here you see the deformation that is after and generated by the 2021 earthquake. And we have all the different deformation patterns that were generated and are being generated by the Reykjanes eruption in 2019, and then the Grindavik eruption that I'm sure you saw in November, and is still ongoing in Iceland. And we have also, of course, landslide. We have a case from France and the case from Tromsø. I think in Norway, just with their national service, they mapped something like 10,000 more landslides than the one that were known by the Geological Service. And finally, regarding the effect of exploitation of natural resources, you have, of course, many things that can impact the urban area. You have groundwater exploitation. This is Lorca, for example. You have mining, open pit mining, as in the case of Cottbus in Germany, or underground coal mining, as in the case of Katowice in Poland. And finally, you have oil and gas exploitation, as in the case of Groningen in the Netherlands. So all this kind of information it has to be, let's say, digested by many different users. And I finish with 2 use cases, one from a public entity. This one was published by the British Geological Survey. And it's about, let's say, an overview and the use of INSAR for detecting soil sinking, also with respect to climate change. And finally, an example from a company called Detectia in Spain, that they use the EGMS to create some data for infrastructure monitoring. I also recall you that we have an open search for use cases, so just go on our website, you will find a link where you can submit a proposal. With that, I will stop, and if you have any question, please contact me. Thank you.
Perfect timing. Thanks a lot for that, but also thanks a lot for an interesting presentation. Any questions to Lorenzo from you already? Then I start. You mentioned the users are mostly geologists. So it's more really an expert data set, or is this something that like if I'm a city mayor and
yes.
I have fear, I can go there and get data, or would I be overwhelmed with the technology behind?
Thanks for the question. Let's say that it started from the geological community, but then it went in many different directions. Right now, there are researchers working on the data for sea level rise studies, in the sense that we can calibrate the model knowing the subsidence along the coast. I think a map was published by the French Geological Service of the whole Europe of coastal zone subsidence. And to reply to your question, of course, the final goal, as you know, of any Copernicus service is to arrive to the citizens and to practitioners at the very local level. The problem sometimes here is that without a support for the interpretation, it can be difficult. Also, we have a problem that is general for many of our data, that is the volume of the data to be handled. We are speaking of a quite big data set to handle, but I had a previous experience that if we can create a network between research and local practitioners, this can work and the data can arrive really to somehow to the population.
Thank you, Lorenzo. Any last chances for a question now? If not, I think we move on.
Yes.
Unless you, Petja, have something to add?
I think let's set the standard for keeping the time.
Yeah.
So,
thank you. Good. Thank
you
you,
so
Lorenzo. We stay in this domain. I would invite Francesca Cigna to come up and to continue talking about subsidence. But we are now doing one step more. So she's looking at subsidence now, but also looking into the future of how things will evolve and how this may impact us. So the floor is yours.
Thank you very much. Good morning, everybody, and thank you for the introduction. Actually, Lorenzo's presentation is helping me because we will be building upon European Ground Motion Service data for our project, so it's a perfect match with the scientific flow of the presentation. So the talk today I'm presenting is on behalf of a multidisciplinary team of scientists and professors that I'm leading from the National Research Council of Italy, the Institute of Atmospheric Sciences and Climate, and the universities of USP, Pavia, and Padua. And what we are doing, if I can change the slide, no, how? Next, okay, it works. So we are working on this project that is called sub-risk, so subsidence risk. We are looking at the process of gradual sinking of the Earth's surface, especially with a focus on cities. And our goal is to understand how the human behavior in managing groundwater resources is impacting on the geohazard of land subsidence. How is it impacting today and how it will be impacting on cities in the future. So this is funded through the so-called PRIN projects. These are research projects of significant relevance in Italy, and in particular in this case it was also funded by the National Recovery and Resiliency Plan funding coming following the COVID. So where are we looking at? We are looking at Italy. And why are we looking at Italy? Because several studies over the last decades have identified a number of subsidence hotspots all across the territory, moving from the south up to the north. As you can see here, these are only examples. There are many more. I can cite the city of Rome that we've seen in Lorenzo's slides. I can cite many river plains like the Po River Plain or the Florence Prato Pistoia Plain, the Volturno Plain, where a number of subsidence hotspots have been mapped using satellite INSAR. And we are talking about, in a few cases, at up to centimeters per year of ground sinking. And so we need to understand how this sinking is impacting on urban environments. So the objectives of our projects are mainly to build upon satellite Earth observation data and existing geospatial data sets from Copernicus, for instance, to create value-adding products that can be used by the stakeholders. And you will see an example of these products in the next slides. And we are also working on advanced numerical models that are coupling the complex behavior of the subsoil. So we are accounting for geomechanical processes like the compaction of the aquifer system, but also the groundwater flow within the aquifer extraction. So it's a quite complex process to study. And we are looking, as we said, at today's scenario, but we are looking also to the future by incorporating climate change data, but also information about demographic development and urban development through a number of data sets available globally and at European level and also at national scale. So our workflow starts from the national scale, then goes down to the regional scale and local scale by looking at different details of analysis and with different techniques. And from the temporal perspectives, as I mentioned before, we are looking first at the baseline, so the present day scenario, and then looking into the future with a view to 2050 and 2100, which are the two temporal scenarios that are usually targeted when looking at climate change studies. And very importantly, something that is in common to all our work packages is that all our outputs will be open access, and they will be accessible through the project website, but also through a portal, like a web portal that we are building, enabling anybody, so any scientist, but also the general public, to access our risk maps and browse through the different products through this portal. So starting from the national scale, the approach is looking at the major cities of Italy. So we decided to start with the metropolitan cities of Italy. We have 15 cities. And what we are doing is to convert satellite INSAR ground motion observations into information about hazard. So to do that, we are considering not only the magnitude of ground deformation, but the differential subsidence that is occurring in space. So every time you have a strong differential motion, this is where the highest probability of developing cracks, fractures, and damage to the urban structures occurs. So we are converting European ground motion dataset information into angular distortions and horizontal strain information, and then converting them into hazard products using a quality scale, so from very low to very high, by using geotechnical thresholds, distinguishing different hazard levels. And as you can see to the left of the slide, we are using a risk metric that is combining this information from the satellites with exposure and vulnerability of the elements at risk. And to do that, we are using the global human settlement layer and the world settlement footprint information to basically get information about building type, like residential, non-residential, building age, and building height. And we combine this information through the risk metrics approach, and what we do is to generate risk maps with very low to very high risk levels and some statistics to quantify the amount of affected buildings and the amount of people living in those buildings. So here, very quickly, is an example for the metropolitan city of Rome. These maps are the three main outputs of the national scale assessment work package. As you can see, we have mapped hazard based on satellite data from EGMS. Then we have mapped exposure and vulnerability based on WSF and JHSL, and we managed to map spatially risk for the built-up areas by using the metrics approach. What we see by looking into more details, especially when we have more detailed data like the Urban Atlas, which is one of our additional inputs into this risk assessment workflow, is that you can actually go up to the urban block level and make an assessment of the probability of that particular urban block to be damaged by differential subsidence. And here I'm showing you a zoom onto an area that was actually shown by Lorenzo as well. It's the city center of Rome, and as you can see in the map in the center, map B, there is a strong pattern of angular distortion due to the differential subsidence, and as a result, many urban blocks are displayed in red in the map. And we've got information from field surveys, field data. Actually, those urban blocks are where a number of fractures in the buildings can be observed, and actually one of those red buildings some years ago was also demolished, so we have a good correspondence with what we see by using this method. So going into the regional scale, we are not just looking at mapping risk as a picture, but also we are looking at the temporal evolution of subsidence, and we benefit from the European Ground Motion Service because, as you probably will know, each of those colored pixels inside has information of about hundreds of deformation records within the time series. So what we are doing at regional level, in particular looking at Emilia-Romagna region, is to try to unravel the complexity of the temporal trends by using independent component analysis and other advanced geostatistical methods. At the local scale, I think I'll be very quick. We are trying to develop a model, a very detailed model, accounting for the heterogeneities of the geological layers. And we are looking at Bologna in particular, which was selected as one of the most important hotspots of the region of Emilia-Romagna. And we are developing this model with experts from the University of Padua to achieve this goal. And last but not least, we are doing socioeconomic assessments of risk. So we are not just quantifying or qualifying the level of risk, but we are also trying to estimate the economic impact, the damage, according to a number of information that we can get from, for instance, from real estate market values and information like that are available for free for the territory. And future scenarios, we are using climate change projections and trying to input temperature and precipitation projections for the future into the advanced model to try to estimate how climate change can impact on the subsidence process in the future, combined with demographic and other considerations, so how risk will be changing in the years to come. So here are my conclusions. So it's a work in progress. We started last year. We have more than 1 year ahead to complete the project. But if you follow us, if you follow the website, if you follow us on Twitter, you can get regular updates, and also you can access our publications and presentations, so you can get more information about what we are doing. Thank you.
Thank you very much, Francesca, and I find it very important and valuable that you focus on the 3 levels, national, regional, and local. And on this note, my question goes to your assessment of the role of regional authorities or regional entities in supporting cities and towns. Their role is possibly multipliers of interpreting and analyzing these data using these tools, which we saw could be quite complex for a city administration to use, especially when we speak about small cities. And given you work with the region of Emilia-Romagna, also very active covenant supporter, actually coordinator for the region and supporting the entire community of cities, do you think that there is potential for these regional entities to be able to support their cities on a bigger scale?
Well, I start by saying that I didn't mention that because there was no particular time, but we are working at very, very, very close contact with the stakeholders in this project. We started with two, so Emilia-Romagna region and ARPA, and then recently we've involved Basin Authority of Po River Plain, because they have experience on the territory and they are the best ones who can tell us if we are generating something helpful or not. And I mean, we are not the first ones looking at subsidence processes in Italy. We are not the first ones looking at Bologna or Emilia-Romagna. But what we are trying to do is to push the technology, even with a simple workflow, to convert very complex satellite-derived information that sometimes cannot be understood by a local user, and convert them into something simple like a traffic light map that can help a local authority to understand where to prioritize investments or field checks or something like that. So that's the idea. Of course, there will be more advanced models. There will always be more performant 3D super fashion things to do, but it's another direction, and we are trying, on the other hand, to reach the users. That's our goal.
Thanks a lot, Francesca. Now, looking at the audience, I gave you a few minutes to think of your questions while I ask mine first. Do we have some burning questions? No hands raised.
If not, you have still a few seconds to think, because I'm a bit curious to understand better how you use the climate change projections for the subsidence risk assessment. Of course, sea level rise is an obvious topic, but maybe there's other connections between subsidence and climate change.
Okay, yeah, this is one of the most innovative components of the project, because as far as we know, nobody has tried to input climate change related projections into a complex model of aquifer compaction in such context. So what we are trying to do is trying to quantify the impact of variations in temperature and precipitation into the overall input and output workflow of the model. So if, as you know, precipitation is the main input into the aquifer system. Temperature can have an effect on evapotranspirations and other processes like that. So we are trying to quantify how these variables can impact the overall balance. That's what we are trying to do.
Thank you. So last chance for you. But I don't see any hand, so we go ahead.
Well, I do encourage our audience to listen in and prepare questions for our next speakers. Thank you so much, Francesca, for these insights. And now we turn to one of our other topics on the session, floods. And I'll invite to the podium Frédéric Hebecker, who will speak on visualizing the impacts of water availability and extreme events with a focus outside of Europe, but we know it's also very important to be aware and to analyze this from a more global perspective and learn from experiences and how they can be applicable. So Frédéric, the floor is yours.
Thank you very much. I hope everyone can hear me. Thank you for the short introduction. As you said, now this presentation is a little bit different because we turn to another part of the world. We turn to Southeast Asia, also to a very different type of city. So we've talked about big cities, mostly so far. Now we're going to talk about smaller cities, rural cities in Southeast Asia. You might even be able to call them towns or villages. So also this presentation is split into two different parts. So I'm going to start talking about water risk assessment or components of water risk that we have assessed in this particular part of our research project. And then my colleague Shaines Ziani is going to take over talking a little bit about climate forecasting and related hydrological modeling. Without further ado, we are here representing work that has been conducted in the context of the Polyam Water Research Project, working in general with polycentric approaches to management of water resources in Southeast Asia, on the interface with water resources management and urban planning directly with cities in Southeast Asia, being guided by, on one hand, inquiring about their demands, their needs, which are essentially quite different to what we see from most European cities. We have conducted a baseline assessment for each of the cities, a participatory vision building, and are now in the phase of developing concepts to present to the cities, but also together with the cities in order to adapt the urban development that is currently ongoing there. Our case studies are located in the rural countryside of Laos, Cambodia, and Indonesia, and are subject to a monsoon climate, which I think we will also hear a little bit more about later in Shaina's presentation. So what is the demand that we have received from the cities? On one hand, there's very limited ground data, which also gives us very limited ability, so to speak, to build on. On the other hand, there is limited coping capacities on the ground. So that means the tools and data sets that we introduce, the methods, they have to be as simple as possible. So we are not introducing very complex solutions like what we've heard about before, for example, but rather try to keep it as simple as possible in contact with capacity development to enable stakeholders. Some of the challenges are deforestation on a watershed level, but also a lot of land use change through urbanization, land reclamation, leading to a loss of water retention potential. And being located in Southeast Asia, it's quite normal also to have seasonal floods and droughts. And then the question, how will that behave in future climate change scenarios? That is why we are assessing hazard, exposure, and vulnerability as part of water risk components and climate change scenarios. So to assess hazard, we have basically used reanalysis data in the beginning to identify when have specific exceptional precipitation events taken place, or when available water, peak water level from our case study in Cambodia, to then go into flood inundation mapping using Sentinel-1 SAR data, and in contact with the demand of the cities also we looked into landslide hazard assessment or agricultural drought assessment using, again, like most simple method available, for example, through the ecosystem of Copernicus or through Google Earth Engine scripts that are very simple to be applied, and then created different hazard maps categories which we deliver to the cities. Looking maybe in our case study in Cambodia, I wish I had a pointer now, but we can see how the flood is behaving in the city. So we see a lot of flooding, which is not too uncommon. However, a lot of the areas that are exposed to this flooding are actually agricultural or areas that are vegetated. So we don't have such a strong impact on an urban area yet. But if we look at like the future, on the right-hand side, we see the urban development plan, for example, for this case study in Cambodia. They actually intend to develop most of these sites. So one of the questions where we are going into dialogue with the cities now is, how can you adapt when you want to build there? Because you might not want to have a lot of options. So looking at a picture on the bottom, a traditional way to adapt to flooding in Cambodia is building on stilts. What is the outlook? So we have identified simple Earth observation data sets and methods that are crucial to help to enable decision makers to actually map components of risks. There is a window of opportunity because most of the cities want to develop in areas which are still relatively natural, so there's a lot of natural assets. But at the same time, we have to talk about their current ideas on how to develop there. In the case study in Laos and Samnua, we have already developed concepts on a very small project scale together with them. How can alternative development scenarios look like? And in Kratie, we hope to do a similar process to introduce these risk components that we have identified to engage in strategies on how to manage floods and green spaces in the future, to develop adaptive transition pathways. And with that, I would hand over to Shainas.
Thank you, Frederick. Good morning, everyone. So in addition to what Frederick had just said, we, in the framework of our project, we needed to also assess the impact of climate change on our study area. But before diving into more details and the methodological part, I would like to explain some context. So as previously said, so the Southeast Asia is prone to frequent occurrence of extreme events, droughts, floods with low resilience and high exposure, high vulnerability, which leads to the increase of the intensity and also the frequency of occurrence of these extreme events, and therefore the negative or high negative impacts on the different socioeconomic indicators in the regions. The stakeholders or the cities needed robust information about impact of climate change on the different sectors. However, we are in an area that is very scarce in terms of data, with complex climate and coarse resolution of available data, and that's why we decided to use high-resolution downscaled climate models, and I speak more specifically about Cordex, Southeast Asia, and WorldClim, based on the IPCC report 5th assessment and 6th assessment, where we forecasted precipitation and temperature to, after that, forecast discharge. As it was already said by my colleague, so the study areas, we have 3 study areas where we study it on 2 levels, so the villages or the small cities levels, and also the watershed level. What we did exactly is that for both precipitation and temperature, so we computed first the ensemble mean multi-models, and for both Cordex and WorldClim, and then we used reanalysis data to correct the bias using chirps for precipitation and ERA5 length for temperature, and then we extracted from this analysis first forecasted monthly time series for precipitation and temperature from Cordex, and we also extracted some trend analysis, seasonality analysis using both data sets. And finally, we forecasted also discharge using a simple conceptual rainfall runoff model, which is the GR2M. So the results were, we have a huge bunch of results, but I would like just to give you some hints. The first one is that overall, both Cordex and WorldClim were really able to capture the temporal distribution of the temporal distribution of precipitation and also of temperature. They were also able to capture the hydrological cycle, the seasonal shifts. However, we see some biases, and especially, for example, for Cordex, where it detected that in the future we would expect a wetter climate, especially in the drier seasons, while WorldClim expected the opposite, a drier climate. We also noticed that there is a large, although that, for example, for Cordex, the resolution is coarse, but there is large uncertainties and large insimilarities between the watershed level and also the village or the cities level. In terms of temperature, so we have all the models, or the 2 models, expected a warmer climate, and also we have large uncertainties with moving from the watershed scale to the city scale. And here are some of the results. So the Cordex RCP is 8.5, which is the most extreme ones, expected that we will have more precipitation in the dry season, and the opposite of less precipitation in the wet seasons. And because I know I am above time, but I will be very short just to show some of the results of the GR2M model. So we used these forecasted precipitation and temperature to assess or to forecast discharge. And we noticed that this simple model has ability, so with a coefficient of NCE Nash-Sutcliffe of 0.35, which means that it has capacities, but it's still insufficient, especially that it has difficulties to detect the extreme events, low or very high discharge. And so I don't want to dig in more details. We can discuss that further, but what I would like to say is that we could, using simple methods, which is what is available from open source data, to give an idea about the impacts of climate change on these small cities. However, we are still fighting a lot of uncertainties, a lot of differences, and this is due to either biases in the reanalysis data, or also some biases in the models that were generated these climate or downscaled climate models. And with that, I would like to thank you and welcome your questions.
Thank you very much. Very interesting. Very interesting and very relevant work. I want to remind you also what Karen Seto said to us at the beginning, that we have a huge lack of studies in the Global South, and if we have studies in the Global South, they are about Nairobi, they are about Lagos, but not about the secondary cities. So congratulations to you also for really trying to look at all the other areas, because this is also where a big part of the urbanization will take place and which are most affected by climate change. So it's important to bring those back on the map. So any questions from the audience? It's time now. Eh? We have 3 presentations without any contribution from your side. You have to wake up now. I still give you a second, because I was also working in secondary cities in Ghana, and we are also assessing the flood risk there. And the only data that we could get, because it was a very ad hoc, not even a project, we were using global flood hazard data. And it was the best we could get, but they were far from being sufficient. Did you test those also in your areas?
Yes, we looked into those products. The biggest issue is the resolution and the ability to adapt to specific events.
Okay. Yeah, that's, I can confirm.
I don't know when you worked in Ghana, but one of the biggest reasons why I personally like to also work with the Center One Data is the newest developments in the EO browser, for example. So you can very easily, even without any GIS knowledge, develop time series that visualize to some degree where flooding occurs, and especially in case studies like in Cambodia, for example, it is very visible.
Okay, thank you. Thank you. Monica. Now, try.
Yes, I think it's working. I just have to shout it into it. Thanks for the presentation. Very indeed agree. A secondary city is the way where we should go to. I was wondering, are you looking also, because often these global flood models and global flood data, they are very coarse and they're not really predicting where the flood really happens. At least that's a conclusion, and we're also now working on flood models, also in secondary cities, also primary cities. And typically what we see is that we really need to include the urban morphology and the local drainage system, where the drainages are blocked. The waste is a big driver of floods. Are you also looking into this very sort of complex factors, which are often very difficult to model because there are no data? But they're often the most decisive to explain the location of floods.
So in terms of modeling, we are at the moment starting to model specifically for our case studies the baseline using a combination of HEC-HMS, HEC-RAS, and SWMM. And specifically in SWMM, we also account for the information we have about the drainage. Based on our experience, that doesn't necessarily match the reality, but it's the best we have at this stage. One of the further developments possible is, for example, that we use the high resolution drone data that we have, a 2 centimeter resolution, to actually add to that data and make it more comprehensive. When it comes to modeling future scenarios, I think Shahinaz has talked a little bit about the limitations, and especially when you don't have the right baseline of many years of discharge precipitation measurements, it is very tricky, but I'm quite optimistic and hopeful that with also the developments of more globalized data sets, so for example with MS Web, maybe we are able to actually increase that, this type of ability, where the main issue is still how to bring that capacity to the local level. Because very often this type of urban planning that I also showed from Cambodia happens in the capital. It's very centralized. So they want to decentralize that capacity, but very often on the local level you don't have that capacity yet. So I think it's going to be a longer process. I hope that answers your question.
Okay, thank you. In view of time, I think we have to move other questions to the coffee breaks. Thank you again for that interesting presentation. We are now moving back again a bit more to the geological side of things, where I have the pleasure to have Gian Domenico Mastrantoni to present their work on a multi-geohazard risk assessment at a city scale with, I think, an example also from Rome. So I hand over to you, 10 minutes for you.
Hello, good morning everyone. Thanks for the presentation. In this next slides, we will talk about multi-hazard risk using satellite INSAR and other official open data. So, as objectives, we know that the United Nations for Disaster Risk Reductions outlined 4 key priorities, of which the first 2 are the main focus of these studies. So we want to understand disaster risk around us, and we want to strengthen also the disaster risk governance to improve the resilience of our cities. And the final goal for this study was modeling multi-hazard risk of buildings at the city level posed by ground instabilities such as landslides, subsidence, and sinkholes. So multi-risk is composed by 4 key parameters: multi-hazard, multi-vulnerability, exposure, and loss estimates. These components come with different challenges, so how we can compare different hazards, how we can quantify hazard interrelationships, and how we can assess different physical vulnerability for the different hazards, and last but not least, how we can synthesize and communicate and easily visualize the results to communicate this to the decision makers and the risk managers. So to address these challenges, or at least most of them, we chose a multi-layer single hazard approach that comes with simplicity, the possibility to compare different type of hazards, and the possibility to obtain easily comprehensible results in terms of maps and risk levels. So the study area for this work was the city of Rome, and where we have a huge amount of landslides events occurring in the past years, as well as sinkholes and subsidence going on. So the methodology for the multi-risk assessment is composed of 3 different scores: the multi-hazard score, potential damage score, and the activity score. The first is basically the spatial hazard prediction, so the susceptibility for landslides, subsidence, and sinkhole. The potential damage score is based on building characteristics and asset market value to compute the vulnerability estimates and the exposure of the buildings. And the third is the activity score, which is based on building displacement rates from multi-temporal satellite INSAR estimates. So by combining these 3 scores, we arrived at specific risk for the specific hazard, and by combining each specific risk, weighted by amplifying factor, we obtain the multi-risk level. This factor is a factor that takes into account the type of the hazard, also if it is a stroke, a shock or a stress. For example, landslide is a shock, so the event occurs in a short time wait of period, so it's harder to mitigate. So for the multi-hazard, we have the 3 different spatial hazard map for the area of interest, and then we perform an intensive building analysis to each of the hazards, and we can see that the sinkhole hazard is mainly affecting the buildings, followed by landslides and subsidence at the end. For the potential damage, we want to compute the losses. So we need the vulnerability and exposure to get the potential damage. For the vulnerability, we used census parcel features to compute the structural resistance, combined with the hazard intensity. Here is impact ratio, and then reclassified into 5 different classes of vulnerability from 0 to 1 to obtain a physical vulnerability map of the city where each building has a vulnerability value. For the exposure, we build up upon the OMI database provided by the official revenue agencies of Italy that every year estimate the average market value of different type of buildings, actually, residential, economic, industrial, retail, and offices. So with this approach and with a sort of data processing, we obtain the real estate market values for each building within the area of interest. So the third parameters is the activity stage. Here comes the satellite part. So we have Sentinel-1 and Cosmos SkyMed ascending and descending PS time series. And we want to get the maximum from these 2 data products. So we merged this information into a multi-sensor data fusion approach to arrive at the maps that you can see at the bottom right for the up-down and east-west component of the displacement. And then we also extract this data at the buildings level, so we have the building's vertical velocity and the building's horizontal velocity. Then, for the different type of hazard, we, of course, select different type of velocity. So for the landslides, we want to reach the maximum east-west and up-down direction. For the subsidence, as previously mentioned, we are interested in the differential deformation of the structures. And for the sinkholes, we know that the deformation is always towards the down. So, passing from the quantitative data to the qualitative scores for the prioritization of the buildings, we used empirical cumulative distribution functions and percentile thresholds to reclassify this data in order to combine all of the 3 scores. So at the end, we have 3 different maps for the 3 different hazards for potential damage, activity score, and hazard level, with the score going from 1, which is the lower, to 5, which is the highest, let's say, priority of, or level of the variable. And then by combining these maps, we obtain a multi-risk score for all the buildings, where we can see also the dominant risk distribution for each type of building. And at the end, we can say that 40% of the buildings in the area of study are not exposed to any risk at all, while 33% face mainly sinkhole, 22 landslides, and 5% subsidence. But in the end, we want also to validate this approach because it's always needed. And to do this, we take the past mitigation expenses from another official database, the RANDIS database and compare this value with the predicted multi-risk scores of our buildings. So we can see there is a direct increment in the score also with the expenses. So at the end, this is a semi-quantitative model incorporating hazard maps, building characteristics, and satellite data. And it is also replicable towards the Italy, because these data are available on a national scale, the census parcels, and also the OMI database, as well as satellites, of course. And satellite inside displacement introduced into the risk equation allowed us to consider a dynamic dimension, so we can update these estimates in the future if we see something that is accelerating or some new landslides, for example. So we want to support, with this study, we want to support the risk managers and decision makers through identification of vulnerable assets and prioritization of mitigation measures. And in the future, we are working also to adapt this type of model to cultural heritage sites, such as Aulerian walls. And we want also to include the social parts, so population, density, vulnerability, and its dynamic cycle between day and night. And yeah, that's it. Thank you. For someone who is interested in going deep into this approach, we have a paper published in Taylor and Francis. Thank you.
Thank you, John. Thank you. Thank you also for staying perfectly in time. I have a first question. You had this picture from this sinkhole in Rome. What is the main reasons in Rome for those sinkholes? Is it natural? Is it man-made leaking pipes, or what is it?
Yeah, sorry, I forgot to mention it, but sinkholes are actually anthropogenic in Rome. So they are mainly related to ancient Roman galleries, on the underground galleries, and also to pipeline leakages that causes the collapse of the roads, mainly the roads, but also some buildings.
Okay. Questions from the audience? You can still think. I still have some.
I do.
then you go.
Audience.
Good, you go.
But from a user perspective, and I'm sorry if my question may sound a bit as a challenge to you. We aim also to make these essentially risk management tools. It's a decision-making tool for urban planners applicable. So obviously it's a lot of computation, mathematics, models that one needs to apply. And what are the conditions for a city administration to use this? Would they need, what kind of expertise would they need in order to be able to apply this more theoretical method, as I understand? Or maybe you actually already have some applied evidence to provide. Thanks.
Yes, we had some talks with the municipality, but they were mainly related to landslide hazard. For the multi-risk, probably, I don't know, for the Rome case, there is a geological office within the municipality. So I don't know, I'm not sure if all the cities have offices like that, but in this case, there were people actually that were, let's say, experts on this topic, because they have background studies about it. But in this study, we also focused on the money that they want to allocate for future mitigation expenses. So for the percentile threshold that I used, we chose the top 2.5% of the values in the top class. Maybe this is also based on how many money do you have to spend for the mitigation. So you can adapt these thresholds based on your availability. And this is something you can interact with these people that are managing the risks, explaining this. And I think it's not so hard to understand also for the people that is not maybe geologists or stuff like that. Also, yeah, this was taught exactly for this topic, to be easily explainable.
I still have one question. You did the interferometry yourself. Could you have used also the Copernicus ground motion service to get the movement from them?
Yeah, the Sentinel-1 data was from AGMS.
Okay.
Yeah, while Cosmos SkyMet was processed in-house.
Okay, good.
Great.
Thank you. Last chance. I continue asking, but I'm afraid they are a bit tired today. So thank you again for this presentation, and we move to the next topic.
Indeed, and I already see Dinesh heading to the podium. Thank you so much, Dinesh. You speak for floodings, but from a different angle, flash floods caused by extreme rainfall. And indeed, in these cases, municipality needs to act very fast to not only predict, but then react in the aftermath. And that's why speeding up the computations is a rather important task. So you have done significant work there, so please tell us more about it.
Yeah, thank you for the introduction and setting up my talk. So I'm Dinesh Natarajan. I work at the German Research Center for Artificial Intelligence, where we work on different AI applications for remote sensing use cases. In this case, I will talk about urban pluvial flooding. So climate change has led to an increase in extreme weather events such as extreme rainfall, which further leads to flash floods, which comes with little to no warning. And here I've added some examples of flash floods in recent years in Germany, especially this year. So there is really a requirement to build tools for better planning of preventive measures against these flash floods that municipalities can use. So there are some physics-based simulation tools that already exist, some commercial tools, some very few free and open source tools that take anywhere from minutes to hours to complete flooding simulation. So how do we improve the adoption of these flood prediction tools and implement them in practice? So we could make them faster and less computationally expensive to make them more accessible, and integrate them with existing GIS tools used by the cities and municipalities. So our vision is to contribute to building a faster and interactive planning tool that can be used by cities and policymakers to plan preventive measures against flash floods, or such fast tools can also be used for early warning systems. So an overview of our work: we use some high-resolution terrain information and some synthetic heavy rain events. We use a physics-based flood simulator to generate training data from many cities in Germany with many artificial rain events to build a database, which we then use to train our ML-based flood emulators. And the advantage here is that they are much faster than the flood simulators, and this can accelerate their applications in flood risk analysis, early warning systems, planning tools, and so on. So in order to train these flood emulators, we need a large, high-resolution data set. Currently existing flood data sets are low spatial resolution or only include 1 or 2 study areas. So in order to build a generalized ML-based flood emulator, we needed many diverse domains of high resolution. So we built such a data set using open source elements, using 1 meter resolution digital surface models of 322 cities made available by the state of North Rhine-Westphalia in Germany. And we also used an open source flood simulator, which is already very efficient, and it was recently published by the researchers at TU Darmstadt, and it's also open source available here. So in our data set, we have a large diversity of domains. We have different urban areas of 2x2 kilometer grid, city centers, small towns with different elevation ranges, different terrains. So in order to really build a generalized flood emulator. So as input features to our model, we used terrain data obtained from the digital surface model and some additional features that could be extracted like slope, aspect, curvature, flow accumulation, TWI. So we have a really large input dimensions of 2048 by 2048. We also use some synthetic, spatially constant, temporally varying rain events of different intensities from 20 to 200 millimeter per hour. These are very rare extreme rain events. These inputs were used to generate reference data using a physics-based flood simulator. So this simulator gives a time series of water depths during the prescribed 180-minute rain event. And then we aggregated these water depths to get the pixel-wise maximum water depth maps that is seen during this rain event. So we have a database of different cities for different rain events, and in total we had around 12,000 samples. And we did a data set split into training, validation, and test set, and we made sure that each city is either only in the training, validation, or test set, which allows you to train the ML models on some cities and then evaluate them objectively on unseen cities during the training. So where do we place ourselves in the current state of the art in ML-based flood emulators? So there are different deep learning architectures like CNNs, neural operators, graph neural networks, which mostly work on either low spatial resolution terrains, or they have less diversity in their data set. So as you go in higher and higher resolutions, there are only studies using one or two domains, and we have 300 cities in our data set as well as 1 meter resolution. So as deep learning architectures, we used a UNet-based architecture, which has as inputs our terrain features and then consecutively downsamples these features with an encoder. And at the bottleneck, it is fused with what we learned from the rain event. And from this fused encoding, we upsample them back to the flood depth map. And this UNet has also an additional feature of the skip connections, which reminds the decoder of what the encoder learned in the initial layers. And we also tried other variations of the UNet, such as UNet transformer, which includes some attention blocks in some of the skip connections. We also tried adding more convolutional operations to the skip connections so that we spend more effort in learning the patterns in the high spatial resolution dimensions. So we trained all these models from scratch on our data set and evaluated them on this unseen test set. Here are some architectures that I showed before. We also tried another architecture at the bottom there, which combines the UNet transformer and the skip convolutions. So they have parameters anywhere from 3.7 to 5 million parameters. We report the error metrics on the test set. The first one you see is the root mean squared error. So for all the metrics, the last architecture performed the best. So root mean squared error indicates that it has an error of 3.3 centimeters across the entire 2x2 grid, across the entire test set. And this is comparable to some of the other studies in literature. Then there are other metrics for flood prediction, like the critical success index, which indicates how good the model is at predicting floods greater than a specific depth. And what we notice is that for higher and higher flood depths, the model tends to underpredict the flood values, which is indicated by the low CSI scores. But these high values are less represented in the data set in this huge 2x2 kilometer grid. So enough of numbers, maybe I show you some pictures here. So this is predictions from our trained model on the city of Aachen. And I have to emphasize that Aachen was not seen by the model during training, so this is an objective evaluation. So when comparing the ground truth and predictions, we see that it is able to capture the patterns in the flood depths and where the water is during the rain events. And if we take a closer look at the pixel-wise predictions, we see that the distribution of water depths here indicates that there are very less number of high water depths in the ground truth, so the model underpredicts those water depths, but for the lower water depths, it's able to predict well. It says 8 minutes, okay. So just zooming into Aachen here, I can show some ground truth and prediction. So there is generally a good agreement with the patterns in the ground truth. The difficult part for the model is to predict these high water depths, especially in those underground driveway that you see there. But generally the patterns and the different rain events is captured by our model. And one place where our model does not perform well is when there are bridges in the digital surface model. So even for the flood simulator, the bridges are a problem because it cuts the flow path. So training it on such data also leads to some differences in the flood path, and the flow doesn't reach the river in this case. So finally, to conclude, we can further extend this work by trying to predict the entire time series of the flood events, and also using our trained emulators to extend them to higher spatial resolutions, less than 1 meter, and also integrate them with some GIS tools. And there are further improvements we can make to the data set, such as using spatially varying rain events or better processing of the digital surface model. So this is a summary of our work. So we have this flood simulator, which is able to do physically accurate predictions, but it takes around 5 minutes, whereas our ML-based emulators, even though there is some investment in training, they are able to make very fast predictions in 0.25 seconds and also for multiple samples at once. So this will help accelerate applications in flood risk analysis and for better planning. So all our data, code, and models will be made open source upon publication. So please watch out for some updates from our publicly funded Flores project, and here's my contact information. Thank you.
Thank you, Dinesh, and apologies for getting a bit nervous because we are in competition with the other session that is ahead of us. So at some point it might get noisy in the background. That was why we are a bit nervous. Still, I have one question to that very interesting and very relevant work in terms of spatial resolutions. You showed Aachen there, but I'm not sure, is it only the downtown Aachen? Is it really the larger Aachen area, or could you maybe even apply it to a situation like in Germany, the Ahr Valley flash flood?
So we have a 2 by 2 kilometer grid at 1 meter resolution of 300 cities in NRW state. Mm-hmm. So we make predictions on the entire 2 by 2 kilometer grid. And so the picture I showed was a zoomed in version maybe of a few hundred meters, just to show how accurately the model is able to predict those patterns. And in our data set, we also have some rural towns or towns with valleys. For example, in Altena, there is this hill leading down to a river. So it is also able to predict these, but we are limited by the digital surface model. If it contains bridges or flyovers, this causes issue with already the flood simulator. So with better data, we will get better results. So, yeah.
Thank you so much, Dinesh. And actually, it reminded me of the time I was living in the area, Rhine-Westphalia, and the flooding in the Mosel and Ahr Valley, which happened, I think, 8 years ago. So I was thinking how relevant your work is actually to enable local mayors and local practitioners in really small cities, they're not cities, towns and villages, to predict and prevent such occasions and significant damages. So thank you so much. A round of applause to Dinesh.
Thank you.
Thank you, and we still go back now to the subsidence topic, back to Italy also. It seems to be really an issue here, and I have the pleasure to have Hanier Datka presenting his analysis in with the case study of the city of Ravenna. And you still have your 10 minutes for presentation.
Sorry, my colleague is not well today, so on behalf of her, I am presenting our study. So our topic is subsidence risk assessment for the enhancing urban infrastructure sustainability, a case study in the Ravenna. Here is our agenda, like flow of the presentation, that we are focused on the ongoing presentation. So start with the introduction. We all know about the sustainable development goals, like it's a focus on the different aspect of the terrestrial ecosystem, biodiversity, infrastructures, everything. It comprising the holistically the different goals starts from 1 to 17, and we are emphasizing on the particularly on the infrastructure side, and to see the what is the impact on the infrastructure and within the city level. So here our study falls under the goal number 9, which is corresponding to the industry, innovation and the infrastructure. Goal number 11, which is directly related to infrastructure sustainability. And goal number 15, which is corresponding to life on land. And our study area is located in Emilia-Romagna region on the northern part of the Italy, the Ravenna city, and which is the more oldest Italian town, and it suffers from the decadal subsidence, and also it has a more strategically importance because it contains the port in the coastal side, and it is one of the UNESCO heritage site which comprises a lot of archaeological sites. So it is monitored to see the urban infrastructure within the city is crucial. And also this is the building density within the city is around 240 inhabitants per square kilometer. So it is relevant to also integrate the sustainability framework with the subsidence. So here is you can see in the map different areas, territory of the Ravenna city. So first, before going to the subsidence, we need to understand what is the geological framework, geological settings, and what are the cause of the subsidence. So here you can see the geological understanding plays a significant role to understand the subsidence, and majorly it's a decadal and the centuries it suffers the subsidence because of the hydrocarbon extractions and the hydrogeological settings, and most of the groundwater exploitation which are the major cause. And here you can see the black dark circle which shows the methane gas reservoir, which are the major cause of the subsidence. And also the lithology affects a lot, and the bedrock and tectonic activities affects the subsidence. So our aim is to integrate all the three sustainability goals with the integration with the subsidence phenomena for the resilience and sustainability of the urban infrastructure. And our objective is to see the time series deformation patterns with the subsidence risk, and we integrated all the sustainability parameter which is related to infrastructure, safety, economy, and the environment. So here is our comprehensive methodology. In the first part of our methodology, we did the comprehensive study on the sustainability development goals. We listed all the parameters which is related to sustainability, and we applied the MCDA analysis, the TOPSIS method, which is the more prominent method for the MCDA, and we calculate the indicator score for each and every indicator which is corresponding to the infrastructure. In the second part of our methodology, we comprising all the risk assessment framework which is related to the, we use the CLMS, EGMS data, and we calculate the building vulnerability based on the DBSN and OMI data, and we calculate all the building vulnerability score and building damage score based on the building velocity and the subsidence. And we ultimately rank the area territory within the Ravenna city, which the urban local body needs to focus more. So here is the SDG indicators that we took in our analysis. It contains the 4 pillars majorly: the institutional, social, physical, and the economical. And this is the top-choice method workflow, which is the more prominent for the MCDA, and it is corresponding to 95% of the accuracy while calculating the rankings of whole, and which gives you the more positive ideal solution for the ranking. So it is a quite geospatial kind of modeling, and it's a quite comprehensive in terms of the ranking, and we implement this method. I skipped this slide because earlier my colleague explained. So here we use the CLMS data EGMS, which is some strengths and some weaknesses. So here I emphasize on the urban infrastructure subsidence of the, so here you can see the EGMS Sentinel-1 ascending track, which is the resultant of the up, down and east-west vector. And if you can see majorly the coastal side, here is the more prominent to subsidence, and we can found the maximum velocity of the 10 centimeter, the 3 centimeter to 10 centimeter. Also here we, in descending track, you can see the most of the coastal side and some of the southern eastern side of the Ravenna more prominent to subsidence, which is also we found 4 centimeter to 6 centimeter per year. And this is the vectoral decomposition that we derived at a 10 centimeter resolution, and from the ascending and descending. And here also you can see most of the cluster facing the subsidence. Also here we can see the vectoral decomposition at the building parcel level, and we collected the building footprint from the DPSN, which is the Italian agency gives all the building parcels, which characterizing the more detailed structure than the OSM. And here we can see all the buildings also in the coastal side facing the quite prominent subsidence, ranging from 4 centimeter to 6 centimeter. Also here the linear infrastructure, we can see mostly the roads are facing on the coastal slides are facing a prominent subsidence. And also we validated with the subsidence with the GNSS validation technique, and in Ravenna there is one GNSS station, and we validate our velocity, maximum velocity with the PS, and it's quite correlative. And also by using the sustainability framework and the subsidence, the first map that I showed here, this sustainability map derived from the ranking of the different indicators and the MCDA method that we applied here. And we can see in the mostly the southern western part of the Ravenna is the less sustainable. The zones are Ronalcecchi, the Mezzano, and the Castiglione, which are the more less sustainable in terms of the indicators and the urban local body investments and the different parameters that we considered. The second map is based on the integration, the vulnerability map, where they derived from the building parcels and the building velocity, and you can see mostly the Del Mare regions, which is a coastal side, which is more prominent, more vulnerable to nature. Also, total damage map, it is derived from the OMI database, from the revenue agency of the Italian Space Agency, and we can see the building damage is facing in Del Mare region, the coastal side of the Ravenna. Also, in conclusion, that I want to conclude the different high risk areas, and you can see this is the comprehensive integrated map. It integrated the sustainability and the subsidence, and we can see the Castiglione, Mezzano, and Del Mare, which are the 3 major area territory that urban local body needs to give the attention to this zone, because it's more prominent to, it's less sustainable and more prominent to subsidence and more prominent to geohazards in the future. So our aim here is to highlighting the high risk area, and we demarcated prioritized some of the zones, and some of the interventions should be followed by the government in these areas, and local authority can make the informed decision by using our risk assessment framework, which is a quite comprehensive, integrating the sustainability and the subsidence. And also the urban local body needs to be can increase more investment in these zones, to mitigate the effects and the mitigation strategies. So here are the references that we are used in our study, and if you I'm here to have any questions. Thank you.
An extra applause also to you for bringing your colleagues closer to the coffee break. You were faster than your 10 minutes, so thank you for that. I found this quite interesting because you are really trying to not only look at the natural side, but also the sustainability aspects that you are bringing in, and also the fact that you are really looking at it from a city perspective, so the local units. Which I think is something that in view of this idea of making it useful also for local governments to make use of it, I think if they see Area del Mare, they immediately understand which are the areas of concern, so that is, I think, really very good work. Did you get feedback from the city of Ravenna?
We didn't interact yet, just for research purpose that we are doing this study, but in future plan we'll collaborate with them and we'll do the study.
Okay, thank you. Still your chance for contributing to the discussion. We have actually 2 questions now. We start in the back. Yes.
Thank you for this interesting presentation. I have to admit, it's not my specific area of expertise, but comparing this to a topic in Asia, for example in Bangkok or Jakarta, very often aquifers and groundwater extraction play a major role. So I'm curious if you've also looked into that aspect in Ravenna.
I'm not that much familiar about the Asian countries, the subsidence phenomenon quite well, but one of the study that we are doing in India with the subsidence in the Himalayan territory, and we found that the major cause also, which is located in the coastal plain of our Arabian Sea, and we found that the major subsidence because of the groundwater exploitation, because for the development and for the anthropogenic factors affects a lot, and in that regard, so that's our agenda. But we want to also, I'm planning to integrate this study with the Asian context also in the future.
Thank you.
So we take the last question from here, and then we wrap up the session. Thank you.
Thank you for your presentation. I don't know about the European cities, of course. So I just have a question. You said Del Mare,
yes,
that area. It looks like high sustainability,
yes,
but also have high vulnerability.
Yes.
So you picked the 3 region for have a consideration for the compared with the other area. So what is different between the other 2 areas?
The integration point of view of the sustainability is more, because it's less sustainable and more vulnerable in the nature because of the subsidence, right? So what we did is less sustainable and more vulnerable in the nature because of the subsidence, right? So what we did in our analysis, we focus on the less sustainable zones at the urban scale, and we identified the vulnerability score, the average vulnerability out of whole the city, and we found that the Castiglione and Del Mare, which are the more prominent, we need more attention for the urban local body to more focus towards the increase the mitigation strategy and increase the investment in those zones. Thank you.
Didn't we plan well?
Well, all right, but thank you so much for those insights. And I also wish to thank all our panelists for those insights on subsidence and risk-related and water-related risks, which are so important for local practitioners to plan for it, to address, and to ultimately protect the livelihoods of their citizens, but also the economy of the cities. So thanks a lot for this. We have the generous 10 additional minutes for a coffee break so that you can continue the exchanges during this coffee break, or I'd rather give the floor to Mark to explain.
You said everything, so we'll start at 12:10. I remind you that there are 2 sessions in parallel. So in the big hall, we will have a sessions on the global urban development. So essentially the global data sets on various parameters. And in the Magellan, so in the other place, we will have sessions on innovative techniques, essentially downscaling techniques and the use of AI methods. Yeah, it is activated. We will be starting in 1 minute. Huh? If you could sit down, we are going to start the session. Okay, we are starting the session. So with it's a session that I will share with my colleague Pouria from ICLEI. It's on our global urban development and dynamics. Actually, we have 2 sessions related to that topic, but the first one is on global urbanizations. So we wanted to give you a bit of context on these sessions. The main objective of that sessions will be to discuss the availability of global data sets. We are really talking about global data sets in these sessions on urban development, and I give you a few examples in these sites, like the building footprint, the imperviousness, the populations, night lights, and but we also want to see what is the practical applications of these data sets. A bit of EU context. There's a good reasons why we want to have that sessions. There is, as you know, this continuous flow of high quality and freely accessible time series of satellite data, and you know how dense are the time series of Sentinel-1 and Sentinel-2. But there is also an emergence in the development of new techniques to do large-scale data processing, essentially with machine learning. We have, and I think this is a key part of the solutions, high-performance computing platforms, being on the cloud or in the private HPC, and of course the democratizations of computing cost. And these all together offer these opportunities to monitor the change and the trends in urbanizations at the global scale, something we would not have been able to do 5 to 10 years ago. These data sets, they come with different characteristics. Today we'll discuss a lot about global data sets, but there are also continental ones, as you've seen in the previous sessions. They need to be multi-temporal, because what we want is to look at the changes. This means that we must be sure that these data sets are consistent in time. There is, of course, the spatial details now that comes to the scale of Sentinel-1 and Sentinel-2. It's not something we can do with commercial data because it will be really too expensive. But already with Sentinel-1 and Sentinel-2, you will see from the presentations that there are really good data sets that we are able to produce at the global scales. You will see that actually the solutions very often use multi-sensors. So by using multi-sensors, you are able to address the limitation of a single sensor. So you will often see
presentations using Sentinel-1 and Sentinel-2 together. Of course, it needs to be harmonized, so that means it needs to be consistent in space and time, and it needs to be quality control, and you will hear about validations, but also about uncertainties in these data sets. And then the last point, which is for me is important, is the level of operational readiness. And here we have different, you will see that some are available as a Copernicus services, some are more the results of research organizations, so this needs to, of course, to be addressed. What is the utility for the urban practitioners? Well, it's essentially to provide insights in the variability, both in space and in time, and have the change patterns, because that's also, of course, we have to think about whatever we do. The changes is fundamental, and that's what we want to track. And tracking change is always a challenge, especially, all the AO experts know this very well. And the area of use are multiple, especially when you combine these data sets with socioeconomic data, but you need to put this into data analytics tools, and we have a very nice example that will be presented today to see when you put all these data sets together, how you can better monitor, analyze, and even predict, and we have the case of GHSL, predict the urbanization trends and derive indicators for this that can be used in different policies at a global scale, but also at a national or at a city scale. We will have 6 presentations. The first one will be a presentation by Mattia Marconcini on the world settlement footprint and the latest development done by the DLR team. Then we'll have a presentation by Thomas on the global urban settlement layer, and here also you have a variety of different data layers that will be presented. We'll have a practical implementations done by Gioville, and Michael Riffler will present this, which is linked also to the GHSL, and this will be explained. And the fourth one is the practical use of this. For those who went to the demonstration areas yesterday, they was already presented, and Thomas will show this again with a presentation today from GSAT. And then the last 2 slides, the last 2 presentations are on the nighttime observations. One from an urban heat island perspective, so from trying to get nighttime warming trends in cities, and the last one by Monica on the importance to have night light observations, and I'm really looking forward to have that presentation. And I want, of course, to give a bit of a user perspective, and that's why actually my co-chair is here.
Thank you so much, Mark, for setting the scene so nicely. I guess you said it all, and I think I can only add from urban practitioners' perspective, the fact that why Earth observation data can really support cities. But when we are talking about cities, we should know that the planet was not like this a few decades ago, a couple of 100 years ago, and it will not look like what we are seeing at the moment in a few decades. So urbanization is definitely a defining trend in the century, knowing that currently more than half of the world's population are living in cities. And this data is set to be more than 2/3 of the world's population by 2050. And this is massive, because the population of this planet may raise to 10 billion by then, and 2/3 of it stands a really huge number. And then we already understand that urbanization and expanding urban areas, this change is happening quite rapidly. Looking into statistics, we see that from 1990 to 2014, the urban sprawl has increased by 95%, and is still, is a very important issue in so many areas of the world. And I guess we all are aware of the linkage of economic growth and urbanization, and there's a competing element there sometimes. When we look into international processes, I'm sure some of you have been engaged in some of the negotiations in intergovernmental processes, and you see that those countries that are experiencing a much faster urbanization rate are taking a completely different perspective compared to those countries that are already well urbanized. And obviously, another angle is a social context and social fabric of cities that are sort of ever evolving, posing different dynamics, which is both challenges and opportunities, but definitely challenges to social services and cohesion. And environmental impact that urbanization is sort of bringing about is no news to anyone through pollutions of different resources, through the patterns of consumptions, land sealing. We see that the environmental impact of it, but it also offers opportunities such as green technologies and new and innovative urban planning. But these three concepts that we talked are the fundamental pillars of sustainable development, right? So we know that urbanization is impacting all these three pillars, but at the same time, this calls for more sustainable practices in urban planning, urban governance, and land management. And that's where Earth observation comes in, right? Thanks to the advancement of Earth observation, the data analytics driven from Earth observation can definitely support, is currently supporting, and will hopefully support even further the new ways of how we are managing our resources and land and urban areas to ensure that we will transition collectively to a more sustainable community, considering the planetary boundaries. So today we have, as you mentioned, we have a wonderful set of speakers, leading experts on different topics that are trying to connect the dots and offering and talking about some data sets and services that supports urbanization or managing urbanization in one way or another. And I'm looking very forward to listening to all these scientists. Thanks, Mark.
Sorry, I was muted. Yeah, it's very nice. Very nice considerations. I think it's important also to see the user perspective, and that's what we want to hear from the speakers. So the way we decided to organize these sessions is that every speaker has 10 minutes, and they will have to stick to the 10 minutes. Even if we have a bit of time, yes, we have the timekeeper here. I think you have a warning at 3 minutes and at 1 minute, so please stick to your time. After each presentations, Pooya will have, I would say 1 minute or a bit less to give a first reaction to what he heard from a user perspective, from the perspective of ICLEI. And we've decided actually to take all the questions at the very end. So at the end of the session, we'll ask the 6 speakers to come here. We'll probably use the seats here, we'll see. And then, so please, if you have any questions, write it down and ask it and keep it for the final roundtables with the speakers. So I'm not able to move the slides, but anyway, I will do it from memory. So the first speaker is actually not in person here. I hope that he's online. He's Mattia Marconcini from DLR. And what we will get, ciao Mattia. And so it's always nice to see him. He's going to present. I think many of you know the World Settlement Footprint suite of products, and you will hear about the latest development and what is called the WSF tracker, if I remember well, which is the new development that Mattia and his team at DLR has been doing. So Mattia, the floor is yours.
Thanks a lot, Mark, and hi, Frascati from Munich. It's a pleasure to be there, at least just remotely. But at least we managed to get this done. So I am really pleased to present this work that has been taking me probably all my nights also, besides the days in the last 18 months. And I mean, you already set the framework about urbanization. It's always fascinating, I mean, studying this complex phenomenon that is actually taking place basically worldwide. And in this regard, as you already mentioned, Mark, I mean, at DLR, we initiated already almost 10 years ago the World Settlement Footprint, which is an activity, WSF for short, that involves the generation of a collection of novel, open and free high-resolution data sets, which has the goal to advance the understanding of urbanization with the highest possible detail and accuracy And in this framework, we had different products, as you mentioned, settlement extent, imperviousness. But let's start with a bit of history. So everything initiated with the WSF 2015. So the first layer outlining the settlement extent at the global scale based on the time Landsat 8 and the novel Sentinel-1, which proved to be particularly accurate and effective. But then when we could put also Sentinel-2 into play, we had the chance to release the WSF 2019, where we introduced several improvements. And as you can see, the result is still quite impressive, and they proved to be probably the most accurate of its kind even so far. But then, you know, the pitch is already full of people working in the field, but then we had the big boys coming there. So Google and Microsoft really started doing an amazing, incredible work with providing building footprints at the global scale, starting from very high resolution imagery. And as we can see in this case of Mumbai, even where we have you know, informal areas, they could almost perfectly detect each and every building. So the question is, does it still make sense to do you know, what we've been doing so far? Well, I would say, of course, yes, but for different reasons. So on the one hand, we can have a look, for instance, to the current availability of the Google Open Buildings footprints and also to the Microsoft building footprints. They're not yet global. Possibly they will be global, but, and I would be happy to have them because, again, great layers, but they have some limitations. For instance, we don't know when they will be generated next time, if any. So there's nothing systematic behind there. Plus, there's no information about when the different buildings have been detected. So we don't have any vintage there. And last but definitely not least, the cities are growing faster and faster. So in areas that are really developing, let's say, very fast, we need something that could, let's say, support in this direction. So even layers generated every 2 or 3 years might not be enough. So in this regard, I'm pleased to show you WSF tracker. So new global layer outlining the global settlement extent at 10-meter resolution at 6-month basis, starting from July 2016. So when basically the availability of both Sentinel-1 and Sentinel-2 started becoming, let's say, consistent at the global scale. And here I picked, I hope that Dennis is there. I started from Nairobi because, you know, in honor of Dennis, it's quite a nice example because you can see also from the coloring, there's a high dynamic settlement growth here. And we can see, for instance, in the upper part, we can appreciate here what happened and actually the detail that we can reach still despite we're using Sentinel-1, Sentinel-2. So the whole archive basically has been used you know, to generate the tracker. And the idea, the goal is to have it, let's say, constantly updated every 6 months. And so far, I can tell you that everything is, let's say, in Google Earth Engine, and to generate the new layer for July 2024, so basically almost fresh from the oven, it took just 3 weeks, because in the end, what we are doing is also simplifying the problem. So I don't want to go too much into technical details, but extracting, let's say, a series of features that simplify, you know, the challenging issue here. And in the end, we simply apply a random forest, nothing simpler than that. So here I want to show you just some examples that I find kind of stunning, really also to prove how fast, how dynamic our world is, especially concerning the development. You might know that there's the new Cairo city rising in the middle of the desert, eastern from, say, the actual Cairo, which can appreciate how fast and dynamic it is. But also in cases where you have, let's say, more informality, so more scattered growth, the layer actually proves extremely performing. Here we can see the example of Lagos, for instance, which with a completely different pattern. Here, another example, Bangkok, Thailand. And it's a bit sad to see how fast the different you know, rice fields that were surrounding the city are replaced by urban areas characterized then by this elongated form, and you can see stripes basically everywhere with the different colors. Of course, Asia is playing a major role. Here also we have an example of Hanoi, Vietnam, and it's interesting to see what could look as something wrong as a blob in the lower right corner. It's nothing more than a new industrial area that basically pop out of the blue just starting from last year. Or, of course, if we talk about urbanization, we cannot avoid talking about China. And I think that I always like the example of Chengdu also for its form. You can see there's a very strong master plan behind, bulky patches, new constructions that are basically anisotropic in all directions in surrounding the city. But for instance, even South America has a similar behavior, despite not as pronounced as Asia. Again, with bulky growth, for instance, here we can see one of the fastest growing cities in Ecuador. But then what can we do also with this data? We can really track eras of crisis even. So this is Goma, at the border between the Democratic Republic of Congo and Rwanda. And you can see that there has been, you can see my pattern in the upper left, this yellow structure that basically appeared in the last 6 months. These are, let's say, refugee camps that were present in the country that have been relocated specifically to Goma. And we could basically identify it almost perfectly. But again, for refugee camps, we can even see what happened in the past. So this is Mepi in Uganda. This is an area in the northwest of the country where we have a lot of people fleeing from the surrounding countries, and they have been establishing in different refugee camps. And here the color basically characterized the time of their settlement. Another example that I find relevant is the one of Cape Town. So you can see quite a remarkable growth. We can have a zoom in this specific area. And actually, there has been a massive growth in this part, in around 2022, but extremely fast. And if we have a look also, for instance, to the flood risk level, this is a combination of the FATOM version 2, 1 in 100 events, combining pluvial and fluvial risk, with the classes ranging from no risk, light gray, to dark red, very high risk. And we see that they settled where no one else wanted to settle there, where we have, let's say, the red units. And we can see, for instance, in Google, this was just August 2020, where just few settlements were present, few houses, let's say, along this couple of roads. But then already in 2022, this was the situation. So kind of amazing what's going on. I was discussing with a colleague of Microsoft that was even behind the generation of the Microsoft building footprints. And he mentioned that in their case, they had even in US some problems because there was not later than a few months ago in Elkhorn, Nebraska, a particularly heavy storm event that severely damaged the city. And they had a look to the building footprints and there was nothing there. So I said, let's have a look. And actually, one could see that in the tracker, everything was actually identified. And just as an example, that even in countries that are rich of data, to have this availability of, let's say, high frequent information could be in some cases.
Mattia, you have 1 minute to conclude your presentation.
Okay, so just to give you an example, really close, really fast, how good it is. We can discuss about the validation, but let me just show you. I mean, here you can see an example of, say, Dar es Salaam. This was December 2018, and we can appreciate that something popped out in, just after a couple of years. Or this is another part of the city, and again, I go faster, but one can appreciate this remarkable growth. And this, let's say, we are working now to set up, a kind of with the support of ESA, to setting up in response also to a request from the World Bank, a portal that might enable the online analysis, as you were mentioning, Mark, before, of this data that could give some insights in order to support the countries. And we did, some preliminary example directly with people in Tanzania, also discussing about, in that case, the fluvial risk. And the last question, when will this be available? So everything is finally being exported. So I cross finger that before the end of the year, this could be available. And with a further update, of course, at the beginning of 2025. This is just not one of the layers. You know that with WSF, we have several others. And wait for surprises because, let's say, beyond the standard layers that you might already know, the 3D, the population, imperviousness, there might be something new that is actually upcoming. So stay tuned, and thanks a lot again, Mark.
Thank you so much, Mattia. I guess... Scientists like you have a lot to share, and it's always hard to squeeze it in only 10 minutes, but thank you so much for keeping almost within the time. I think a quick reflection from my end was like, you showed some really powerful examples of the application of this tracker, and particularly, you know, in line with the objectives of this tracker, as you mentioned, that is to produce open and high-resolution global data sets to help us better understand urbanization. And that's exactly the challenge, because in a lot of countries that we have cities, we have members from 137 countries, and oftentimes we realize that when we are talking about governments, they only consider the administrative boundary and administrative area as cities. But we know that that's not the only area that you need to deal with as areas. And then they come up with you know, terminology such as peri-urban areas, or even we are talking about urban settlements, we know that like there is a continuum of urban settlements and informal settlements. So really powerful examples, and thanks a lot. I believe what you're doing is really has this huge potential to be integrated in so many global programs. I may have some ideas, but we'd love to take it offline. Over to you, Martin.
Thanks a lot.
Thanks again, Mattia. Thanks for keeping the time as well. Mattia, if you could stay and attend all sessions, because at the end we still want to have this table and allow a few questions from the audience. So the next person is Thomas. I think you all know Thomas now. He's been very active in this conference, and he will present, yeah, we keep the time as well with you, Thomas. He will present a series of data sets, which is called the Global Human Settlement Layer, and you've seen the GHSL presented in many presentations, so it's quite well-known data sets. So we'll know a bit about what are the latest development also in the GHSLs, and its use in both the policy sectors, but also how the city authorities are using these data sets and the various layers available. But it's also made available for research, so we want also to hear from this.
So thank you, Mark, for this introduction. Maybe on top of that, my aim is really not to focus so much on how we do it, what data is out there. I will show this also a little bit, but really taking into account what we wanted to achieve here in this conference, that I want to show that why we did it in this way. So to be able to really bridge this gap from research to policy development. So if I can move, yeah, so you see here the global data set that again shows how little of the global space we are talking about if we are talking about urbanization. It's still a major mega trend on the globe, but in terms of area, it's still quite limited. But that's only a side note. I'm still fighting a bit with the system here. So what we are doing with GHSL, we try to provide really a framework that tries to look at the human presence on Earth in a consistent way. That is important. We have one data set that is able to address population built-up areas and settlements. And being a commission service, we are obliged also to make this available free and open, so we really adhere to the fair data principles. So you just go to the data site and download whatever you want without registration whatsoever. But we also have to look at our processing budget, so we also spend time in trying to be really efficient. And the other aspect now is that until recently it was really more on a pre-operational basis, so best effort, and then you were long waiting for updates. And now we are really moving into this operational production, and you will hear also then in the follow-up presentation more details about that. In very short, again, I mentioned built up, we use algorithms to detect all the buildings in the world. We combine it then with census data to come up with population density grids, and then put on top this settlement classification, the degree of urbanization that I will also come back to a bit later. But then in terms of data coverage, we started actually from the middle there, where you see monitoring with Sentinel now. So we were coming from the disaster response perspective. How many people are affected by the flood? How many buildings are destroyed? These were the questions when we were starting to develop GHSL. But then very soon it was clear that it can be used for something else. So we really try to look back as far as possible as satellite data allow, which is now until the 70s with Landsat data. We combine it now with Sentinel, so currently we have already an integration of Landsat and Sentinel data. We do the monitoring then with the Sentinel data in the Copernicus context now, but then policymakers, they don't care so much about the past, because they need to develop programs, so they need information for the future. So we've also invested in understanding, are we able to map settlement and population growth in a spatial context in the future. Still something a bit about the product. We are looking here at Ghana, and on the right-hand side you see the highest resolution products that we have based on Sentinel. Currently for the year 2018, we integrated that then with the Landsat data to create this time series from 1975 until 2030. So that is the other projects where we see also this time component currently available in a 5-year steps interval. And at the bottom you see a bit what I mentioned, this data integration, where you have on your left, the building volume, in the center, the population, and then on the right-hand side, the settlement classification, all in one package. Here now in a different view, the data products again. So we have a set of data talking about the built environment, where we are now moving into really built up surface measurement in square meters. We have building height and volume. And then we also are able to differentiate between residential and non-residential. That is very important for our population disaggregation, because we are mapping resident population, so we don't want to put them into industrial and commercial buildings. The degree of urbanization I mentioned already is really, I think, one of the success stories also in this context, because it was really a development done with what was called here so often the users, so working with those that need such a definition and develop it together. And yeah, there's also a paper. You will see a better QR code at the end, so don't worry much. In terms of approach, we have developed our own methodology, the symbolic machine learning. I will not go into much detail, but this approach allows what you see here on the right-hand side, your left, is this evolutionary approach where we started with the MODIS data, very coarse as training data, then developed the first GHSL product and used that for the subsequent training of the new model. And I took this picture from the presentation from the paper I just mentioned. You can read the paper for all the details, but what I wanted to show is really the GHSL products there, where we started in 2016 with the first release with somewhat decent accuracy, but then we really have this trend of self-evolution improvement over time. And that allows you to do really nice studies based on the time series. So you see very different areas on the left with cities and city growth, so some urban areas. Top left is, I think, New Delhi, and the middle bottom it's Bangkok in Thailand, but then also some very rural contexts. And for all those, we know how many people are living there, how many buildings are there, and what type of settlements we are looking at. And then you can put this together in this settlement evolution graphs that we have done, and you see this very different pattern where sometimes, like in New Delhi, you have a massive population growth, not so much the city extent, but population is growing significantly, while in other parts it's very much on the rural side that is growing. So this is opening a whole lot of additional research. I mentioned the Copernicus data integration. The next presentation will explain to you much more the methodology behind, but we really felt that we need regular updates, so the colleagues of DG DEFIS supported this now, so we will have really biannual updates of GHSL built up in the first place, but then we will derive the other products on our side. So we're expecting the first update for 2022 to be delivered to us in December this year, and then every 2 years. And we saw already in the pilot study some significant improvement. Now, to finish, really few points also about this data integration, where we really need to make sure that we don't overwhelm policymakers. So this is where we have developed here this staircase, basically, from where you see on the left-hand side the raw data that is hard to handle even for us, and that needs to be integrated. So the step one, the information would be then the built-up areas, the population grids. Step three would then taking those to do the classification of the settlements into cities, towns, and rural areas. And then built on top some policy analysis. We produce the Atlas of the Human Planet, to which some of you have already contributed. So that is a bit the approach that we are aiming for. And this is then also picked up. So we have, I put here some of the more high-level policy reports to which we contributed, or to where our data were used. So quite various domains, and that is I think, showing that such an approach, an integrated approach, is able to deliver. And we also deliver capacity building on the degree of urbanization. With this complete set, which we were yesterday also at the demo, there's also the tools that you can use to derive some of the products with your own data. So we have really reached out to a number of countries to help them make use of the data. And to wrap up, I think I hoped I was able to clarify to you a bit this context, that it's not important just to develop one product, but to think of it in a more framework manner if you want to make it used by policymakers. And doing that, we also, we had bright minds that were helping us to come up with new ideas that are now mostly the first time delivered at a global level. And again, the second last point here is this co-design is important. So don't try to come up with a fully fledged product, but start talking to the people that should make use of it. And then I'm looking forward to the updates coming up now from our contractors in the context of Copernicus. And sorry for being a bit longer.
Thank you so much. That was lovely, Michelle. I really appreciate that. Please join me in giving a round of applause.
Maybe while you summarize, if you want to find the paper, it's on that QR code. Sorry.
Thank you for leaving the QR code there as well. I think, to me, from a practitioner perspective, it felt like there's a lot in common with the WSF tracker as well, which, when you look into that from a strategic perspective, these two can complement each other. But I particularly liked the angle that you were taking, the sense of co-creation and not really being prescriptive, but rather leaving room for other stakeholders to engage, but also thinking like this foresight in your work, that you turn this to, type of policy advice, the atlas that you mentioned, the capacity building that is definitely informed with the insights that you derive from this platform. And I think why this is important is particularly at the multi-level governance, in so many areas, we need to create solid information for the national government, but also for subnational governments. And I think the type of work that you are doing in this tool is definitely one of those that can support this. Again, same as the previous one. I think there are a lot of ideas as someone who's engaged in this line of work, but would really love to take this further. Mark, over to you.
Yeah. You know, when you have these presentations, I mean, I think, like me, you probably have already a number of questions to ask. I mean, one of the questions that we'll ask, I already tell you, is how to get the ownership from countries and from the city authorities. But it's something we'll discuss in the final roundtable. So, actually, you already introduced the next presentation, Thomas. So the next presentation is, as Thomas said, actually, this GHSL was initially developed as part of GRC research activities, and they developed up to a pre-operational stage, and now it's integrated in the portfolio of Copernicus services, and through a contract. And actually, Michael Riffler from GeoVil is leading that contract, so you will see how we move now to an operational services.
Yeah, thanks for the kind introduction. Actually, I would like to present in more the methodological background of the presentation we just saw from Thomas for the new service implementation, where we are responsible, and it's not only us, GeoVil, but also I would like to mention here the colleagues from other companies, so from CLS Group, Vipno, but then the DLR is also involved in the activity, and then certainly the things I show here, present here, there we suspect or include colleagues from the European Environment Agency, and last but not least from the JRC, Thomas Kemper and the group. And I think the scene has already been nicely set in terms of motivation. I think the first point is clear. I mean, majority of people are living in cities, are affected by, let's say, the strong dynamics we already saw also in the presentation of Mattia, but let's say see it also from a more general point of view. I mean, there's many interesting characteristics you can observe within urban environments, but also in the surrounding rural environments. So the use of land resources, certainly the information we derive is relevant for disaster management in the emergency management context, but then there is many more applications which are interesting. Let's say more from an applied scientist point of view, certainly we are very much interested in, let's say, the changing data policies. I think for the younger audience here, it's just natural to use Sentinel-2. Everything is open, but I would like just to remember you that 10 years ago, that was when Landsat has been opened to become free, and before that, getting these public data set was quite a hassle. You have to submit proposals, etc. And so we are now in the golden age of Earth observation, I would say, also knowing, just saw the first pictures of Sentinel-2C, so having already the next Sentinel-2 in operation, and hopefully soon also the next Sentinel-1. And as a last motivation point, I also would like to mention that as a service provider, we are certainly also interested in onboarding new technologies, AI-based methodologies, and making, let's say, bringing them into operation and applying them on a larger scale. Quickly on the methodology, so how do we extract information from the AO-based information, or let's say time series which are available now from Sentinel-2, Sentinel-1, mainly used in these pan-European and global productions. There is, let's say, 3 different types of information we can actually leverage there. First of all, certainly the spectral. So if you think of Sentinel-2, multispectral information is available. With the time series, the temporal information gets very interesting, and then certainly you can also extract spatial features out of the Earth observation data. And in the operational context, certainly we want to make use as much as possible from the available data, But then also we still have to keep in mind that all these processing costs, so therefore the methodologies need to be cost effective and also fast when considering the global context. So let me just point out a few, let's say, important design decisions we considered here in order to go continental and also global. The example shown here on the left-hand side shows, let's say, the typical time series information you would have, and often in that context what is done in order to make this, or let's say to extract these features for classification methodologies is then just to put some kind of statistics or do some kind of compositing in order to feed this into a machine learning algorithm. But I mean, if you see this time series, then you also see how rich a time series in fact is. So it also shows undulations. You can actually see trends, etc. And it would really be a waste of all this amount of, let's say, all this time series information if you would just stick to the statistics. So we then actually, so besides the statistics, we also consider time series modeling and parameterization. In order to get additional features we actually use for classification. And one of the big advantages in doing this is that so you could also in fact, let's say, feed individual images to modern machine learning methodologies, but on the end, if you then go away, let's say, from a small study area and consider this needs to be worked globally, then you certainly need to make sure you know that the methodology is fail-safe, and therefore what we can do here then is, you know, to convert the time series, which vary around the globe, also due to cloudiness, etc., just translate that into a predefined set of coefficients, informations, which can then be fed to the machine learning algorithm, and this proves to be a highly efficient approach. So the next step is then certainly select appropriate model. So in a couple of years ago, let's say the state of the art for going large scale was, let's say, more to address it in a pixel-based way, which is still done frequently. We tested and implemented here a convolutional neural network, so-called UNet approach. We saw it also in one of the previous presentations, already a similar approach. So we use this UNet for our classification and regression task because, so together with the information presented before, so translating this time series information, extracting the model parameterization, and then just think about the third aspect I presented before, so also having the spatial context. This is something which can be done with the UNet easily. And so where we then, how many? 3 minutes, okay. I need to speed up a bit. We can implement that or feed that into our model and integrate, so not only the multispectral aspect, but also these time series features and the morphological features through the convolutional process. Some more details on model training and transfer learning. I think this is highly important for a global product. Just consider that we have roughly 20,000 Sentinel-2 tiles on the globe, so meaning we need to train the models in order to do the model inference. And here we follow the concept which has been introduced previously, I think, by colleagues at the JRC, and where we select, we make a random selection of the tiles, use these then for the training, and then spread the models, do a bit of retraining in order to go global. In terms of the big data processing environment behind, so what is very important is that the methodology is transferable, so meaning, as you know, so data is hosted at different cloud providers. So we implemented a system which can address various cloud providers, is also capable of addressing issues with, for instance, if data is missing, and certainly have implemented that into efficient container orchestration framework, so-called Nomad, and also use various let's say dashboards which make let's say the monitoring of the production easily available. And just to demonstrate here in the lower part figure, I would like to show, so let's say these are more or less the processes which need to be distributed, but this is just only one layer in the whole system. There is a whole bunch of additional components you need around this in order to steer the processing and observe it. And I would like to come to a few application examples, but here also more, let's say, from the implementation point of view, because we have not yet finalized the production and therefore are also not allowed to share the products processed so far. But just to show here one example from the exposure mapping component of the build-up product, so part of the GHSL product portfolio. So here we are interested in extracting build-up information and also distinguish between residential and non-residential areas. And the image on the left-hand side, on the right-hand side, it shows, let's say, build-up structures and together with parking lots. And certainly a very important point here is then to select appropriate training data, making you aware, make it possible to distinguish between the build-up structure and the sealed areas, and just using a different training configuration, you come up with these two different solutions shown here. And what I also would like to demonstrate is, let's say, a design decision between selecting a pixel-based approach and the UNet-based. You can see here in the right-hand side, the example is that you much better catch the outline of these residential and non-residential areas. And one more example I would like to show here on the left-hand side in this figure is we also experimented with synthetic data, training data, and for some regions, we came up with very good results, purely relying on synthetic data, shown here for a test area in the US. But then in China, the results were not so satisfying, so leaving gaps here on the lower bottom shown with the synthetic data results, which then in the end led to the decision that this needs further investigation before it can be put into operation. Actually, I will come to the end. So I just also wanted to show another example where we for the implementation of the Copernicus land monitoring service. So here we are dealing with a classification regression problem. So in fact, we use the same framework and can apply it there as well. The issue there we have is that this has also been addressed already in some presentations, that you need to make sure that, let's say, past products are consistent with the most recent products. But on the other hand, you know that the technology you can apply right now will lead to much more accurate results in the products, but somehow you also need to make sure that they are still aligned with the past results. So therefore, we use a mixed calibration approach in order to trying to harmonize the products from the past and right now, and the differences resulting differences are just highlighted here. So after considering this mixed approach, we come up to much more let's say, to better outlines of the sealed surfaces, also showing fine scale structure compared to the previous products. I know I need to wrap up, just providing the short summary here. So what I wanted to demonstrate is that in the end we implemented a framework which we now also bring forward to various or implement for various services, can address multiple characteristics you would actually like to extract in order to monitor surface dynamic or land surface dynamics. And yeah, one key process I was actually not, where I actually didn't have enough time is that, let's say, a key aspect in the overall implementation is certainly that you have accurate reference data, and this is also where a lot of effort actually goes into implementation of these services. Thanks for your attention.
Vielen Dank, Michael. I think this is really helpful. Particularly, I like the examples of application. But for the interest of time and to make sure that we will have some Q&A at the end of it, I'll pass the floor to Mark to move to the next presentation.
Yeah, the next presentations, I'm looking at my notes here. The next presentation is from Thomas Soukup from GSAT. He already made a demonstration during the demo area in the Magellan yesterday. So we will see, so you've seen this global data set, the GHSL series and the WSF, and in these presentations, it will show how you can integrate these data sets in a data analytics framework and derive statistics indicators that are useful in different policy contexts.
Yeah, thanks Mark for introduction. I really like the sequence of the presentation because I think we see all the nice data which we are able to use, and my presentation will be a little bit how we can make them accessible in an easy way. So that's also why we choose this more news headline title, but that's exactly to exaggerate basically that we are able to make it easy already. So I'm presenting the work which was done with ESA support. They are mentioned some main contributors. They are definitely not all. And we also, I don't know if Dennis is here, but that's also, he's in fact part of the team because we did it together with UN Habitat. Okay. Yeah, so I will not go to the details because many of this was already said already in introduction. So just to highlight that basically the urbanization is often considered as a challenge, but it's also a big opportunity, and I think it was already mentioned at the beginning. And so this is just for the rationale, why we did it. And we saw already a lot of data only in this session. So basically, we need to have data sets ready to be able to navigate the future, to navigate the urbanization processes for the benefit of all. And Earth observation is really nowadays able to provide the information about the past, about the present, and also guide to the future with help of the modeling. The main rationale was that basically there is many valuable data sets, but it's not only about to make them available as a data, but the impact might be challenged because the data are complex, the data are huge. So we also have to consider this complexity, which might be generate a difficulty for user for practical uptake. And that was basically what we tried to contribute. And so within collaboration with the UN Habitat, we tried to exploit some of the technologies and things we developed in a context of the URBANTEP project, and plus the new generation world settlement footprint data sets to contribute a little bit improve the situation to some aspects. So I already mentioned that it was funded by the ESA and was done in a collaboration with the UN Habitat. So the goals of the project was really to contribute for production or easy production of the SDG indicators related to 11.3. And moreover, also the UN Habitat was very keen to develop something which can really practically support the national and local authorities in their activities around the SDG indicator reporting. So this is just another showing the three main elements which we used, the data, visualization, and analytic toolbox, which as a GSAT we are behind, and also the European data cube for the functional urban areas delineation. So after many iterations within the team, with the users from UN Habitat, we end up in something what we called Urban Expansion Insight. And we basically developed a tool which nowadays has 3 main modules. So the first one is kind of exploration module, we call it. The second, so where you can really play with the different data. The second one is a benchmark, which is more focused on, let's say, practical comparison between the different regions, countries, cities. Or you can also use it for comparison of different data sets. And the third module was, we want to support some kind of reporting, some kind of documenting what you find in the tool. So the third module is how to make a quickly report, documenting your findings. So I will just go quickly through some slides and just to document how it works. I invite you to try yourself. We had a demo-ish session yesterday, so some of you, I apologize, it will be a partly repetition. So the Explore module is really, you can really dive deep into global urbanization patterns and trends. So just you can combine, let's say, freely any data which are in the system, attach the indicators which you choose. You can play with the time scale, change granularity, and compare. And you can find any place in a word really quickly. And you can export all the elements of, so the pictures, the graphs. You can work later on in your local environment. So just example, you basically can select the countries as you want, and you immediately see the indicators which are defined in the system. You can obviously not work on a global scale, but you can also dive in. So for example, this is example of Cairo. And here we are not comparing the different areas, but we are basically comparing the different data sets and the message which they in fact gives you, so which I think, and I will point to that later on, is also very important. We discussed in the last days that we have not one data set, we have many data sets on a different scale, and we should really be more acknowledge what these scales really tell us and which product is more useful for which purpose. And tool like that can basically raise a more confidence in the data, because maybe we will find that they tell the same story, or we will see that they are telling in some cases different stories. So why? Okay, 3 minutes. So I go quicker. So this is just a list of the data sets which we have. So we have a number of WSF products. We have a latest GHSL products, which you saw in previous presentations. You have defined SDG indicators, but there are also some additional indicators which are relevant. So you can also dive deep a little bit in the indicators, not just stay on the level of the SDG indicators. And this is just a final example of comparing of different data, just to document that you can also find some errors in the data, because you see clearly that in one of the data sets there is some artifact which otherwise would be really difficult to be seen. So also for some kind of really user checking of the data, it could be useful. So for benchmark, I mean, you use the similar functionalities, but you are really concentrated on the comparing between the areas, between the time, between the different data sets. What we support is comparison on administrative areas, but we also, what I didn't mention, you can also choose a different analytical, let's say, representation of the findings. So for example, here you can in scatterogram see how basically the clusters of the region, for example, evolve in the time. So you can really identify the outliers which are expanding much faster than the other ones. You can also select your reporting period, so you can you are able to also monitor not the whole area, but in 5 years intervals, 10 years intervals, as you want. I mentioned comparison on administrative areas. There was a lot of discussion about functional urban areas, so we also support that. And what we also implement is that you can compare the functional urban areas as defined by the URBA, but you can also combine it with some other definitions, for example here, and you see what it really results in the data. Yeah. But you can also change the parameters, for example, of the URBA, and again you can see what does it mean in your statistics. So just to conclude, all of these, what you find, you can report. So you quickly select the report and you switch to the reporting environment, where we have now basically some kind of template, but this is expandable for the user templates. And you just simple by clicking select which statistics want to include, and you can print it to the PDF. So besides the saving individual elements, you can also prepare easily some kind of report. So just a concluding slide. So the key message is basically we have a data already, and much more will come. I mean, we saw for example, Mattia presentation, so another group of high resolution data. And we need easy access to data, not only to data, but also to curated information generated using these data. Because this is crucial for the real use, for generating insight, and finally generating impact of these data. And just to mention the benefits we see, basically for the research community, tools like that really promote the right data for the right purpose, because you can really find what the data tells, yeah, how this story is biased. So basically something what we say as a fit for purpose. And so we can provide finally more evidence about strength and limitation of individual data sets, which is crucial for the user, because they can really concentrate on the specification of the problems and solution for the problems, not on technical obstacles, which is nowadays a case. And also, we discussed many times, it will generate more awareness of the strengths and limitation of the individual data sets, because users should not take it as a granted. But it will generate finally also the more confidence in the data, because they will understand these limitations and strengths. And finally, because I am from the service provider side or private companies, I think it will also, the benefits for us as a service providers, it will generate more requests for the added value services and all these, which obviously is an aim of ours as a companies. So thanks for your attention. Yeah, it was 2 minutes longer, sorry for that. So if you need any more information, just there are some contacts and links. So thank you very much again, and I hope you find it useful.
I'm with you, Thomas. It's really hard to squeeze that wealth of knowledge into 10 minutes, and we already know that. But no, that was fantastic. I particularly was really impressed by looking into different levels in your work, and that matchmaking angle that oftentimes is missing, and your first key message that there is already data available, how best we can extract a maximum value out of what we have, and then also from end user community perspective, like focusing on the solution, not too much on the technicality or the technical obstacles, because there are other solution providers that would work on this. So for the interest of time, and knowing that we'll we'll have some hopefully time at the end for questions, I would like to yield the floor to Mark to move to the next presentation. Thanks, Mark.
So we still have two presentations to listen to. So during these 4 presentations, we discuss essentially daytime type of observations. It's not totally correct because with the radar systems, there are cases where we have both the ascending and the descending orbits. But now we are moving to nighttime observations, and we are going to look at this in 2 aspects. One, in the context of the urban climate, so the importance to look how the cities are warming. And you know from the Urban Italians presentations that it's very important to have these observations when the difference between the center of the city and the outside of the city is high, which means during nighttime. So this is the presentations of Panagiotis, and the next one will be about night lights, because this is also important. So we are moving to nighttime observations now, and I'm sure this will be also very interesting for the audience.
Yeah, thank you very much for the introduction. Thank you all for being here. What I'm going to present today is the work that we are doing as part of the land surface temperature project of the ESA's climate change initiative, okay? So if you're not familiar with that, with the CCI LST project, what is the goal is to provide LST data that are suitable for climate analysis, okay? So what it does in essence is reprocessing a lot of the historical and present data sets, and they are using algorithms for the LST retrieval and for the quantification of the uncertainty that they are consistent. And the overall goal is more or less to provide the data that are adhere to the requirements of the global climate observation system. And what I think is like the crown jewel of that project will be like this climate data record. So the whole idea is to combine data from different missions in a time series that is going to be consistent and expanding. So imagine that the starting date is going to be something around 95 with 80 ESR2 data. So in addition to the data provision, the climate change initiative, the LST project, has also some user case studies with the goal is to test the data, provide feedback to the data producers, but also initialize and provide some information for the users that are coming next. And I'm leading one of these user case studies where the aim is to use the nighttime land surface temperature data in order to estimate the trends in cities across the globe. Okay, so I will try to provide like a very lightweight version of our methodology because I want to focus more on the results, but feel free to contact me later because, as always, the devil hides in the details, okay? So this is the starting point. When you download data from the CCI project, you get like these netCDF files that cover the entire globe, and you get like 1 image per day in dataset. The areas that are missing are either because they are water pixels or because there are pixels that are covered by clouds. When we work with thermal infrared data, we cannot get information from there. So for our analysis, we use the data from Aqua. We use the nighttime data, and the reason is because the land surface temperature and the air temperature agree much better during nighttime, and especially in this kind of coarse resolutions. And when we process all the data for this period from 2002 until 2021, we are not going to get data after 2021 for MODIS because of like this orbit shift and other problems with the dataset. And what we do is, starting with the LST data, we need to extract the information corresponding to the cities. So we overlay the data with a polygon layer that we created in order to provide a consistent description of the urban areas for the globe. And then for each city, we collect the pixels that fall inside that boundary. And we summarize these results. So we calculate, for instance, for every day, what is the mean land surface temperature or what is the maximum standard deviation. We also collect some data that help us process the data, like the view zenith angle and the solar time. We do some processing. We calculate an uncertainty for every spatial mean that we calculate. We also calculate what is the fraction of the cloud cover for its observation. And then we store everything into a database. Now, what I would also like to note is that we try to control how the cities change over time. So what we do is we update this mask that I showed you before that delineate the cities every year. And here you can see an example of how they change over like this 20-year period. And when we're done with that, we move with a trend analysis. This figure more or less shows the entire process. We start with the daily data, which is like these light gray points. We calculate the monthly means, the darker gray. Then we decision the entire time series, get the blue points, which are the anomalies, the monthly anomalies, and only then we do the trend analysis using this Stiles-N operator, which is like a linear regression and very robust to outliers. Now, let's move to the results. In the map, what you can see is like the distribution of the LST trends that we calculated for all the cities that we covered in the analysis after we have proceeded with the quality filtering. And what you can see is if we collect the data for the entire globe, what we see is that the mean LST trend is 0.06 Kelvin per year, or 0.6 Kelvin per decade. The standard deviation is 0.02 Kelvin per year. You can also see the distribution, so you can see that we have a longer tail for the warmer temperatures. The maximum trend that we have calculated, and I'm going to come back to that in a bit, is 0.15 Kelvin per year, which is huge. Now, what we have also split it and calculated what is the mean values per continent, and what you can see is that the areas where the cities are warming the quickest is like Europe, Asia, and North America, and then for the global south, like Africa, Oceania, South America, it's not so intense. What is also interesting is that for like these 935 cities that we had after the quality control, we noticed that around 5% of them, so 46 cities, have LST trends, nighttime LST trends, that are greater than 0.1 Kelvin per year. Okay. Moreover, if you examine, now I'm going back to the map, what you can see is that we can detect a couple of areas where there are these hotspots. The first one is Europe, and in particular Eastern Europe. So you can see that in Eastern Europe we have all this very strong hotspot where we have like cities increasing with the LST, the nighttime LST increasing quite a lot. And in particular, from the 246 European cities that we have in total, 14 of them exhibit an LST trend that is above 0.1 Kelvin per year. So it's around 5.7% higher than the global average. The other hotspot is China. So here you can see that from the total 192 cities that we analyze, 14 of them exhibit again this a trend that is greater than 0.1 Kelvin, so 73%. And the last one is Middle East. Middle East, we have like 64 cities in total, 30 of them exhibit this 0.1 Kelvin, which makes it around 20%. And also in Middle East is also the area where we find the city for which we observed the greatest trend. And in particular, that city is Doha in Qatar. For Doha in Qatar, the LST over this 20-year period has increased by 0.15 Kelvin per year. So in this 20-year period, the temperature has increased by almost 3 Kelvin. In Europe, in contrast, the city that is where the LST, the nighttime LST increasing the most is Warsaw in Poland. So it's 0.093 Kelvins per year. Now, I want to speak a little bit more on the difference between Eastern and Western Europe. Here you can see like the focus area that I showed you before, and here you can see the mean trend that we calculated from all the cities per country. So the pink colors are Eastern countries, the green are Western European countries. And as you can see, all the Eastern European countries are the ones that where we have the highest trends. But this is not the complete picture, because if we also consider the climate, we can see that there is like a very clear difference between cities located in continental, which is the red ones, and temperate climates, the green ones. And you can see, you can see also the difference, the major difference there. So climate is like the main driver, not so much what happens in the city. We have also extended this analysis with the climates across the globe, and what we have seen again is agrees with the result before, that continental climates exhibit the highest trends, then the dry cities, then the temperate, and then the tropical. What we have also done was we have focused and worked with like the trends in the urban areas, but what we have also done is also calculate a buffer, a ring around each city, where we're able to process also the LST for the surrounding natural areas, and we want to see how well the trends agree. And here you can see in this scatter report the agreement between the urban nighttime LST trends and the rural LST trends. And you can see that there's like a very good agreement, but it's not one-to-one. There are some differences. If we plot them like this, we see on global level that the rural areas have like slightly higher trends than the urban areas. And according to the analysis here, these differences are statistically significant. But what we have observed is if we start in disaggregating the data, so in here, for instance, we split them in climate groups, we see that this difference starts to weaken. And if we move from global to regional analysis, you're going to find hotspots where the cities, in contrast to what I have showed you before, increase, the LST increases faster than in the surrounding natural areas. So this is something that we need to investigate further. Now what we are doing is that we're in the process we try to figure out and understand a little bit more why there are like these differences across the globe. So we have collected ancillary data and we have applied the same trend analysis. So we have collected air temperatures from ERA 5. We have collected NDVI data for the cities. What we have also collected is like, and we have estimated what is the change in the cloud cover over these cities over the years, and also how the change in the size of the cities change. You can see that we have a very strong correlation with the air temperature from ERA 5. For the other three, the correlation is very low, close to 0. For the change in city size, here we have like this correlation, but also the p-value is quite significant, but you take this with a grain of salt because we have not adjusted that for the different size groups. We have more cities that didn't change a lot and fewer cities that changed further. But this is like the next step for our analysis. Now, to conclude everything, what I would like to note for you, what is the take-home message is that from the analysis that we have done using these 20 years of MODIS data, we see that on average, all the trends that we calculate and pass our quality control are all positive. And on average, they increase by 0.06 Kelvin per year. The other point is that 5% of the total cities exhibit a warming trend that is greater than 0.1 Kelvin per year, which is extremely high. And the final thing is that the hotspots are usually cities that are located in continental climates, and also cities in Eastern Europe, China, and Middle East. So, thank you for your attention.
Thank you for keeping it in time and for the wonderful presentation. Really appreciate it. I'm sure a lot of us have questions, but if you agree, we'll put it after the next presentation. And I encourage everyone to take notes of their questions so that right after the last presentation, we delve into questions that we might have. Thank you. Mark, the floor is yours.
Yeah, I see that it's already half past, but we started 10 minutes late. So we are still on the night observations now, but with a different perspective. So we have Monica Caffa from ITC, from the University of Twente, and she will explain how the importance actually to monitor this artificial light at night, and why it's so important actually when looking at the global urbanizations. And you will see, I'm sure, very interesting examples.
Oh, thanks, Mark. I hope it will be fun, the presentation. I want to take you to the dark side of the Earth observation. Because I think most of the images we are looking at are the daytime observation and not the nighttime. And I want to share my passion about nighttime observation. So we had, like, in the last 2 years, we're working with a wonderful team around what is called a NIOBI, which is a new Earth observation mission idea. And we have been generating a whole idea about a new sensor system together with a very diverse group of scientists, biologists, people working on astronomy, citizen science, like myself on poverty, on architecture, etc. And we have been heavily debating about, so where does light matter? So we have the side of the light pollution. And I want to ask you, like, have you ever been thinking about why your car windows, front windows, are so clean nowadays as compared to 10 years ago? Who has observed this? The reason is that we have a mass extinction of insects. Biologists estimate that around 90% of the insects are extinct in Europe. And of course, let's say, particularly the night active insects, they are a major sort of driver of this extinction is light pollution. And that's sort of the debate. So we have our friends from biology who want to do astronomical observation. They want to dim the light. But then we have the sides of more people working on global south question. We need light. I know that a lot of you, or a couple of you, have been on Monday sitting in a restaurant with a power cut, and that's the sort of the normal experience of many people in the global south of unstable electricity, of not having electricity. Good, let's go to a bit of the content. So we have been looking into the question of what is light pollution. So light pollution means an excessive use of artificial light, which we see in most of our urban areas. So 80% on the globe, we are living in very light polluted spaces. But we still have a large part of our global population living in areas which are not lighted, and even further, who don't have access to electricity, which is estimated around roughly about 1 in 10 people on this globe who don't have access to electricity, which is a major human development question, a major issue of security, of being active in at night spaces, being able to do economic activities at night, to learn at night for kids. It's a major gap, a major development gap. We have been putting together so this is part of a review, and I have later the QR code of the review we recently did on different aspects, how we can monitor light pollution using ground observation. But of course, we are here on Earth observation, so a lot of the interest here is on spaceborne observation of light pollution. The problem is we are working mostly, let's see if this works, it's cut here. So we have been working mostly in the last year with sensor systems which are very cross, like OLS or VIR, so these are the major powerhouses of our publications on light pollution. Of course, there are more systems now available, which are like a big leap forward is SDG-SAT, which has a resolution of 40 meter, multispectral, 10 meter panchromatic, and you see the massive difference between a very coarse resolution image and a higher resolution image from SDG-SAT telling us about the night light patterns. What can we do with nightlight information? So what you see up there, and these are examples of applications which we have been studying. So we can look into conflicts. We can see the massive disruption of light electricity access in a case of a conflict, which means not only that people are out of electricity, but they're also out of elementary services. And we know this from colleagues in Sudan, which we have been observing over nighttime images, that the electricity cut means no water, no nothing for people. Another aspect is like we can monitoring policies, the success of implementation of policies, like in this case, the shielding of light, which is a major problem of light pollution, is if light are not shielded because they contribute massively to the light pollution, which impacts insects, but also us as humans. Light pollution has been studied in many fields as a major issue of cancer risks and other health outcomes, negative health outcomes. We can also see the seasonality, like in the case of a place in Austria about the skiing resorts, like the seasonality of light pollution with peaks in the wintertime. Or we can see the economic growth, which has been studying in many publications in terms of how areas develop in terms of increasing light in context of GDP. What we are in the moment limited in our studies, and that was the whole context of the NIOMI mission, is that we need higher resolution, higher temporal, spectral, and spatial resolution nightlight observations, which are accessible to researchers for free, because we have systems which are commercially accessible, like quite high-cost nightlight systems, but we need systems like VIRS, which are accessible to a larger research community to really bring the whole scene of nightlight observation forward. And why is this also, and following, I think Thomas was mentioning that cities are roughly only 2% of our globe, but they are a major contribution of CO2, as you see, and particularly the lightening is about 20% of the global energy use, and around 6% of the CO2 emission. If you want to read more about this, we have a nice recent Nature Review publication, which was the outcome of our NIOMI project. Feel free to get in contact with us. I will now go to a passion I have, and my colleague Claudia will later on go more into the slums and the slum mapping. I will go to the other space away from the light pollution to the missing access of light. Very briefly, I'm running out of time. So, as we know that about 1 in 10 living in not electricity supplied areas, and the light situation typically is, oops, I've been skipping over it. It didn't come, no, it didn't come, sorry. So you have data sets like this showing that for the city of Nairobi, 100% of the population have access to electricity, which a large part has access to electricity, most not very stable. 60% of the population in Nairobi are living in informal settlements without stable access of electricity. And we have been exploring this in the last year, looking into what is actually happening and what is the problem. So you see very diverse light sources. They are very irregular. You have a lot of dark spaces which are not supplied with light. You have a lot of unshielded light, so there's also the future threat of the development that you have a lot of light pollution and very unorganized lights, which are again having an impact on biodiversity. But what is a big problem, and these are photos I took in the field in one of the slums in Nairobi, that's how the streets are looking like. Already daytime, going there, I typically, if I have to take a photo, I have to stop because I don't want to fall, because streets are dangerous places. They have electric wire, open wires on the walls. A lot of people are getting injured, killed because they accidentally touch electric wires. If you go in the night looks like this without lights. So we have been observing areas there, having taken massive amount of information about the sources of lights in informal settlements. This is an example of Nairobi again. The major source of lights are coming from windows, not of street lights. We see that we have a massive amount of instability in the settlements, with every second day a power outage with an average duration of around 3 hours. We can observe, if you have high temporal resolution, we can observe conflicts like in Khartoum, where we see in a couple of days the total breakdown of large parts of the cities, which are further continuing to break down. And basically there are cities in Sudan, for example, Nyala, a city of 1 million people, where basically has been vanished. The nightlight is out, 1 million people have left the city. But we also can see, if you have sufficient spectral resolution, the energy shift from traditional lighting to LED lighting. I'm out of time, I'm sorry. We can observe aspects of fires in cities. And the problem of higher resolution, going to higher resolution, is we are all working with the left side of the VIRS type of images. And we assume that the whole city is lighted. While if you go to an image which has about 5-meter resolution, we see that large part of the city is not lighted. It's just a simulation to show how important high spatial resolution is. And I'm almost done. This is an example of a wonderful work of a colleague or part of the team, Alejandro, who has been putting together, and hope it runs, whole Spain of SDGsat, where you can see the different patterns. And remember, the blue light are the LED lights, the yellow light are the traditional light sources. And you can see which parts of the municipality have been shifting to LED lighting. We also further go ahead with combining our data sets and looking into which type of informal settlements and how informal settlements are much consistently having lower lights across the globe. If you're interested, we are now working on a scout mission. We try to convince ESA to get us higher resolution, higher temporal, spectral, and a spatial resolution satellite. Let us know if you're interested to join the team. We are in the moment working on it. Thanks, and sorry for being slightly over time.
Thank you so much, Monica. We really appreciate that. I think it was a very interesting example from my perspective, because I believe more and more we are living in urban systems that are very complex, and different elements, interdependencies need to be investigated more and more. And I think you presented a very interesting and strong case of this light pollution at night. Lighting in general, as you mentioned, is accountable for 1/5 of global energy consumption on the one hand, and the second, the impact of light pollution at night for the biodiversity, which in turn would impact the natural sinks, which in turn, the natural sinks would reinforce climate change. And then I guess like this is ultimately addressing the well-being and health of the citizens. So it's like completely a loop when we look into that. And when we were talking about the outline of the IPCC cities in April in Riga, we were trying to focus on the intersectionality of these topics. We believe that there has been enough of work and research on each thematic area and topic, but the interdependencies are in question. I think what you presented is very much in line with that. So thank you for that. I think with coordination with Francesca, we have 5 minutes for Q&A. So yes, like a sharp 5 minutes. So if there is any question, Francesca says like sharp 5 minutes, no more than that. So if you have any question, it would be great if you raise your hand and highlight which of the presenters are in question. Otherwise, Mark has a ton of questions and he will ask those questions.
Yeah, but we would like to give the priorities to the audience, to the participants. I'm sure you must have some questions. So,
Dennis.
And Dennis first. Yeah.
Okay, thanks a lot, presenters. And since Dennis was mentioned quite a number of times, it's good that I also say something. First, really want to appreciate the presenters for amazing presentations. And from the UNHabitat perspective, I also want to highlight that I'm very happy that we're actually working with everyone, more or less, and that we've been able to convince the different teams to collaborate and work together. And I'm seeing a lot of this coming up. And when Thomas presents and he's presenting about GSL, WSF, Thomas Kemper presents and talking about harmonized definition, and that gets used by other teams. It's really important for us. But my short question maybe for Monica is, with regards to the data for nightlight and economic monitoring, do you think we're at the scale where we can actually start understanding urban economies using this kind of data at scale, and of course considering the huge informal economies actually that are so in some of the developing countries. So it would be nice to hear maybe where you think we are headed in that direction.
It's a very complicated question, yes. I think there are many studies on high correlation between GDP and night lights, but on a very sort of continental, large regional scale, also global scale. What we also have been looking into, another dimension which needs to be paired with such an analysis, is the different cultural aspects of lighting, because different cultures have different lighting practices. So I think it's not a very simple analysis you can do, so you need to pair it with other level of information on a global scale. You can see, of course, in general, if areas develop in terms of economic development, you have an increased light. You have also typically a more regularity of lighting, which has not been looked at very much into it, and therefore you really need high resolution because you see the sort of the very irregular lights, the very chaotic lights, unshielded lights, are typically sort of the more informal type of particularly economies, because typically the small informal businesses at nights, they have very bright lights, but very not organized, not shielded, not very well directed. So this can be sort of proxies about economic activities in the night on a small scale, on a settlement scale, but happy to discuss with you on that further. It's a very complex topic to use it, but I think there are some potentials of using it, particularly if it comes then also to light colors, etc. But the problem, what I want to say also is VIRS it's only panchromatic. So from the available data sources, we don't get any information about light color. Only since SDGsat is available, we have information about light colors which we can relate to different lightning sources, being it electric lightning sources, or in the example I was very roughly showing fire sources, which gives a lot of insights into night practices of people. Sorry, maybe too long, but thanks.
No, I think we still have the time for the second questions, and then I'm afraid we need to stop.
Yeah, okay. Yeah, great.
Thomas has also questions. No.
Okay. Yeah, just one short question to the nighttime land surface temperature in cities. I think one of the results was that it's mostly climate change driven, or temperature. Continental cities are more affected than those in the coastline, etc. Could you maybe elaborate a bit whether it's possible to combine with these IPCC models, whether you can really model maybe how the cities will develop in the next, let's say, 10 to 50 years, whether you could use the IPCC models to just get some information about the future development in cities regarding temperature?
Yeah. I mean, what we can do is we can use our results more or less to guide our attention, because most of the climate models are way, way coarser than the resolutions that we need in order to be able to resolve the city boundaries. And also they don't have like, in most of them don't include like a description of like that there is actual some urban areas there. They're completely ignored. So from what I see is more or less that you can use like the analysis from the LSC data to get some idea of where are the hotspots, what should be like the priority areas, and start focusing more there. At this point, I don't have like a clear idea of how we can start with the analysis from the satellite data, get like the climate projections, combine them, get something meaningful out. Yeah.
Okay. Yeah, great, thanks.
Okay, so I don't know those who are working more on the urban patterns and how they do their projections in the future. So because I know that you work a bit on this. Just this is the final questions, and I think Mattia has also worked on this. 1 minute.
Yes, so I think there's potential to combine those, because we have the projection as 1 kilometer built-up growth until 2100. So those would maybe build a little bit in what you need to look at the extent of the city, and then we would need to see how the climate data could fit into there. But I think there's information now coming that could try to bridge this gap.
Thanks, Thomas. I don't know if Mattia wants to add something. Maybe not. Okay. So I think, yeah, we really need to close, otherwise there will be nothing left at the canteen. So I would like to give a round of applause to all the speakers. I think it was a very nice session. And Francesca, you...
I know it's not your fault, but we are running super late, and we reconvene at 2:40, please. Please, because then we have to do the closing session before everyone departs. Have a nice lunch.
No, wonderful.
It was one of the best sessions.
No, but it's lovely because you're objective and we can talk about it.
tell you
Yeah.
something about this.
There was
very
a
funny.
conversation, but like,
You were not in the demo area, because at some points, you know, the problem with a lot of these project gets. Yeah. So as soon as the project stops, there is no continuity.
Right.
And then so there was Thomas presenting what he does, and you know, it was an user-funded project, so but now they're coming to an end, so you need to find funding whatsoever. And then it was Thomas Sopita, the one data analytics. And then there was Thomas Kemper asking him, how much money do you need? You know what I mean? This is a good question. Yeah, so you know what, he was only ready to support having these tools.
No, absolutely. And I think like I believe like if a collaboration is a they need to work together. You know, otherwise like it's gonna die whatever they're working on.
Okay, so if you have any notes, send it to me.
I think like you already have like I was trying to ask, but they had included in their presentation the key messages points.
Yes, but I did not have the time to go through it.
I think there was like one slide and three of it. But I think like from my perspective, it's just like there's one thing, like the fact that like we need to bring this more closer to decision. You know, and I think we had examples of it, particularly at multi-level governance context.
I have a few notes, but I will know. Francesca wants me to move to the final slides. So you said to move it. So what you said?
I think to add to the to support decision making and governance at multi-level. That's multi-level governance. And further explore the intersectionality of what observations are in the first area. Exactly. Yeah. We all is climate offering and other dynamics and toolkits that we have at hand to address the next crisis. Climate change is one of them. Diversity is another one. Yeah, absolutely. And I would say cross-pollination is also crucial. Cross-pollination to ensure that the tools will interact together. Across the current services and offerings to ensure that continuous service that cities depend on. Cities and national governments and national governments could benefit. Because there's not, and this speaks to the scalability of those observation solutions. Just like, and it's about like this is linked to the scalability of the solutions. But the challenge is like the definition of scalability is sometimes taken as a linear thing. Like the reality is so many of these solutions are being catered exactly to a given context. But then, like you could legit get your document on a drive that is just published. It's not a derivative broadcast, but it's just published and it's recent, or you haven't heard of it. This is not trust. You don't trust if they can keep it safe for you. But you would put it on Google. You know why? Because you understand they have proved that they will keep it for you, right? So I think like one of the challenges that a lot of good solutions will come to its end because they are not a viable, financially viable solution. And this cross-pollination can support the viability and scalability of the solution. And purely I'm talking from practice perspective. As like just like
yeah, they don't think about scalability.
it's the thing. Yeah, they think it like from a spatial perspective, but not from temporal perspective. I'm talking here.
Guys, let's go to lunch because me and you we have to start thinking of the wrap-up session.
have to say goodbye.
No worries, it isn't.
I have to leave to the airport after the lunch. I'm doing a quick.
Are you coming to lunch? Or?
Yes, I'm coming to lunch.
Okay, then we can.
Okay.
Hello and welcome back. If you can please take your seats, we're about to start. So, welcome back everyone. I'm afraid we need to start, although some of you are not yet back from lunch. I hope you had a good lunch. My name is Zoltan Martalis. I work here in ESRIN in Frascati. I have our friend Denis Maniki here with me, and we are going to continue part 2 of the same session, part 2 of 2, so to speak. We are still in the session called Mapping and Modeling Urban Growth, from informal settlements to SDG indicators and global urbanization. So we are going to see 6 more talks, 10 plus 5 minutes each. We decided to allow for questions at the end of each talk instead of gathering them at the end. And first up, we have Jasper van Vliet from Vrije Universiteit Amsterdam, from the Institute of Environmental Studies. Jasper is an associate professor in land use and urban development, and he's going to talk about how to improve the mapping and modeling of urban development for impact assessment. And especially interesting is what he is pointing out to us, that we should not stop where built-up areas end, but we should consider also the urban-rural gradient at the outskirts of cities. So, yeah. Jasper, please.
Yeah, better. Okay. Well, good to see the few of you that survived the lunch. My name is Jasper van Vliet, indeed, and I'd like to explain a little bit about large-scale mapping and modeling of urban dynamics. And I emphasize the large scale because that's, I think, contradicting to some of the work we've seen before on urban digital twins, which are essentially local in a city with a lot of detail, but this lot of detail is at the same time a constraint for applying it on a countrywide or even continental scale. So this is my starting point. This is an animation we made from a land use change model that we built, I don't know, 10, 15 years ago at a European scale. I'm aware there's no legend, but I guess you recognize the area, and red here is urban land, which is expanding. That's not necessarily surprising. The thing I want to point at here is that there is only one color of red. With that, I mean to say that in these models, there is only one type of urban or built-up land, if you want. That was fine 20 years ago. We couldn't do any better. But I think in order to support impact assessments for a range of sustainability challenges, we need to go a little further. Conceptually, this model that I just showed the animation from, but many others as well, work like this. There's, on a, let's say, on a macro scale, countries or regions, there are economic models or other models, typically exogenous to what we are doing, that come up with a demand. Say we need 1,000 additional square kilometers of built-up land that we need to allocate. Subsequently, all these land use models, they are actually doing this allocation. That's the bottom part here. And that works for Dynaclue, which you just saw, but also Metrodynamica, Flood, Geomod, Idrisi, and there's a whole range of models. They differ in their exact allocation algorithm, but conceptually they're all the same. And this concept hasn't changed a lot in the last 20 years. There's been a lot of improvement in the allocation, though. This is really where machine learning and all that comes in. And that's great, but still, it's rather simplistic conceptually. And if you take a look at urban land, and I don't think I need to explain it to you, they vary in much more, or in many different ways, not only in whether or not it's built-up land predominantly, but, for example, also in their density, comparing suburban development with downtown Hong Kong, or in their building quality, slums versus formal buildings, or in their morphology, or in their urban green, or in their land use activities, and in many other ways. Now, of course, you can't put everything directly maybe in one model, but I think these aspects, they are very relevant for a range of impacts. We can do a little more now. That's what I want to show. I seem to struggle a little bit with this control. So the conceptual model that I showed typically relates demands, and demands here are seen from a model point of view, not from an economic point of view. Demands for certain land use related one-on-one, expressed in kilometers, to what you see in the map. So there you get these maps with homogeneous land use types. Now what we did is using a land systems approach, one that has been used before in agricultural simulations, where you also have different land use intensities in different agricultural activities. So the idea is that you can link demands not one-to-one with land uses, but in a many-to-many way. And you no longer need to do that in areas, but you can use real units. So for example, there's simply a number of people that we need to provide housing for, or there's a demand for a certain amount of tons of crop products, and they can be supplied by different systems. Deep rural probably contains only a few inhabitants, but produces more crops. Villages, well, also a little bit of both. Dense urban, maybe a lot of inhabitants, but no crop production. These settlement systems, they are flexible, of course. You can define them for every study, but it's the many-to-many relation that is interesting, because that means that the same demand for population can be supplied or accommodated in different ways. I can have a few areas with high density development, or many more areas with villages. Now, we applied that in a case study on flood risk analysis in Southeast Asia. You see the countries here: Myanmar, Thailand, Laos, Vietnam, Cambodia. So this is what I mean with the larger scale. And here we defined 4 different types of settlement systems on the rural-urban gradient: villages, suburban sparse, suburban dense, and urban dense. Subsequently, for each country, for each system, we used Street View to also characterize their building materials. So we took several dozens of random images for each class and categorized them in terms of whether it's informal, wood, masonry, or concrete. We did that because that's important in terms of the vulnerability to flood risk. Then, as I said, you can accommodate the same population scenario in different ways. So we ran 2 scenarios with the same population scenario, the United Nations medium scenario, just exploring the difference between a scenario focused on expansion versus a scenario focused on intensification. You see here 5 of the bigger cities of the study area, so Mandalay, Bangkok, Vientiane, Phnom Penh, and Can Tho in southern Vietnam. I think Phnom Penh is one of the clearest examples, where you see in the middle a lot of the light pinkish, all suburban or village sprawls along the roads going out of Phnom Penh, whereas the densification yields only a lot more of the dense next to the confluence of the Mekong and the Tonle Sap rivers there. Once again, same population, but accommodated in a different way. You can also see that from the bar charts in the bottom, that for Cambodia there, you see in the expansion scenario a large increase in villages and suburban sparse, whereas the intensification or densification scenario yields a lot more suburban and urban dense developments. And you also see that there's much less area in total used for settlements, even though it's the same population. But now we come to the interesting part. We combined this with already available flood risk maps. So this is the map showing the 1 in 100 year risk for, or the floods with a 1 in 100 year return period. And you see that not coincidentally the A, B, C, D, E, so the cities are all selected on their location in flood risk areas, of course. And we calculated the damage for both scenarios. Actually, we did it for different return periods. This is what you see on the y-axis here. And I take Phnom Penh again as an example, the D column, where you see that the expansion scenario, a lot of the expansion is in the west, which is actually on higher ground, so it's not directly exposed to river flooding. Whereas a lot of the intensification is actually shown in red as damage, which is close to the Mekong River there, which is at risk of flooding. What is additionally interesting is that if you look at the country totals, I showed 3 graphs here, you see in the gray line the current situation, or current being 2015. You see for Cambodia that the dark red line, so the intensification scenario, yields a slightly higher damage on average for the whole country. But if you look at Vietnam, you see the opposite. You see a much higher damage for the expansion scenario. So with this, we showed that exploring different different manifestations of urban development, in this case sprawl or densification, yield very important insights, namely that it really matters which of these scenarios you strive for in a specific country, and that the answer is not clear a priori, because different countries get different preferences in terms of the total amount of damage for flood risk. So with this, I want to end. The paper and the data model are available there. I wasn't so fancy as to produce a QR code. I still have to figure out how it works, but I believe the slides will be shared afterwards. So it's there. My main point, though, is that now, so that 1, we need to account for the heterogeneity in urban areas. And 2, there's a task for us. I see a lot of very small-scale applications where we do that, but there is very little information at large scale and in multi-temporal parts. And it would be great if next time we could actually validate such type of models with time series or whatnot, because now we were well, limited by using a number of street view images only. Thank you very much.
Excellent, thanks very much also for keeping the time. We have time for some questions. Yifan?
Thank you very much for the very good presentation.
Just a second for the microphone for our online viewers.
Yes, thank you very much for the very good presentation. I'm curious if you're able to include the flood risk as a factor when you do modeling, so then you can avoid those areas in both scenarios.
Technically, that would be no problem. I mean, I can include the map and give a kind of a penalty on having certain areas being urbanized. So that's no problem. How the allocation is done here is with a logistic regression. So we look at the current situation where these different settlement systems are located in relation to both biophysical parameters, slope, elevation, soil type, climate, whatnot, and also socioeconomic, distance to road. Well, you know the type of factors that go into these models. We can add them. The question is whether it is actually already included now. I don't think so, because most of the cities are actually in flood-prone areas, because we're typically building them next to rivers and they're typically expanding. So the question is whether it's realistic, but yes, you can easily include it, no problem.
Other questions? Maybe I can ask, is this work thanks to or due to some request from Southeast Asian partners or stakeholders? Are you involving them at the moment?
Yes and no. So this is a follow-up of a project I did for the Asian Development Bank, which is really the type of model that I started with here, just one class of urban land. And it's after that that we realized, well, maybe because after that in parallel I had colleagues working on this agricultural intensification, and wait a second, we need to do better. So strictly this one is just a project out of curiosity. Can we do it? And what is the result? But it followed from a project I did for the Asian Development Bank, and yeah, I'd love to also apply it in these contexts, yes.
Okay.
Thank you very much for this very interesting presentation, because I also work in the same region. I'm very curious about your results. Maybe specifically to my experience in Cambodia, I would like to ask, could you, and if so, how account for land reclamation happening as part of urbanization? Because especially in Cambodia, what we see quite often is that sand is being taken, for example, from the Mekong, and they just fill up the land 3-4 meters. And if you talk to stakeholders, it's like, we made it flood-proof because we basically elevated everything, which coming from a water management background is not that black and white, but I'm wondering whether or not you can include that in these type of model predictions.
Yeah. The short answer is no, because, well, there's a whole set of rules. I explained the basic one, allocation based on suitability, but one of the rules is that we assume if it's water, it won't turn into anything else. Of course, I can change that rule. It's an easy one. I mean, the model doesn't know about water, so I can as well say that it can turn into, but then I need to find a way of how it happens, because otherwise maybe all of the ocean will also turn into land. So for now, it's no. I also think it's a question of scale. We simulate here at a 1 kilometer pixel resolution. I'm not aware of many reclamation areas, not inland, that are of that size. We've done it once in Jiangsu, so a province in eastern China. There, the reclamation is actually of the size that you would want to represent it in pixels. But here, no.
Maybe some of the northwestern part of Phnom Penh that you showed. I think there's a lot of land reclamation that has happened, but I'm not entirely sure about this.
Okay, no, I'm not aware of that, but it would be good to look at. For now, we have a simplistic answer there. We just assume that.
Okay.
That's it?
No, just.
Oh, you have a question?
Yes, I have a question. Thanks, very interesting presentation. I'm just curious. You've used the word intensification, and I've seen in many cities in the world, as parts intensify, the construction material also changes a lot. Are you accounting for like these changes also in the construction material? In like highly intensifying areas, you actually have more sustainable construction. How does also that affect in the model on the assessment of the damage?
Yes. So here, what we did is for each of the classes, we looked at the composition of typical building material. So if a location changes from say, a suburban sparse to suburban dense, we assume that the material composition will change accordingly. We do not account for any potential changes within a class that stays the same. So we assume that the composition for urban dense in Laos now will be the same as in 2040. That might be a simplification. It could even be relatively easy to change, but for now we had no information based on what we could, based on what we should make these changes. So for now we assume that within a class it remains constant.
Okay, thank you, Jasper. Next up, we have Maximilien Huel from an Austrian company called Sistema, and he is going to talk about Sentinel-2, segmentation of Sentinel-2 data, and even enhancement through super resolution. And I'm happy to see another project from our GDA, Global Development Assistance program, which is the program where we, here in ESA, we work intensively with the development sector, with the development banks. Thank you.
Thank you. Yeah, it works. Thank you for the invitation. Thank you for attending this session. So I changed the title of my presentation to fit more a bit with the current activities. So it's a multi-module machine learning framework for urban monitoring using Sentinel-2 that I will present to you. And, okay, this is. So a bit of context of this work. It started with a project named EO for Yemen. The idea was to find new technology, new approaches to support NGOs on field operation. So EO for Yemen, so on the Yemen area. For this project, we started building a Sentinel-2 super resolution model, reaching 5-meter resolution. We created a urban detection model, especially for detecting informal settlements, and use it as a proxy for population displacement. And finally, a change detection algorithm to see the changes over time. Then it continued with the SR4C3, standing for Super Resolution for Climate Crisis Context. The idea was to bring all those innovations that we started with the previous project to the climate crisis domain and also to the security domain challenges. So for that, we improved the super resolution to move from 5 meter to 3.3 meter, and especially maintaining as much as possible the radiometry of our input data. And by maintaining this radiometry, we were capable of doing temporal analysis. So the project that I will talk about has for objective to use the improved Sentinel-2 data to identify the urban extension and at the end build new application on top of it. So here the framework, as Zoltan explained, it's part of the GDA program. So first we have the super resolution module, then we have the building segmentation module, and then we have the change detection. I will go through each module, showing the methodology, showing some results that we obtain, and then having a conclusion and some discussion about each of the modules. So to start, the super resolution methodology. Here you can see, this is working, yeah. Here you can see the data that we had. Of course, Sentinel-2 was our input, and we used PlanetScope and worldview data as reference. Unfortunately, we didn't have much reference data, so to pass by this issue, we created several data sets, and especially this first pre-training data set by using the capabilities of Sentinel-2, the amount of data that we can download it, and we created a first data set with 125,000 patches from 30 meter to 10 meter. It was a way to show the super resolution model, or to maintain the radiometry, but also to improve the input data. And then we had other data set using the reference data, the PlanetScope, and the worldview. We trained an EDSR model, which stands for Enhanced Deep Super Resolution, that we trained, and then we were able to create this application, so this module, where we download Sentinel-2 10 meter NRGB images, and we obtain a 3.3 meter of the Sentinel-2. Here are some results of it. Here are the results over the city of Minsk. And to show those graphs is to show you the similarities between the 10 meter on the top and the 3.3 meter in terms of spectral signature, where we see that the bands are quite matching in terms of radiometry. And here, this image is to show, I don't know if you see it well, but is to show the enhancements in terms of geometry, where we can better define the stadium on the bottom at 3.3 meter. Another example to show some smaller objects. So this is the solar panel field of Warzazat. And you can see here on the left is the 10 meter resolution, and on the right the 3.3 meter. This example is to show that we can go quite down in terms of object detection and spotting smaller objects. As we can see, we can almost, I don't know if we see it well, but we can almost count each solar panel. Then I move to the methodology for the urban segmentation, or more the building segmentation actually. So we had still the Sentinel-2 as input. We make it through the super resolution model to obtain our approximately 3 meter Sentinel-2 images, and we created the first data set with 73,000 patches. For the first model, we decided to go to the OpenStreetMap. We made several tests for pre-training by using land cover maps. But the OpenStreetMap were showing high resolution objects, and were quite fitting with our 3 meter spatial resolution. We decided to make a focus for the first step over Europe, because OpenStreetMap is quite more accurate over Europe. And so we ended up with our georeference building objects. We have to say that OpenStreetMap has some bias, so we know it, and it can impact the final result of our model. We trained a UNet architecture with ResNet blocks, and from that we obtain a second module with the Sentinel-2 at 3 meter, going through the model, getting the building layer. So here an example of the result. So this is an image over Paris at 3 meters, so it's already super resolved. And what we obtain as a result is this kind of layer, trying to detect as much as possible the buildings. Of course, we know there are some artifacts, I would say, but overall we reached 85% of accuracy. And what we were quite interested of is the impact of the super resolution on the classification. And we saw that we get 25% of improvement between the 10-meter models that we created at the beginning and the 3-meter resolution for the building accuracy. Of course, the coverage is over Europe, but as I said, it's high resolution delimitation from OSM, so it's quite interesting for us. And so then with this kind of product, we are thinking already of potential application to perform on top of it. So I will show the change detection that we already created in the past and that we updated with this new model. What we are also interested in is in the computation time, in the computation power, because as I said, it's in the context of crisis. So sometimes we need to deliver quite fast data. It's in the context of rapid mapping at the end. And the computation of the super resolution plus the building segmentation for this specific image with the GPU is about 3 minutes and 20 minutes with the CPU. Of course, it's longer, but we are quite confident that we can go even faster. And then to finalize the last module, the change detection methodology. So we collect several dates. It's temporal analysis, you probably all know, where we have the super resolution, where we have the building classification. We apply some vector operation and pixel analysis, and we define a parameter to determine the type of object we want to check, and especially not the type, but the size of the object we want to identify. If we are working on main cities, we would like to identify bigger objects. If we are working on, I don't know, like refugee camps, we want to precise a smaller object. And we have the detect changes, and we have our final module here. This is an example over the city of Vienne with 2 different images. And I don't show all the process, but I show only the final output that you can see here in blue is the changes detected by the algorithm with the new construction that we can spot here if we compare between the 2 images. Of course, we know there are room for improvement, and as you probably saw also with the result that I show, there are some artifacts, there are some issues we are trying to solve, and especially because each module performance depends on the previous one. The super resolution will make a change on the urban segmentation. The urban segmentation will make a change on the change detection. So we want to improve that. Concerning the super resolution, we are quite happy with the result for now. It's working quite well globally. So we keep it like that, and we make a focus on the building segmentation. The idea is to merge the reference dataset that are available, the open dataset that are available. There are many datasets that we talk about during this conference, the OSM dataset, the Google dataset, the Microsoft dataset that are quite precise datasets over the buildings. And so in this way, we can improve accuracy and coverage. Potentially performing object detection more than segmentation. For the change detection, we are thinking already to move to deep learning capabilities, but same, we need reference data, and this is quite difficult to obtain, especially for change detection. And as I said, we make a point on the computation power needs, and so we want to improve that by potentially moving to parallel computing and being as fast as possible. So to conclude, I presented to you a multi-module framework with the objective to increase the Sentinel-2 capabilities in terms of spatial resolution, capabilities of analysis, and also the temporal dimension by the change detection. And also this framework that I presented is fully automatic. So you just set up one parameter, which is the download, and you obtain your output at the end. This graph is just to explain a bit how we structure the thing. So we have the 3 modules that we already created, and we are thinking at building on top of this module. By going even deeper, there are multimodal modules that are appearing those days. For instance, to go for urban planning using socioeconomic data to merge with the urban segmentation, or even demography analysis and linking population with the segmentation done. And I thank you for your attention. I think I was.
Thank you, Maximilien. Any questions?
Thank you for the presentation. I have a question about the super resolution. What is the generalization ability of the super resolution part? So I'm not sure to which city, which data you use for training, but suppose you want to apply to a new city, would the super resolution perform well? So how does it generalize to African cities, just to give an example?
Well, we try to generalize as much as possible by collecting the reference data all over the world. So basically, we do not have much reference data from PlanScope and WorldView, but we try to collect on different landscape, having data in the north of the world, having data in desertic area, having data with high vegetation. And that's why we created also this pre-training data set with a large amount of Sentinel-2 data. It's in a way that the model already knows how satellite imagery look like and all different landscape look like. Of course, there are some artifacts on the super resolution. We are quite happy with the result we obtained because it works in all the cases that we tried. It was working well. It works with new images. But of course, there are some artifacts. And when I'm talking about artifacts, it's more like when there is a high atmospheric perturbation, for instance. So you have a lot of clouds, a lot of shadows. The model is not really used to it, so it will perform a bit weirdly and create some artifacts. Also over the seas, but in this case, we are not really interested in increasing the sea resolution. But yeah, overall, it works quite well. We made several tests, and but the problem is that if you want to have an accuracy to say, okay, this model is global, you need the reference data all over the world to verify each part of the world every time.
Is the model open? Is the model open?
The model is not open, okay, but the methodology is open. There is nothing amazing in the methodology, especially let's say that the biggest work that has been done was on the data set. Yeah. To prepare the data set as much as possible so that a deep model like the ADSR understand what it has to do. But no, the weights are not open. The weights of the model are not open. Okay. I don't know what will be it will be in the future because we use only open source data. But for now, it remains internal.
You use WorldView images as well.
Yeah.
Those are not open.
Those are not open. And to point the WorldView images. It's really a final training for the worldview. I mean, I can go deeper in the methodology if you want later. I don't know if we have time for that, but
we can talk later.
Yeah, I can explain.
Thanks.
Yeah, thanks.
Anyone else for a very quick question? No. Okay. Thank you, Maximilian.
Thank you.
Our next speaker is Yifang Ban from the Royal Institute of Technology, KTH, in Stockholm, Sweden. Yifang, we've been in contact for a very long time now, and you are chair professor of geoinformatics, and your research is urbanization, remote sensing, as many of us. But you've also been involved as an expert in the UN Habitat's Technical Committee on Human Settlements indicators for the SDGs, and that's what you are going to talk about. Also relevant contribution from Dennis here.
Thank you very much, Sultan, for the introduction. Yeah, this work is in collaboration with Dennis and Robert at the UN Habitat, and also contribution from my team of students. So I would like to discuss what are the opportunities and challenges when we have this Earth observation time series of big data in terms of SDG 11.3.1 land use efficiency monitoring. So you have seen all the background information about, the need for the monitoring and what the challenges we're facing. So I will not continue with that. And also in the last 2 days, we have, talked about the need for sustainable and resilient urban development, and the SDG indicator 11.3.1 definitely can support us towards that direction and curbing unsustainable urban sprawl and maybe make it more sustainable. So yeah, maybe just a brief overview. What is land use efficiency? It's basically the urban land consumption rate to the urban population growth rate. So with this in mind, how do we do this kind of calculation? So we have a lot of data for build-up area mapping, a lot of new satellite data. We have 50 years of Landsat that provide historical trends and patterns. Then we also have Sentinel-1, and now we have 10-meter global urban data set, the WUF and the GSH in a high 10-meter resolution. Then we also have very high resolution with building footprints, the Microsoft building footprints, and also Google open buildings. So we have huge amount of data, great opportunities. We also have variety of population data that's great for this kind of calculation, and these are included in the EU for SDG toolkit. It's collaboration between GL and UN Habitat. So where does a city end? So we adopt this global definition of cities that's adopted by the UN Habitat or UN in general. And it's difficult to draw the boundary. It's not admin boundary, so it's based on population-centered definition. So it's not easy for people to do it, so we decided to develop a tool using Google Earth Engine that can automatically detect the building boundaries, and also users can interact with change if they're not satisfied with the automatically generated boundary. So you can adjust these thresholding parameters and have it change. So that's make it easy. You click select the data set, a variety of global population data set. You can just get the right city definition, and then you select some build-up data set and also higher resolution population data set. You can calculate primary and secondary SDG indicators. You can see here the top is the primary indicator, then we have the land consumption per capita and change in land infill. So if you have a lot of intensifying inside the city, it can also be captured. So then we won the EU for SDG Award 2022, thanks to the community support. And then we selected study areas. Actually, it's a global sample of cities from the UN Habitat, about 1,700 cities. From big to small, the variety of, cover all 6 continents. And then what are the results? So we have done now halfway. In the abstract, it's at 500 cities, so we actually exceeded it. We did 800 cities, but we're not finished yet. So you can see the trend from 1990 to 2000 to the left, and then middle is 2000, 2010, then 2010 to 2020. You can see the bigger bubbles are more the Asian cities, and then the European, the purple ones are somewhere here. And so they're going up and down. So it's now not like all Asian cities are sprawling, and some are densifying. So, but on the other hand, you can actually see the recent trend of maybe like a development of a relatively medium or not the mega cities. Then I thought, okay, maybe we can say, okay, anything over 1 million and the medium 500,000 to 1 million, and the smaller city below 200,000 if there are any trends. It's actually very mixed. So we're going to have to, finish all the 1,700 cities and do a detailed regional analysis, then report more trends, what we can observe. But here you can clearly see some global trends. The higher the land consumption versus population growth are mainly in Asia, and then we have also, the median part in the around here that in other parts of the world, and maybe slower, relatively slower in North America and Europe. So we have some general global trend here. Then we also wanted to do some sensitivity analysis, like GS build, world urban footprint evolution, and Gaia is JRC, DRR, and also Tsinghua University dataset. What are the differences? Gaia is impervious surface, and both GS build and WSF are built-up areas. You can actually see impervious surface definitely give very higher score for the land use efficiency. So that means maybe that would not be the best data set to use for this kind of calculation. Then we also look at the sensitivity to population data set. Actually, it's not a huge difference if you look at the bar. So they are quite similar, the GSH pop, world pop, 100 meter, and GPW V4. And then here are just comparison again to the indicator itself. You can actually see GSH and the WSF are quite similar, and Gaia is overestimating. Then we try to say, okay, if I use different population with the calculation, what will change? They are relatively quite, I would say, quite similar. Then we decided, okay, do a detailed comparison between GSH and WSF. What we saw here is, okay, 1985, 1990, maybe the data are not super reliable because we don't have a very good global coverage, cloud-free Landsat imagery, and also at, So that we have some issues here, you can see. And then another big difference is between 2015 and 2020. That's due to the change of spatial resolution from 30 meter become 10 meter. We have a big difference. So here you can see the variance of these two periods. The others are fine. So then I decided to investigate a little bit more so you can actually see is the city densifying because it's a negative here, the rate. Then we look at, this is from 2000 to 2020 in Toronto. Then you look at 2015, it's positive. So that means there's a difference between 2015 to 2020. Here we can see the difference between the two times. So that's because of the 2015 to 2020. The negative is caused by the latest 5 years. So then we look at the population data set, not much problem, but the build-up data set is an issue. With the high resolution, 10-meter resolution, we basically detected the buildings quite well. We got rid of all the streets, parking lots, all that. So that shows maybe compared to the previous version, 30-meter, you basically lump sum build-up area together that includes streets and everything, the parking lots. So it seems like your build-up area is decreasing. That's because of changing of resolution. So therefore, we have to be mindful. When we go to Africa and some other cities, this example, Kigali, there wasn't any negative. You can see both are positive because the mapping accuracy were not very detailed mapping Africa. So then the red looks fine. So now I come to my last slides is what are the opportunities and challenges we have? We have freely available multi-resolution EO data set, and also some of the planet high-resolution data are also openly available. We also have high-quality building footprints as training labels. We have advanced deep learning models for global urban mapping and change detection. So very exciting time. But on the other hand, you can see this cost inconsistency in data set. We use Landsat all the way, not a big problem, but suddenly we increase the 10 meter, or even with this Super resolution, we have 3-meter global, what will happen? So we have some work to do. So we need novel approaches to improve earlier build-up data sets. So not really we change the 10-meter to 30 meters so we can be consistent. It's how can we use change detection to go back in time to produce high-resolution older data set. So I think that's something we, as a community, we need to work on. And also, in terms of city definition, I've seen a lot of publications, people still use admin boundary or density of build-up areas as definition. They have not adopted the official city definition, so that also causes problems. So therefore, I want at least raise awareness here that when you do the calculation, please use the official definition. And and also the definition of urban land. Is it build-up areas or its imperial surface? And when we collect data set in the EU5 SDG toolkit, maybe we should provide some kind of recommendations. And also existing build-up data set, we put in quite many. There are many data sets, and users have asked me, because even in the tool we developed, we also have variety of data sets. They said, which one do we trust? Which one do you recommend? I said, well, we want the users to choose, and we have actually data set comparison tool. You have satellite image in the background, you overlay the build-up data in your area to see which one that fits your needs better. But then they said, but unfortunately, earlier years, we don't have cloud-free satellite images. That's the fact. So therefore, I think we need to do some kind of independent global validation of urban data sets. I'm calling for action, then we can put some kind of recommendation to the data in the toolkit. Thank you very much for your attention.
Thank you. Any questions?
Hello? Yeah, there you are. Thank you for your presentation. Very nice, and I've been working a little bit on this urban land consumption as well. My question relates to not so much your methodology and the data sets. That's great insights. I didn't know that. It was great to see. But you focused solely on the larger cities. Now, several studies have shown that this rate of population change to land consumption is even more unfavorable in rural areas. Now, I know that each village is, of course, much smaller than Beijing or Paris or Rome, but altogether, it's really a lot of land. So my question is, are you also planning to conduct similar analyses for, let's say, the non-urban part, or is your tool also able to do that? Can I delineate zones excluding urban land rather than only the urban part? Sorry, excluding the big cities rather than only the big cities.
Actually, I want to clarify. Thank you for the good question. Here, some of the examples are bigger cities. But if you look at the whole study area, they're like from smaller cities to big cities. So it's selected through UN Habitat Global Sample of cities. So there are many, majority, I didn't show the graph, majority of the cities are below 200,000 population.
Yeah, okay, but my question was more about cities the size of Frascati, so not even close to the 100,000.
Rural areas. Yeah, they are included as well. But I didn't, I lump sum them together below 200,000. But maybe in the future analysis, we can actually change in scale. Maybe in Asia we do that, but in Europe we make a finer scale. It's a good question, thank you.
Would be great to see that result, thank you.
Yeah, thank you.
Thank you. I actually wanted to come back to this map because you mentioned that there were some inconsistencies due to these negative ratios or the decreasing density, and I see some very green cities.
Yeah.
There's a big one in the Middle East, but I can't see which one that could be. Maybe Damascus, I don't know.
Yeah, so mainly I think some are due to either inaccurate population or inaccurate urban data set. So we need to look it up to see what are the issues. Yeah. Thank you.
Thank you very much. Dennis, you can continue, yeah?
Thank you very much, Ifan. And now we move to another very interesting intervention on a totally different topic by Dilek. Dilek is a research scholar in the Novel Data Ecosystems for Sustainability, a research group of EASA. And she is also managing the Citizen Science Global Partnership. We've heard a lot about Earth observations and related, but not so much about citizen science. So Dilek, we hand over to you to tell us more about complementary of citizen science and EO for addressing the SDGs.
Thank you so much, Dennis, for the nice introduction, and thank you all for being here. My name is Dilek Freisel, as Dennis said, and I work at EASA. I'm also the managing director of the Citizen Science Global Partnership, which I will be talking, hopefully, if we have time, a little bit about. And I'm also working with a lot of the UN agencies and currently with the UNDP on the use of citizen science for addressing SDG data gaps. And today I will be talking a little bit more about that. We've heard a lot about the SDGs, but I know that even in this conference, people were asking me, what are the SDGs? So we tend to, look at it a bit of a broader overview, but we don't really know what's inside or what it entails. So the SDGs are a global framework to address the world's greatest challenges, from environmental degradation to poverty, right? But the fundamental question is, what are the issues with the SDGs? Where are the areas that we need more improvement, policy changes, and so on? So, but SDGs are also associated with a lot of data gaps. So I forgot to mention that we know that there are 17 SDGs, right? We're very familiar with this. But under these 17 SDGs, we have 169 targets associated and also 231 unique indicators under these SDGs. So we're talking about a huge framework that covers a lot of diverse topics. And we're mostly talking about SDG 11 as part of this conference, but actually there are a lot of other SDGs that have very relevant components to urban or to the issues that we're discussing here today. So I will very briefly talk about the data gaps and the SDG framework. I'm not going to go into the details, but these are from the latest two SDG reports published by the UN Statistics Division. And I will only show you in the first one, for instance, if you look at it, I don't know how I could use it, but the gray areas in the first graph show the areas where we lack data, the SDGs. And if you look at SDG 11, which is our favorite SDG, which one is it? Sustainable cities and communities, right? And you will see that the largest data gap in the whole SDGs is actually under this SDG. So this conference is very important to address a lot of these issues. And if you look at the other graph, and this is actually comparing the data availability between 2019 and 2024 in the latest SDG report, you will see that there's quite a bit of advancement in terms of data availability. But if you look at SDG 11, goal 11, still we're talking about huge data gaps. And even when we have data available, this is not really relevant for all the countries or all the cities at the same level. So even when we say available, we need to look into what available means actually. And just to highlight the severity of the problem, according to UN Environment Program, there are 92 environmental SDG indicators in the SDG framework, and 6 years left to achieve the SDGs, because this is a framework until 2030. We still have about half of these environmental SDG indicators like data today. So we want to address these data gaps, right? I'm focusing on the SDGs, but this is relevant to, I don't know, New Urban Agenda or Global Biodiversity Framework or many other global frameworks or, other regional level frameworks also in the EU. How do we address these data gaps? So Earth observations is one way, and this is discussed a lot within the official statistics communities because, countries report on these data. to the UN, relevant UN agencies, and then these are shared globally. But citizen science is not really, or wasn't really talked about when we have been talking about these data gaps. So we've done this study and published this in 2020, and this got a lot of attention actually from these official statistics communities. We looked at the metadata and methodologies of the SDG indicators, 232, that was the number at that time, and we looked at the citizen science initiatives that are taking place at a local, national, and global scale. We looked at the data sets that they produce, and we found that about 33% of the SDG indicators can be supported through citizen science data. And a lot of these data actually can have complementarity with Earth observations data, and we explored that in this particular paper about the complementary use of citizen science and the SDGs and how they could contribute to monitoring or addressing SDG data gaps. And this is just an additional example, but one of the interesting findings, which is very relevant to this community as well, is the greatest contribution from citizen science data to SDG monitoring would be particularly also in SDG 11, sustainable cities and communities, due to the local aspects and community level aspects of citizen science initiatives mainly. But when I say citizen science, people were also asking me, what is citizen science? So in this conference, so it is very difficult to define. There's no agreed definition. I usually take a couple of drinks to start talking about this. It takes a lot of time, but very briefly, citizen science is the public participation in the process of knowledge production and scientific knowledge or scientific research. You know probably more crowdsourcing, community-based monitoring, volunteer geographic information in this context. So we use citizen science as an umbrella term to cover all these diverse ways of engaging public in doing scientific research. But how is this happening? People like, okay, in theory, this could contribute data to SDG monitoring, but how could this happen in real? So we've done this study, or we've done this project and published this in the journal Sustainability Science last year. This got also the best paper award just about 2 weeks ago from the journal. So we work with the Ghana Statistical Service, the Environmental Protection Agency, and other government agencies in Ghana, and involving also UNEP. And we integrated, or the Ghana Statistical Service integrated the data from beach cleanups into their official statistics and into the monitoring of SDG indicator 14.1.1b on plastic debris density. And this is the first time and first use of citizen science data being integrated into official statistics and being reported to the UN SDG global database as country validated data. So we published how we went through the data validation process for existing citizen science data and published in this study. But I encourage you to actually have a look at the supplementary material of this particular table, because we also provided a roadmap and actually a checklist for other countries to use the approach that we use or to adapt it to their own context. And we also published the processes we went through, but also the partners, the collaborators that we work with. This could help other countries, other national statistical offices, and also citizen science initiatives to actually replicate or adapt this approach to their own context, and also to other indicators. This was just only one example. But at IASA, we also have a lot of colleagues who develop citizen science apps. And one of the applications that we use in our crowdsourcing work is PicturePile. And PicturePile is an application that uses or integrates citizen science and Earth observations approaches to address a lot of the research questions that are highly relevant to SDG monitoring and reporting. So we've done campaigns in the past that are about deforestation, about post-disaster damage assessment, you name it, and we published our findings in this paper. I don't have a QR code either, but the presentation, I guess, will be available for all of you. So the thing is, this is also from the paper, so what kind of campaigns we implemented in the past, and some of these campaigns are even before SDGs, and how they could be used to monitor or support the monitoring of SDGs. So you could see which SDG indicators, the data sets that were produced as part of this campaigns or in these campaigns can actually support the monitoring of SDGs in a direct or complementary way. So one of the fundamental questions, though, with citizen science, and maybe this is also relevant to your work, a lot of these things are happening at a very local scale, as I mentioned, and at the community level. The fundamental question is how we could bridge this very local level, community level data collection process and data sets with the national and global level monitoring processes. And this is one of the questions that we try to answer at the Citizen Science Global Partnership, which is hosted at IASA. And it's a network of networks that aims to advance citizen science for a sustainable world. So it's all about scalability of these approaches and the successful initiatives that are actually working well in a particular context. So in this European Commission funded project CROPS, we exactly look into this and we try to upscale successful citizen science initiatives at the Europe level, but also at a global level due to our context with global processes. So thank you all so much, and I'm happy to answer if you have any questions.
Thank you. Thank you very much, Dilek, for bringing this very different perspective to what we've been hearing through the week. I'd like to see if we have questions from the room. Yes, I knew we'd have questions. There's one out there.
Hi, thank you for the presentation. I had a question about the data collection. Did you use some platform or application specified for like incentivizing people to collect the data?
Okay, so in these particular studies that I've shown, not all of the projects are actually, we started to collect data. So where we integrated citizen science data from beach cleanups, we used already existing data from other initiatives that are openly available, and the process of using these data for official statistics was very new. That was our contribution. At that part, we didn't really do any data collection activity. Actually, that was the plan initially, to have more, more observations, but then the COVID hit, so in that project we basically work with existing citizen science data from International Coastal Cleanup, which is a US-based initiative, and they have networks of citizen scientists and civil society organizations using their methodologies globally. It's a huge, one of the biggest citizen science plastics initiative. But at IASA, we have our own projects and citizen science applications. One of them is, for instance, PicturePile, and we have another one, GeoWiki, some of you may have heard of. We have PhotoQuest, for instance. It's very similar to Lucas that we've heard of yesterday, I guess, in one of the presentations, Land Use, Land Cover Area Framework Survey. So we have our networks of volunteers, and so they basically, when we launch a campaign, we reach out to them and they follow us and they know, and then they help us to gather the data. But it's not an easy task to engage many people in the data collection process. So you really need interdisciplinary team, people who have diverse backgrounds, not only developers, but also people who are really expert on communications and so on. But this is an important topic for the field of citizen science in general.
Thank you, Dilek. Do we have another quick question in the room? Okay, if not, we have 30 seconds for your time, Dilek. So I have a question. You present two opposing scenarios, that one, on one hand, citizen science provides among the highest contribution to SDG 11 data. Then on the other side, we are saying that we also have the least data availability for SDG 11. If you are to pick 2 or 3 key things, what do you identify as the break between the high potential for citizen science for contributing to SDG 11 and it actually contributing to the targets within SDG 11? What do you see as the biggest barriers to actually utilizing this huge potential of citizen science to contribute to SDG 11?
Yeah, I think a lot of the issue is about the, people not knowing about this, unfortunately. So within even the UN community, people started to hear about citizen science for the first time from our work. So they were a little bit familiar with citizen-generated data, but they had a lot of issues because these data are, in their minds, collected through civil society organizations, which for advocacy purposes, so they weren't really sure about the quality of data or impartiality of these kind of data that they could use or integrate into official statistics. But more scientific-based approaches through data quality being ensured, and we have different ways to ensure data quality in a lot of the projects we do. So people are becoming more and more aware within the official statistics communities. So I think we really need to make people within the official statistics communities and the UN more and more aware of citizen science and not to judge the whole field about data quality based on a couple of examples, but instead look at the particularities of each and every initiative and the project.
Thank you very much, Dilek.
Thank you.
I truly appreciate because you actually connect in to the next presentation by Claudio Percello from ITC, who is an adjunct professor at the Faculty of Geoinformation, Science and Earth Observation. And Claudio's interests are in machine learning and deep learning for information extraction from remotely sensed data to address the SDGs. And Claudio will tell us a bit about slum mapping.
Yes. Thank you very much, Dennis, for the nice presentation. So today I will talk about Idea Atlas, which is an ESA-funded project, and is about mapping informal settlements. And in particular, I will talk about our user and data-centric artificial intelligence approach to map slums or informal settlements. And thanks to the whole team, so you see the people that are involved in this research. Maybe it's redundant, but just a quick motivation why we are doing this. So I think people in this room are familiar with the challenge. Due often to the rapid urbanization there currently, so a lot of informal settlements and the number of people living in this area is really large. Currently more than 1.1 billion people, and this is expected to increase in the coming years. The people living in this area often lack basic services, sanitization, electricity, clean water, and so on. One of the problem is also that this area are often invisible in official maps. So in many parts of the world, we really don't know where the slums are scattered in maybe large or medium-sized cities. And that's a problem because we really don't have a full understanding of this global phenomenon. So indeed, the SDG agenda takes this problem at its heart, so to say, and in particular, the indicator 1111 aims at estimating the proportion of the urban population living in deprived areas. And traditional statistical methods are based on household surveys, which are very expensive and time-consuming. So our approach is as you can imagine, based on Earth observation and artificial intelligence that allows us to build models that are scalable, more affordable, and that can potentially be applied at higher temporal resolution. So that's the aim of our work, and that's the aim of the project, Idea Atlas. And indeed, we want to develop AI-based methods to map deprived areas from Earth observation data. And in particular, we want to extract information in support of the SDG 1111. Is a relatively small consortium, so ITC, and then we have GeoVille that is also supporting the technical developments. The team is, the core team is relatively small, but we have a large network of international collaborators that help us with the work, and including our advisory board. Dennis is also part of it, and you see other people involved. And Mark, which is also involved in the organization of this conference, is our ESA contact point and project officer. So I'll tell you a little bit more about our study. We aim to have a diversity of different cities, different areas in the world. So we consider 8 cities distributed in different continents. And for each of this city, we plan to indeed apply, develop our method, and derive city-scale statistics. What is important to observe that each of this city has its own characteristics, different local situation that we need to take into account, and that's actually the approach that we take in this project. And in fact, that's why we talk about user and data-centric approach in this project. So our team has put a lot of effort in engaging with the local communities, with the stakeholders. We have organized living labs, and that allows us to better collect information, insight about the challenging living situation of slum dwellers, but also allow us to understand the different types of deprivation that people are experiencing in the different cities, as well as collecting data, which is fundamental for us to build the AI model and validate also our results. We use a variety of satellite data, open data, mostly Sentinel-1 and Sentinel-2. And for the development, for the deployment of the model, we use cloud computing, so that allows us to make the large-scale application of the AI models. In terms of products, by the end of the project, we would like to be able to map the extent of the slums, and also to monitor the developments, the temporal dynamic of how slums are evolving over time. Beyond the binary mapping, so to say, slum, no slum, we also want to characterize more, in particular, the slum severity, or a deprivation index that actually tells more of what types of deprivation are the people experiencing. And at the end, we want to aggregate and derive city-level statistics, intersecting our map with population density to derive the indicator 1111, so the proportion of urban population living in slums. A little bit, not too technical, just to show you the type of model we use. It's a convolutional neural network. I'll skip most of the detail, but just to tell you that this allows us to fuse different types of input data, in principle both optical and SAR, but also we have developed a specific architecture that allows also to regress also the built-up density within the network, which is actually one of the fundamental features to map deprived areas, especially at the 10-meter resolution. And very quickly, but I think it's interesting to look a little bit of our results. These are preliminary results. And what I want to show you, well, is what we obtain in the 8 different cities. And what I would like to point out in particular is the large variability. Now I'm focusing on the F1 score. It's kind of the best metric to capture the overall performance. And look at how large is the variability of the performance. So we have cities like Nairobi, where we obtain a relatively high accuracy, almost 80%. That's pretty good. But we have cities at the bottom here of this table, like Mexico and Jakarta, where the performance is very poor. I think it's important from my point of view to report and show these results, because what we see often in the literature that research groups tend to publish on their results where things work well, when the accuracy is good, but not where the performance is actually not that good. But to give a transparent view, I think that shows that cities are very different, and in some cities, from Earth observation data, we can pretty well capture and discriminate these different types of settlements. In other cities, this difference is much more difficult to be captured. But of course, the idea is to then incorporate additional features, geospatial features that hopefully can increase the performance. But only with Earth observation data, that's obviously the limitation of the technology. And here I just want to summarize the main challenges that we are facing and working on. The first is the definition of what is actually a slum or informal settlement. We know there are definitions given by UN Habitat, but unfortunately these definitions are usually not adopted at local level by municipalities and individual cities. So there is a difference there, and different cities actually have slightly different definitions. Another challenge is the resolution of Sentinel data, 10 meter. We of course cannot capture all the details of roof materials and so on, so maybe we should explore super resolution. And then reference data quality. We know that the data that is provided us through municipalities and stakeholders is often incomplete, it's outdated, and generally of varying quality. In some cases it's good, some cases it's really poor quality. And that's also something we are working on. For instance, here, and in some cases it's just the way that data is collected. So in cities, in some cities data is collected according to administrative spatial units. So the label is given just to the whole unit, spatial unit, but inside the same unit there can be slums and also formal settlements. So that's one of the challenges. And the other, and maybe the biggest, is that not all informal settlements have visible characteristics that can be captured from satellite data. So this is one example from Jakarta, where you see in yellow, this is actually an unplanned settlement, so it's considered an informal settlement, but there is no visual difference from the settlements around it. So it's basically impossible to map this just from Earth observation data. And because of the challenges in data and the poor quality of the data that we obtained from the stakeholders, we decided to develop a portal, a user portal that allows us to better interact with the local communities and to collaboratively add annotations and improve the quality of our reference data. In principle, we will like to do this in an iterative way. So actually, this platform shows the reference data and shows the prediction of our model. And this allows people to see where predictions and reference are disagreeing. So then the people have to look and see who is correct. Is the prediction that is correct, or is the reference that is correct? And with this approach, we discovered in several cases where actually our prediction was correct. So people and municipality and stakeholders had to update their database. And that's actually a nice thing that we can do in support of our end users. I'm not sure how I'm doing about the time. I think I'm late. I'm going to conclude. So we obtain high performance using Sentinel-2 and with built-up density in some of the cities. In some others, as I show, the performance are poor because of the challenges I mentioned before. There are many steps ahead that we would like to start working on. So as I mentioned, iteratively improve the reference data. We would like to, at the end of this process, release a benchmark data set together with a publication. And we are also working in collaboration with UN Habitat to define an Earth observation-based indicator of for SDG 1111. Thank you very much.
Thank you very much, Claudio. Let's see, we have a question from the room. Yes, Ifan.
Thank you, Claudio, for the very good presentation. Also appreciate you not only report the good accuracies, also pointed out the low accuracies. So what do you think? How can you improve these, like cities like Lagos, Jakarta, Mexico City? Is that like higher resolution data will be helpful, or better methodology? What do you think?
Yeah, well, we are trying to attack the problem indeed from multiple angles. So improving reference data, that's often very, very important. We train our model with training data, so that the quality of the training data is very important. Resolution, that plays an important role. We are actually, well, I didn't report, but we have actually also very high resolution images, so we are aiming to compare the results. And often that improves, but that doesn't necessarily solve all the issues, all the uncertainties. And the third strategy would be to incorporate additional features that don't come from Earth observation data, but other sources of geospatial layers that can help us in better mapping and also mapping also the deprivation level, the deprivation index. So multiple strategies that we are planning to adopt. But nonetheless, I think there are elements of uncertainties that escape even these. So we are trying to improve by combining this, but it's a challenging problem. And we need to say this also, right? So.
Thank you. Yes, Thomas?
Thank you, Claudio, for a nice presentation and a realistic presentation, because we also have some experience in this area. So I was just curious, because you mentioned slum severity index, which obviously it's very difficult to fill in with the data, because you need basically data about the water, sanitation, etc. So I was just curious also in relation to this citizen science presentation, how you get these data? Do you use the households data or surveys, or did you try to really, because you mentioned the portal, which yes. I think it's close to some citizen science way of getting these data, because we always struggle to find the right way to get this information. So how you approach that?
In this project, we are try to use as much as possible open geospatial data, but so Monica also has another project where they use indeed citizen science to collect this kind of information, and I think indeed citizen science can help a lot to better understand this deprivation level and the different domains of deprivation.
Thank you very much, Claudio.
Thank you.
Do we have another question in the room? Okay. Thank you very much, Claudio. I am too invested in this process, so I will just, I will not ask you, but just say that we are building this global consortium of people working in slum informal settlements mapping as UN Habitat, and we welcome any person who is actually interested to be part of this process to also join. Feel free to reach out to Monica, Claudio, or myself, and we'll be able to give you more details on this. Thank you, Claudio. Finally, last but not least, we have an amazing presentation by Anand Garaya. He's a data scientist working at the United Nations Innovation Technologies Accelerator for Cities in Hamburg. And he will tell us a bit more details on, again, informal settlements mapping with high resolution imaging.
Yeah, hello. Yeah. Good afternoon, everyone. I'd like to begin by introducing UNITAC. So UNITAC is a collaboration between three organizations: UN Habitat, UNYCT, and Hafen City University in Hamburg. We are supported by the German Ministry of Foreign Affairs, and UNITAC is a part of the People-Centered Smart Cities flagship program by UN Habitat. The main focus of this program is to ensure that the cities of the future are inclusive, sustainable, and designed with the need of the people at the core of the development. Now, moving ahead, I would like to talk about what we do at UNITAC. So our mission is to support the national and the local government in their digital transition by working closely with the cities and the data. We focus on a key question that how data and urban technologies be leveraged for better city planning. And so for that, we develop and utilize advanced tools for mapping, spatial analysis, and data visualizations. And with the support of that tools, the government can take better decisions in their urban planning efforts. Moving ahead, I would like to explain about one of the first pilot project of UNITAC, that is the BEAM tool. So our key partner in this project were the Human Settlement Department of eThekwini City in South Africa. The main objective behind this project was to ensure that the government has the idea of the dynamics of the informal settlement, and based on that they can make efficient decisions in their resource allocation and planning of the informal area. So before going into the details of this project, I would like to give you some background on this informal settlement. So, in eThekwini City, more than 25% of the population resides in this area. And due to that, they face a lot of challenges like lack of availability of clean water, electricity, improper waste management facilities, and substandard housing. So to encounter this issue, eThekwini municipality launched an informal settlement upgrading program that can help to improvise the current living conditions and provide the good essential services to the residents living in that area. However, for this initiative to succeed, they need up-to-date and accurate data on the number and the location of the informal settlements. So, but they face a lot of challenges on that. Talking about the challenges, one of the key challenges in managing informal settlement is mapping and monitoring its growth. So, what did they do is they hired 15 land monitors to collect this kind of data by doing on-ground surveys. However, considering the size of the area and the changes and the rapid changes that are occurring at that area, it was very difficult and time-consuming for them to collect this data. So at the end, the government ended up with outdated and inaccurate data and were not able to provide essential services to the residents. So here, UNITAC came into the picture and developed a deep learning-based mapping tool to support this initiative. Now, coming into the details of this tool, so this BEAM tool was trained on a very high resolution aerial imagery provided by the municipality. Talking about the resolution, it was of 10 centimeter resolution and was captured in the year 2020. And we did some, we added some supplemented data like open source data from the RAMP project. And after that, talking about the ground truth data, we manually labeled around 3,062 buildings on the image representing 1 square kilometer on the ground. Now moving ahead, talking about the model verification data. So we created a holdout set from like another image that was captured in the year 2021. The resolution of the image was of the same quality as it was for the training data that was captured in 2020. Here we manually labeled 447 buildings on the image representing 300 square meters of the area. Moving ahead, we used HRNet model to train the beam tool. And talking about the results, so we already had one mapping tool that was trained on another similar kind of data. And in that, we just passed the model verification data of from eThekwini to that model to test that how that model performs. And here we noticed that the accuracy that we got was average, like the pixel accuracy and the feature counts. So we thought to train the model on the original data set, and there we received high accuracy on pixel-wise, but the feature count got decreased from the baseline model. So we thought that what is the reason? So if you see in this green area, that is the model prediction, the model is not able to segregate between the edges of the building. So here some improvement should be needed. And so here we tried to change the training pipeline by tweaking the data augmentation and data pre-processing part so that the model can understand the edges of the buildings, and the results were improved because the pixel accuracy got to 89% and the feature count got to 72%. However, we were still not satisfied with the results, so we tried to do some more changes to the process, model training process. And here what we did was we added the open source training data that I talked about, the data from the RAMP project, and the accuracy of the pixel got increased by 91%, and the accuracy of the feature count got increased by 97%. And this model was performing well on the verification data, and then we deployed this, and currently eThekwini is using this model in their mapping and resource allocation process. Moving ahead, we expanded this project to Central America, where our key partner was UN Habitat Mexico. The use case was quite similar. However, there was changes in the type of the image and the type of the settlement that in Central America was. So talking about the imagery, we received the images of Maxar Worldwide 3 imagery, and it was provided by UNOSAT. We did some, as you can see that in this is the original image that they provided, and the resolution is not very good, so we just did some processing on that image to make it more understandable by the algorithm. And then talking about the training data, so we manually labeled the image tiles using Label Studio software. Here we added one more class in addition to the building class that we have. We added the edge class in this to improve the model accuracy while predicting or separating the building from each other, as it was a very dense area. And talking about the training data set, we use 1,082 image tiles of 256 cross 256. We also supplemented this data with the RAMP open source data. Then for the model verification data, we used 262 image tiles of same size, 256 cross 256. After that, we did some modification into the inference pipeline to separate the buildings from each other for better visualization at the end. So here the priority was to separate the buildings in highly dense area. So we used the inverse edge probability combined with the building probability to improve the accuracy of the model. And after that, we did some morphological image processing on the results to improve to have better visualization. And here are the results for the model. We achieved good results on this Central America data. And yeah. Thank you for that. And I would like to give credits to Michael Hetton and Sophie Noy. They are my colleagues, and they have actually worked on this project very hard, and I would like to give all the credits to them. Yeah, thank you so much. Yeah.
Thank you very much, Anand. And I know the pressure of being the last speaker when Francesca wants to close. So I will give room for one burning question for Anand. And I'll give him 30 seconds to respond. Question? Okay, if no question, I will ask you the question. Only 30 seconds for you to respond. So given the super high resolution requirements for the BIM tool to work, and also the need on the other side to do this slum mapping, informal settlements, mapping market, global scale, how scalable is it? And I mean, what kind of thing do you see us needing to actually be able to apply this?
So as per, first of all, it's a good question, and it should be addressed because whenever we do like a mapping of this informal settlements, informal settlements, I would say it's everywhere over the globe. So to make it more scalable and to make it more generalized, we need more data. And if we have data, we need more like highly like a GPU or something that do high computational power on this data to generate the preferable outputs. So based on that, I would say that if we have these two things with us, we can make it more generalized. Otherwise, it becomes very difficult to make it more generalizable. Because as you can see, that we did the mapping process in eThekwini and in Central America. In both of them, the model were same. We use HRNet model. However, when the data changed, everything changed. The training process, the learning rate, and everything changed of the models. So this tweaking would be there if you want to make it more generalized. So yeah, thank you.
Thank you. Thank you very much. Zoltan,
Yes, thanks everyone. Thank you. A big round of applause for all the presenters. Also the first part of this session before lunch. Thanks very much. And I invite, thank you, Dennis. I invite my colleague Francesca to start the wrap-up session.
Thank you. I do not like this role to put pressure on people. It's not the easiest. So thank you for everyone for still being here. We are at the closing session, and the first thing I wanted to bring to your attention is that this year for this conference, we decided together with the program committee to not spend our budget on gadgets, so a bit of a different approach, because I think that nowadays everyone has water bottles from other events, and we don't need other gadgets to, let's say, leave on our tables at home. So if we want to be, let's say, we claim we want to be sustainable, so let's try to act as the most we can in this direction. But since we did have a budget dedicated for gadgets, which is 3,000 euros, we thought that the best way to use these was actually to devolve them to an NGO that was working in a context close to urban and close to the objectives of our workshop. So this was a decision taken by the program committee. Just to give you a quick outline, we have selected some entities that were close to our objectives. We have asked them to give us a contribution and tell us a bit what projects they are working on and how they would have eventually used this grant. And I am very pleased to invite to speak Ms. Daniela Melandri, who is the President and Executive Director of URBIS24, who was selected for this grant, given the explanation both of the entity and of the project. But I will not spoil her introduction, as we have the pleasure to have her with us. So welcome, Daniela, and the floor is yours.
Thank you. Thank you very much. Thank you for the invitation, and thank you for selecting us for this grant. It's absolutely an honor for us being part of this community. Just a couple of words about who we are. We are an organization which is called URBIS24, and the clue is a bit in the title. We work with cities around the world, in particular in Europe, but not only, to deliver more inclusive, greener cities, and so cities fall basically. So I was very, very interested in listening to all the presentations because they very much align with part of the activities that we do. We work in particular on 3 areas of in reference to the cities. We work in the participatory activities involving citizens in order for processes, solution services to be more inclusive and more co-participatory and co-creative. We work with data, which is basically the reason why this connection has been established. And we work with data that we see, and we work with data that we don't see. We work on the basis of the fact that data define the world, as we say, but shape the world. And when we don't have the data, we are making the world or part of it invisible. And most of the times in cities, this is related to the vulnerable groups, to neglected areas, to areas which are deprived. So the non-data is part of a very, very important task in our work, in our daily work. And third, we are architects, engineers, so we do design solutions for cities, especially in nature-based solutions, in order to create better places for people and for vulnerable groups particularly. So this is a little bit about us, and I'm happy to share the information about what we do. We are mostly funded by the European Commission, so we work with projects, and we are running, and we are the scientific and division coordinator of a big project which is called Diversity, and it's all about what I've just explained. In this project, we have created an index, and this goes to the grant that we have received. The index is called the Diversity and Inclusion Green City Index, and is an index that combines the different layers that have been discussed even today. The social layer, the health layer, the environmental layer, and the economic layer. And again, it does take in consideration data sets coming from cities, and it does take in consideration the non-existing data sets that cities cannot access to. And therefore, it creates an opportunity to understand how the cities are doing, especially when it comes to inclusion and when it comes to matching inclusion with green spaces, because as we know, most of the cities in Europe for sure, but not only, have a lot of green spaces which are in the rich areas of the cities and not in the most deprived areas. So this index does help policymakers in order to create better policies and advise them on refining their decisions. We are going to use the grant. Thank you so much again for giving us this opportunity for the last mile of this very long journey. The European Commission has funded this index, as I mentioned, but has funded until the TRL 8, which means that this index is almost ready to go. But of course, that needs requires the last part of the go-to-market rule, and this is how we are going to use the funding that we have received. I hope I'm happy to answer to any question.
Thank you, Daniela, for this explanation and for your time. It's really a pleasure to bring, let's say, to be helpful in bringing this index to the last part of the journey. So we are very happy to even being able to contribute to your objective. So thank you once again, and I would invite us to applaud once more to universities.
Thank you.
Okay, so you have been through many sessions these 2 days, and I would ask the session chairs who are still in the room if they can come closer to wrap up the sessions in 1 or 2 sentences with the key summary and recommendations. So if you want to get closer, I know that not everyone is here. So as a disclaimer, we will anyways put online all the material of the wrap-up. But since someone is still here and we are able to hear the wrap-up from them directly, I would ask you to come closer. Thank you. All of the session chairs who are in the room. So Mark, Stephanie, Romain. While you do this, I take the opportunity to thank some people who have been very precious in the organization of the whole workshop. I have already thanked the program committee and the scientific committee at the beginning of the workshop, but I really want to thank all the supporting teams, and specifically Irene Renis and Sabrina Lodadio. Sabrina is down there. She's been doing all the back office. Irene is not here, but she's been working behind the scenes in the past month with me. I want to thank Riccardo Sonnino from Olli, who has placed all the organization in the room and having everything going smoothly. So I don't think he's here right now, but anyways, thank you, Riccardo. I want to thank UGB that has created all the graphical material for this event. So the amazing team that even last minute has placed everything correctly. So thanks specifically to Georgia. Thank you. And then the technical team down there, so JBJ Production, Jacopo, Bogdan, Stefano, and Thomas for all the support. Thank you very much. Okay, so let's come to the session wrap-up. Session 1, I know that Claudia and Efren are not here, but you heard from Efren this morning. Session 2, not even, so Olivier and Kavita are not there. So I would propose to go with session 3, Stephanie. Thank you.
Okay, thank you, Francesca. So session 3 was about urban energy landscapes and efficiency mapping. We had a lot of fantastic presentations on new products, new services, including, for example, analysis of solar power potential across the globe, assessing energy efficiency and renovation needs of building stock using different data, for example, street view data, satellite data, thermal data, both from satellite as well as collected in a citizen science approach, as well as also the thought of that the urban energy landscape is not only represented in the urban area itself, but as urban areas have the highest demand for energy, how rural areas or renewables that are close by urban areas can be managed and spatially distributed to better serve urban areas as well. Then a big, nice summary presentation was given on the different scales and the questions, problems, challenges, data sets that can be used at different scales, from international to hyper-local projects and activities across the globe also. And some of the highlights were that satellite data can already play a key role in regional level urban emission monitoring for decarbonization, that we have a big potential for EO data in scaling, not only geographically, but also in terms of timely responses, that urban energy management is supported both by applications and analysis, again, within city boundaries, but also outside of direct city boundaries. And then recommendations generally were given that information services, such as provided including Earth observation data, can be used as evidence to support decision making, specifically when communicating with and towards citizens. We have the challenge sometimes still that computational load, for example, for creating solar energy potential map is a challenge, and that there is a need to transition to workflows better and more towards high performance and optimized processes. We sometimes still notice that there is a mismatch between the expectation from practitioners receiving information quickly, but then also the willingness to pay for the processing of that information. Then again, that urban energy transition is not only happening within cities, but also outside of the city. And that sustainably cost-effectiveness and guaranteed operation of data products are crucial for the uptake of these services, products for practitioners. And then also that cities ideally must be involved as early as possible in the process to secure, for example, investments for ongoing operations, or also instead of cities, intermediary actors like national institutes or regional or local agencies. Okay, that was the wrap up of the session. So back to Francesca.
Okay, session 4 is me. I didn't really have the time to do a structured one, so please excuse me for that. But I would say as a very quick message on the urban green infrastructure session that there are very interesting applications that can serve as a decision support. We've seen works on different tree species. We've seen works on different park forms and the importance of how big a park is in terms of cooling, and other aspects such as keeping in mind all species when thinking also of the urban ecosystem. So there are different aspects coming from the session that can serve as decision making. So I see a lot of space in actually targeting the user community interested there. But you have to wait a couple of days to have the nice wrap up on the website. So I would ask instead Thomas Kemper for session 5. Thank you.
Thank you. I'm in the same boat. I didn't manage to put this into writing, so I have to live with my notes, and I also didn't have time to discuss it with my co-chair who's already traveling back. Anyway, we had an interesting session on disaster, urban hazards, etc. 6 presentations, 4 of them on subsidence, so a bit imbalanced, 2 others on floods, and maybe this is already a recommendation for the next session. There's also other urban problems. They were partly covered maybe also by the heat sessions that we had, but I think we can be more creative on broadening the urban hazard potential. Nevertheless, there was really interesting contributions on the subsidence in the wider context. So there's of course the presentation on the Copernicus service that provides really European-wide information on ground movement, and we have seen several of the applications and some of the other presentations also making use of that. So that is really good to see that there's data out there systematically collected that is then also picked up by others. On maybe some innovations there, or some very, very good approaches. There was a study that looked at different levels. So really starting from the national assessment, then going down to the regional and to the very local. So really not just nitty-gritty detail on one sinkhole, but trying to put this in a broader context. And another case study also tried to combine the risk with also sustainability concepts at a sub-city level, so that different quarters of the city were assessed. And that is information that I think is then something that really can feed into also decision-making processes at the city level for the mayor's office. For the rest, the subsidence is maybe not the best example for direct contribution to the political guys, because it's still quite complex. Then on the flood side, we had two very different applications. One pointing to the importance of secondary cities in the global south that are totally underrepresented. I mentioned already, Karen Sete was also hinting to that. We have very few studies on the global south in the first place, but then they are sort of talking about very few places, big places, while the vast majority is forgotten. So we had here examples from Laos, Cambodia, and Indonesia, showing also on how with relatively simple methods you can really provide important information for those cities. And then the last presentation was more high-tech, trying to use machine learning to come up with prediction of flash floods. So when we have situations like yesterday here, pouring down suddenly huge amounts of water, and where will it go, where will it flood? And that was something that I think has also some potential. It was still in an early phase of trying to get it going, still struggling with high-resolution elevation data, where you have a bridge that then in such a model suddenly functions as a dam, which it is not, but those things that still need to be tackled. But I think something that once those things are solved can really help then also civil protections to understand better what will happen. So I think that's it from my side. Thank you.
Now it's Mark's turn for session 6 on global urban development and dynamics.
Yeah, I was a bit more lucky because we had some introduction slides to the sessions. So actually I have even too many slides to show. These were we tried in the sessions to give a user perspective from the very start. So Puria from ICLE, who was my co-chair, actually highlighted a number of points that, and I show in yellow really the most important ones. The session was about the global urban development, so essentially the urbanizations globally, so the availability of global data sets to study the global urbanizations, and which is a very key topic, because I mean we know that urbanization will still intensify in the future, especially in the global south, and is going to cause a lot of problems, especially from an environmental point of view, but also from the welfare of the people living in the cities. And it was already highlighted from the start that Earth observation and remote sensing can revolutionize the way we can monitor urban growth at a global level. So we had the objective of the session was actually to discuss what is available in terms of global data sets on the urban developments, of course starting with the human settlements. We have many data sets, and these data sets has actually been mentioned many times in a lot of the presentation during these workshops, but we also discuss the derived products from this, like imperviousness and population grids, and also other type of data like artificial light at night and land surface temperatures, but always with a global dimensions, let's say. So what we wanted to say is that the availability of these data sets, what we can do with it, and what are the practical applications. So what are the insights we can give on the spatial variability and temporal dynamics for urban development processes. So the session was organized with six presentations. 4 were essentially on the human settlements from the data set perspective, the global data, and then from the use of it in different contexts. And then we had the last 2 presentations were on nighttime observations. So we had land surface temperature on one side and the night lights for the last presentation from Monica. This is a summary, so we can say that these global data sets are very important to understand the processes of global urbanization, the changes. Actually, during the presentation, we made also some reference to some very detailed global data sets that are available, especially from Google and Microsoft, but it's a sort of one-shot exercise. We don't know if they will redo it. It costs a lot, of course, to do it, while what we've been doing with freely available data sets, so with the Sentinels essentially, but also Landsat going in the past, is actually looking at the change, and the change patterns is very important. So we stress very much on this. And we can say that these global data on urbanization trends are available. They are available, and much more is to come. So there are still development, there are already development done by the various developers. And we can say that these data sets, especially, I mean, the one that we saw, which is the global human settlement layer from GRC and the world settlement footprint from DLR, are already of excellent and quality control data sets. So this was acknowledged by many. And there is now, the GHSLs moving into this new Copernicus service on human settlements that will soon be available. What was demonstrated is that the spectral, temporal, and spatial features of the Sentinels, and in certain aspects also of the Landsat for the past urbanizations, allow to monitor urban growth globally. It was emphasized as well that it can be strange to think about dense time series for urban, but actually having the dense time series allows actually to discriminate better urban areas from non-urban areas, and gives a lot of important information. So there's been a massive processing, which caused some challenges, of course, to be addressed in order to go global. So, of course, from an algorithm point of view, you need to have a solution that works in different environmental conditions and different urban fabrics, but is extensive from a computing perspective, especially if you want, by using the machine learning techniques, and if you want to move to deep learning, which is even more demanding. So, the key message is that the methodology needs to be really cost-effective and transferable. For the nighttime data, so we focus essentially on land surface temperature for the looking at how has been the warming of the cities over time, and the night lights data as well. There's multiple urban applications we can do from these data sets. Of course, we can look to use this data, especially in the global south where there is not much data, to look at disaster risk reductions. So you use, especially for the exposure elements, but it can be used also for some indicators. So in the new urban agenda, but I would mention the 1131 that was shown by Thomas on the SDGs. And of course, the city warming trends, as I mentioned. For the night lights, there was a lot of different applications that I was not expecting. So here, when you see them, economic growth, conflict, the shielded street lights, I didn't think at that once, and the seasonality due to tourism, as you see. There's plenty of information we can have, but the very important one is probably to really see what's happening in the global south, because we know that they have less access to electricity. Of course, we need to make these data sets accessible in a seamless way to urban practitioners. For the end users, of course, this would allow them to focus on the problems they need to solve, but it's also important for the research community, and we've seen a lot of researchers doing the research based on these data sets. So the recommendations, the very first one was, of course, to have a bit more collaboration between the different data sets developers. Then, of course, we need to be very honest on the strengths, but also on the limitations of these data sets and their use. It was emphasized that data is large and complex. In this case, I mean, for example, the WSF data that looks at the evolutions of urban data over 35 years. I mean, they've processed 7 million Landsat scenes, just to give you the dimensions of the data that is processed. Of course, nobody can do this, so we need to make this data easily accessible and integrate it into data analytics tools in order to make it usable by the city and the urban practitioners. We need to collaborate well with organizations that can act as multipliers, and we we saw the example of the urban habitat and the World Bank, at least for the global aspects. Access to reference data, this was stressed many, many, many times. As soon as you do machine learning, you need your reference data. This is very, very important. And in this case, as I mentioned, they all were using actually data from OpenStreetMap, Microsoft, and Google. And the last one from our colleagues who was showing the night lights that, yeah, you need a better sensor, especially in terms of spectral and spatial resolutions, but I understand that you will propose scout missions for this, so, and I wish you good luck on this, and I will finish with this.
So next session, mapping and modeling urban growth from informal settlements to SDG indicators monitoring. So that's Zoltan and or Dennis.
Well, we just finished this session minutes ago, and it was a natural continuation of the previous session as presented by Mark. I think the findings and the conclusions are valid for our session too. We had similar global data sets being presented and analyzed, and a few applications. What I wanted to add that maybe hasn't been mentioned was we are transitioning now towards higher level products that are multi-source. A lot of data sets are being fused together. It's a really good development because we have to stop just producing maps. We need to go away from this simple land cover, land use approach and creating higher level analytical products. But with that comes also come a lot of problems. How do we make sure that the inputs are the right ones at the right scale, right observation frequency and so on. And an additional aspect is that we are now working more and more with enhanced inputs. So the inputs themselves are enhanced even in terms of resolution. We've seen applications, examples of Sentinel-2 being enhanced spatially 3 or 4 times. And that, of course, is the quality of those data sets depend a lot on the training sets that are being used. We've had specialized events on that. Earlier this year, we had the URBIS24 event, and we hope to see more of those presentations and initiatives and events. Again, we are working more and more. We would like to work with partners who are starting to use these global data sets on an institutional level, such as UN Habitat, also the development banks who are on one side, they are trying to understand the trends and the priorities globally, trying to benchmark various urban areas against each other, but also in their client states, they are supporting their client states to prioritize investments. And it's very important to be able to have common definitions of what an urban area means, and what are the parameters that best characterize not just cities in one country, but regionally and globally. And I think we've come a long way, and we should see these emerging global data sets not as competing with each other, but complementing each other, and that goes for not just for the direct urban areas, but also, as we've heard in the session, we are now also differentiating between the involving more and more the peri-urban areas, and studying also the linkages between urban and rural to get a more complete image and snapshot of the cities. Thank you.
So session 8 on commercial EO data and services for urban contexts. Romain.
Hello, everyone. Yeah, thanks for staying until the end. You're all very brave. Our session on commercial EO data and service provision was introduced by my colleague Peggy, presenting the data procurement activities we have here at ESA, one third-party mission for research and development purposes, and the Copernicus contributing mission for the commercial data provision complementing existing data from Sentinels dedicated to the Copernicus services. And we had the honor to host 4 data providers from different companies, SatView and Constellar, which are thermal data providers, EGEOS, who presented us with their SAR capabilities, and Prometheus Intelligence, new space multispectral company. What they all have in common is that they are data providers. They're building their own constellation, for some already operating some instruments. And they are also integrating the development of dedicated products for which they have a lot of relevance for urban contexts. So those commercial companies, what they do is, as I said, primarily provide data, but also really thinking about how to develop those simple way of integrating data in solutions and bringing value-added services to the community. They're highly relevant to those urban monitoring applications. Along the conference, we've had a lot of presentations talking about thermal and infrared data in particular, and the relevance for urban heat islands and climate change applications. We also had a lot of posters talking about these data, but also the limitations of using these data and how it's necessary to increase the quality of these data, the resolution of these data. So those companies are actively providing and working into developing this constellation in this sense. We've had some nice demonstration of SAR interferometric applications and even more applications in the optical domain. What we noted is that there's a huge complementarity between those companies that we consider as established companies operating their systems since a long time. They sit on a huge archive, providing a wealth of information that is available to a certain extent, which can be really, we can very much dig in intelligence and prepare AI applications and everything. And the complementarity from emerging suppliers comes from the novelty and innovation they bring in the new sensor domains. Launching a 100 satellites constellation of thermal infrared data has never been seen before, for instance, but also new products with onboard capabilities, onboard AIs, inter-satellite communications to increase the way we acquire the data and treat the data. Some of the highlights, not to repeat, but those companies are shaping in part the future of high resolution data, as I mentioned before, not only in terms of spatial, but also temporal and spectral, higher visits. There's a lot of innovative approaches. It was very interesting to see that actually the offer meets the demand in the room today. We had a clear interaction during the presentation where a few people from city councils were actively asking to collaborate. So I think thanks, Francesca, to bring us to this workshop, because it actually emulates a lot of things, and we had a clear demonstration of this. And one of the key points that I noted was that not enough large cities take advantage of these existing data and new data, and we need to ask why. I didn't have time a lot to really scratch my head around this, but there's probably a lot of communication and promotion issues that have been the case for a long time. So we need to maintain our efforts in this direction. But there was also potentially also a lack of expertise and time that we also need to provide and bring forward to those people. And generally speaking, the engagement in the room was excellent. So thank you for all the participants who brought their question and interest to this. And finally, I will not spend too much time on the recommendations, pretty high level, but I think for the people who are interested in the research, it's important that you check what's available in the third-party mission program. It's fully sponsored by the agency. There's a lot of data, a wealth of information. And I've taken a few comments from colleagues during the events that there's some limitations to the program, but we're actively working to change that and improve the access to the data. Thank you very much.
So, session 9, innovative downscaling and AI techniques. Thank you, Nikolai.
Hi, everyone. I have some slides. I don't know if they're... OK, they are ready. OK. Yeah, OK. Thank you all for sticking until the very end. And this session was slightly more technical than the rest, I feel. And the recommendations might be slightly more technical as well. The title of the session contains both downscaling and AI. And downscaling is quite interesting because in many problems we're dealing with, there's the trade-off between dense data that we can easily access, like Sentinel missions, and the very high-resolution data sources where we can get very fine-grained information, but that obviously comes at a cost. So downscaling techniques might be a way to kind of find a trade-off and bridge that gap. And that's why we've had this session that kind of involved both AI and downscaling. So the session involved presentations of several works where super resolution and downscaling of satellite imagery plays a key role in understanding and processing of urban scenes. For applications such as material building, material segmentation, building footprint, change detection, tree inventory, roof segmentation, and urban dataset curation. There were 4 presentations included in the session, starting from URBIS24, a library of hyperspectral material measurements, where this library of physical measurements that were taken from the ground of existing materials in urban scenes was used to actually build maps of materials at large scale without any sort of like deep learning or high-level AI involved, just by kind of taking advantage of high-quality data. The next talk was about change detection of building footprints from super-resolved Sentinel-2, and this was an interesting use case where multiple AI models were put together in order to create a pipeline where super resolution was just the first step in order to go from Sentinel-2 to high-resolution data, which was then followed by building footprint extraction and finally change detection. So it was an interesting use case where of how people can put together existing AI models without training anything to potentially create impactful tools. The next one was about single image super resolution of Sentinel-2. This, again, I think Zoltan already mentioned that we've had a specific workshop on super resolution here at ESA, and this is a topic we are investigating quite heavily, involving multiple projects. And Sentinel-2 obviously has a very unique value and coverage and accessibility. So this is one of those works where we can potentially make an impact by taking advantage of Sentinel-2 and mapping it to a high resolution or predicting what it could look like at higher resolution. The usual issue of data limitation, ground truth was mentioned as always, and again this belongs to the problems that are currently addressed by the research community. Finally, the last talk was about cloud-based satellite mapping workflow with a human in the loop, where machine learning was used to basically allow to build the new data sets at a lower cost by providing some guide for the annotators. And this was shown for a variety of use cases and a variety of data sources. OK, as for recommendations, these again are maybe a bit more on the technical side. Hyperspectral real measurements applied at scale can lead to powerful applications for urban material mapping. That was the first talk. There was the issue of shadows being still a problem when measuring the hyperspectral signatures of materials. Generative artifacts of super resolution models are still maybe a problem that needs to be addressed and controlled. And then for the change detection itself, which was the last part of that pipeline, there's also an interesting context of a different cost associated with omission versus commission errors. Then realistic estimation of the downsampling kernel and the influence of spectral characteristics over super resolution tasks, again, are an important area of future study, and I think I've already mentioned it in the previous slide. And finally, human in the loop can be a powerful scheme for improving the quality and volume of urban data sets, and again, this mainly has an impact on the cost of annotating data. And I think that's about it. I can now pass it to Nicolas.
Hey, good afternoon. I guess I have some slides as well. If you manage to open them. So the I think you don't like you. Yeah, I did. Yeah, no, this is it. So the session was about advancements in 3D urban modeling. So at this stage, I'd like to thank actually Mark, because I think he gave a very good overview of what's going on in this session about 3D urban modeling and advanced techniques like AI and the lack of reference data, the lack of sometimes resolution, let's say, in the data that we use. To get to the details, so here we had 6 talks. There were 2-3 talks which was, let's say, very nerdy, deep learning oriented with some kind of architecture to estimate a 3D change or to estimate build-up height coming from high resolution, like very high resolutions, Cosmos KML or TerraSAX, or either using Sentinel-1, Sentinel-2 and propose some specific architecture for that. There was also the use of WSF and some kind of analytics derived from that to understand a bit urbanization and trend for the urbanization. I think it was also mentioned by Mark before. There was also some open source framework which were also discussed by CS group people, and this software is called CARS, that enable to play a bit with multi-view stereo and do some kind of analytics and studies. And they provided the concept of semantized meshes. There was a last talk which were more about combination of modeling, Earth observation and in situ data to get the 3D surface temperature and to get the evolution along the day. So this was, let's say, the talks that we had, just a few minutes ago. So in terms of recommendation, obviously, as I mentioned, recommendation for better data. So there was the question about the usage of Cosmos KML or TerraSAX, which was also very expensive, and how we want to scale with those kind of very costly imagery that still provide high resolution information, but with a cost. So generalization capabilities and also cost effectiveness is doubtful. And of course, you can substitute that with Sentinel-1, Sentinel-2. We see some limitation, obviously. There have been some talks on using different orbit, ascending, descending for Sentinel-1, or using the seasonality of shadows for Sentinel-2. But this comes with limitation, especially for low, let's say, small buildings, for which the quality of the estimate of the height might be a bit limited with those kind of sensors, because you lack resolution and you lack information simply in the data sets. And I think, yeah, this is it for this session. I don't have much to report. This summary will be surely improved for the final version. Thanks.
Okay, and then we had yesterday 2 demo areas that should have happened in James Cook. But as some of you know, the interest was so much, and at the end we found the solution of the Magellan. So I would, the sessions were, the demo areas were on data platforms for urban applications. So I don't know if it's Maiken or Zoltan to report on the first one. No? Okay, we can go directly to the second one then. That was, always on the same topic. And here we have Zainab to report. Thank you.
I think I also have 2 or 3 slides. Okay, perfect. So I don't need my laptop. Okay, so this was supposed to be a demo session. Not all presentations were actually demonstrations, but one of the main ideas was to showcase how we can leverage digital innovation, cloud computing to provide and expose services that are useful for urban applications. So we had 4 presentations / demos. The first one was from Iklay Puria, who's I don't think he's here. But yeah, he provided a very nice overview about this initiative that I personally was not aware of, the Extended Innovation Agenda for Cities, that aims at providing integrated climate solutions with a very dynamic and, let's say, innovative approach to address global challenges, putting the evolving issues and human needs at the center, and also emphasizing the need for evolving solutions. So he had a very clear invitation to the Earth observation community to get in touch and be part of these solutions. It's not happening yet at scale, so he had a very clear invitation for everyone to get in touch if they want to be more aware of the initiative. And I hope that the slides will be provided later, because there was a QR code for the platform and whatever is developed there. We had a second presentation from Beatrice and Kavita, who I cannot see either, about the Space for Smart and Green Cities Task Force, which is an ESA initiative that aims at, again, partnering with cities and urban actors to leverage Earth observation or space assets to address their needs. So we had a very nice overview about the activities that were conducted since the launch of the task force last year here in ESRIN. We had an overview of the priority topics that were identified with these partners. And there's also a call for proposals. So Beatrice and Kavita invited both cities and solution providers to reach out if they are interested to participate. We had a third presentation from CLS, Lorenzo and Alice, about the Urban Atlas suite of products, a nice overview about the products and the updates. So here we had a nice demo as well with nice examples, for example, from the city of Rome, and an update about the technical evolutions and what's in the pipeline for the suite of products. And last but not least, a presentation from Patrick from ESA about the ESA initiative, the Green Transition Information Factories, which is again an ESA initiative that aims at bringing space solutions to the green transition and climate adaptation purposes. So we had a demonstration showcasing some of the capabilities that were developed with a focus on the sustainable cities and also energy capabilities. So some of the discussed challenges were related, for example, to the importance to report on the use of these. So we have loads of platforms, loads of services available out there, but we don't always have an assessment of their impact or their reuse. So, for example, the colleagues from Urban Atlas reported that they have no clear insights about how many cities are actively using their products, and they invited you, if you are using them, to go on their website and compile with them a use case just to showcase the use of the products. We also talked about the need for scaling mechanisms, because we have, again, all these services and platforms, but how do we scale their use among different stakeholders, different geographical areas? And we talked about how ESA is pushing in this direction to streamline both the production and the reuse of these services. Also, Pudia gave a nice overview about how the expanded innovation agenda for cities is dealing with this scaling of the services. So he highlighted the active involvement of many sectors and the need to mobilize the Earth observation community. For example, there are sectors of transports, agriculture, and maybe Earth observation can be under the large umbrella of data and technology. we also talked about what solutions actually exist and that are worth scaling and bring into the larger community. Because obviously not all great solutions find their ways to visibility, adoption, and uptake. So we reflected a bit on how best to find these solutions and to help capacitate them to scale. One other aspect related to scaling was scaling the funding, because at the end of the day, if there is a technically viable solution, the question is who will pay for it. So we talked about potential mechanisms to mobilize these funds, and Pooria again made us aware of this, for example, a $1 billion initiative and its venture philanthropic model to flow funds towards cities, and other potentially useful mechanisms to scale and streamline this funding. So I hope that the slides again will be available, because many people ask for them, and yeah, that was it.
Okay, we're running a bit late, but I do want to take the last minutes for a quick horizontal wrap-up that we've been doing with Mark to highlight some of the points that actually have already come out. I remind you all that the scope of this workshop was really to put together the different communities and put really the attention on the users. So you've already heard this morning their key recommendations. I will quickly go through these key outcomes, followed by some key actions that we see to be very concrete. So the first is closing gaps. What do we mean by this? It's clear from the cities that were in the room that there's a gap in their knowledge awareness about the Earth observation world in large, so products, tools, but also who are the key players to refer to. And on the other side, we've heard from industry that there's a problem, that the difficulty to connect to cities and to urban practitioners. So to say it short, there's a big demand, there's a big offer, but it's not clear how these two things come together. So we see as actions, and it's been mentioned throughout all the workshop, that we need to structure multi-sector connections, not only through events like this, that can be, of course, a great opportunity to put people together, but also offline. So this means also facilitating interactions in a systematic way through probably those intermediate bodies and networks of cities. We've seen ICLE, we've seen Covenant of Mayors, and there are many others out there. So this is something that ESA has on its shoulders, but it's let's say a joint effort in terms of closing these gaps. Second is building trust. We've heard from practitioners that the trust of products is essential for them to actually uptake the solutions out there, and the access to reference data is key. And here we get back to the uncertainties and accuracy of what we are proposing. So in terms of actions, and this maybe is more to the community here, is to be honest in reliability and limitations of products and tools while showing them and communicating uncertainties. It's also a matter of co-development of applications. So this means tailoring of solutions to, let's say, make sure that the trust is built through all the stages. And having also city practitioners sharing their local data, and this means also validation for many methods if we think of all the solutions that propose AI and so need training, but also validation data.
Of course, these key outcomes were done really in a rush, and we will further develop this, and we will also integrate the recommendations that we got from the users that you see on the poster here that we involve in the program committee. The last two we wanna stress and emphasize in this conclusion is first the concept of easy to use. It's something I think you are all aware. I mean, I'm talking here to the Earth observation community about the concept of analysis-ready data, because when the space agencies thought about this, it was really we knew that you researchers, you were spending half of your time preparing the data before doing your research. So we thought that it would be important for you to have analysis-ready data that doesn't not need from you to process the data. We know that we are not fully there. Some of you are still doing cloud screening, but still, I mean, the idea is to remove the burden on the processing and make and allow you to focus on your data. In the same way, we should think to have this sort of ready-to-use. We didn't put analysis-ready data, but ready-to-use data when we want to talk to cities. I mean, we should not expect that municipalities will have in-house capacities. There are some cases we saw. I was talking to the city of Vienna, and I was surprised that they have staffs where we work on the data, but in most cases they will not have that capacity. It could be that this capacity is available through what we call city practitioners. So they are the technical companies that work closely with the city, that are still sectorial in the sense that they work on urban applications, but they have at least the geospatial knowledge and sometimes also the Earth observation knowledge. So think about the use of your data and try to remove totally the burden on the processing from the city authorities and the urban practitioners. So make your products closer to decision making. And when we talk about multi-level governance, you should not always think about a city authority. At the end, these data are used at different levels, up to the global level. Also, UN Habitat needs to have some global statistics. So there are different levels of governance in the way these data can be used. And when it comes to building capacities, so don't think only about cities. Think also about these technical city practitioners that I was mentioning that can actually be a sort of a way for you to access the cities. That's one point. And the last point is, of course, the problem of knowledge sharing. And this is a problem with the cities, but also within the Earth observation community. And there is a lack of knowledge. And very often when you come to this conference, you learn about what the others do. And you say, I mean, of course, you also do your own research. I'm sure you spend a lot of time doing literature review and reading articles. But I think we should find a better way to share knowledge between you, within your community, and also with the users. The Geo Toolkit is a good example. It's really made for the urban practitioners, for the city authorities, but we should think as well of having the same knowledge sharing as well between all the developers, so that you can also leverage or build or develop on what others are doing, both in terms of data and in terms of tools. We have been thinking about this. We've been thinking about having a sort of research development environment dedicated really to urban applications. We tried a bit with the Urban Tab. We didn't manage to reach that level, but it's something on which we will take an actions. So in terms of knowledge sharing, so think of two types of knowledge sharings between the community, and then one, as a community, you want to communicate with your owners. Sorry, with your users. There's still the next slide.
Yeah, okay. Yeah, just practical information. A recording of the event will be made available as presentations. In case you do not want your presentation, you will let us know. But anyways, we will ask you consent via email. And also the summary and recommendations from all sessions will be made available and a bit more structured as many of us have done it in a rush, or actually have not done it yet. So next edition of URBIS should be late 2026, TBD. And in the between, I really, it's not a wish, it's a concrete action. We will bring these collaborations to be more structured. And so the next time I look forward to see some results from here to there, let's say. That's it, I think.
No.
No, what else?
I think we need really to congratulate Francesca for the excellent work she's been doing. Because, yeah. You might have noticed that she's already 1.5 person. And despite all of this, I think you cannot imagine the work that she's been doing. So I mean, a big applause to her. Yeah?
Thank you all. Thank you.